We should be. There we go. All right, we should be live. Hi, everybody who's with us and waiting in the chat. I see 57 of you now. Sorry, we are a little bit behind when we had planned on starting. As you can see, I am not Adrian Bowyer, and neither is Vicky, who is joining me right now. We have had a little bit of a time zone issue. And so currently working through that right now with Mr. Bowyer. And so hoping to have him on very shortly, or at the very least, be able to kind of hopefully shift some things around. So if you see me looking away, it is because I am in the process of trying to organize that. Welcome to the wonderful world of virtual and time zones and figuring all of that stuff out. So I'm going to apologize to you guys now for being a little bit later on the start than we wanted to. All right, and it looks like Mr. Bowyer will be able to join us in just a couple of minutes. Oh, fascinating YouTube, I'm sure, as you guys are watching a blank screen there for a minute as I'm typing out an email to Mr. Bowyer. Bowyer. I need to say it correctly. All right, and it does look like he's going to be able to jump on, which is going to be awesome. While we're doing that, I see lots of people active in the chat, and here I am just talking away. Vicky, is there something you want to say? Introduce yourself to people who might not know you.
Good morning, everybody. This is Vicky Somma. I'm one of the board members of the East Coast RepRap Festival. I'm greeting you from Occoquan, Virginia, which is about 30 minutes south of Washington, D.C. I guess since you're already here, you know that this is the Build Platform channel, and I am excited about our lineup that we have today. So after Adrian speaks, we're going to have E3D. They're going to be talking, and they're actually going to do like a little quiz with Makers on Tap, which might be super fun. We'll have Prusa talking, and if you caught them on the Sponsors and Exhibitor channel, they had a most delightful little mini Prusa talking on the just a really cute video. So it'll be great to see what they have in store for their longer time slot here. We also have Chelsey that will be coming up today from, and I always flip-flop it. I think it's Chaos Core Tech, but I always like to say Core Chaos Tech. She'll be one of our speakers, followed by Dave Randolph from Printed Solid, which is one of our platinum sponsors. And if you didn't see the introduction, we do have some swag to share with you, even though this is a virtual event. We do have our nice little, let me switch over here so I can make sure I'm getting it on their screen, our little virtual ERRF badges that we can mail to you. And it's sponsored by Printed Solid. And I'll go ahead in the chat, I'll put the PO box that you can send a self-addressed stamped envelope to us, and we'll send back the badge. And that's not just it. We also have virtual ERRF2020 stickers that hopefully the virtual part only applies for this year, and we will send that out to you as well. So after Printed Solid, we'll have a education roundtable. And so we have 4 educators going from the K to 12 to even college. They'll be talking about their experiences and their challenges and best practices with incorporating 3D printing into their curriculums. And I see that Adrian is already here, so maybe I should shut up and you could get to what you really want to hear this morning.
I was just going to say that, Vicky, not to cut you off, but we do have Mr. Bowyer here, and so I'm going to let Mr. Adrian Bowyer into the meeting, the Zoom room. Hopefully,
Hello.
Mr. Bowyer, thank you so much. My
Well,
apologies.
I do apologize. It seems that we've got our times an hour out across the Atlantic. I had thought it was 5 o'clock my time.
And I didn't respond. I saw the email and I didn't do the change in my head either. So I take full responsibility for that, Mr. Bowyer. I apologize.
Perhaps half and half. Right. Well, I'm happy to give my talk if you'd like me to go ahead right now.
Absolutely, Mr. Bowyer. I can tell you that as of right now, we got like 60 people who are watching and ready to hear what you have got.
Oh, right. Sorry. Wait a minute. Right. Now, with a bit of luck, you should be able to see my first slide. Is that actually the case?
I see you on video, Mr. Bowyer.
Right, but not my shared screen.
Not just yet. Nope. Have you hit you hit the share screen button? And oh,
Yeah.
there it is. Now I see it.
Oh, right. Now I can't see myself, which is not good. Oh, yes, I can. Right. Right. Okay. Oh, I don't know. Can you see the cursor from my mouse cursor? That would be useful if you can. So I can point.
Yes, we can.
Right. Okay. Good. Hello, everybody, and my apologies for being late. It was because I didn't understand how clocks work, or at least not across the Atlantic. Anyway, thank you very much for inviting me to speak this morning for you, this afternoon for me. I wanted to say a few words about moving RepRaps into production as opposed to using them for small-scale activities. I wanted to look at two aspects of that. One is making the machines more accurate, ideally without spending a lot of money, and also how to make them produce large quantities of goods without requiring a great deal of attention. Okay, so to start with, let's say a few words about accuracy. Now, people have known an awful lot about accuracy since the Industrial Revolution, and in particular, they've known that it's difficult to make an accurate machine, but it's quite easy to make a machine that's adjustable. And so there's a picture of my old lathe, which I can see, having looked at it now, that I should really have cleaned it down before I took the photo, but never mind. And arrowed, you can see just a little screw in the side of it. That screw allows you to center up the tailstock so that it's exactly aligned with the chuck on the left-hand side. So rather than make this lathe accurately, what the manufacturers did was to make it so that it was easy for people to adjust and make it accurate that way. Now, of course, we can apply the same sorts of things to RepRap machines. So, for example, here is a Delta machine that I've been working on the design of for a little while. It's quite easy to make all sorts of 3D printed items adjustable. You can see here an adjustment being done. There's my hand holding a screwdriver and a vernier caliper there. And just by twisting the screwdriver, I can alter the length of that horizontal member there and adjust it very precisely if I can measure it precisely, which I can with the calipers. To see what's going on in a little bit more detail, if we look at the CAD design for the thing, you can see that horizontal part there. And what it consists of is two sections, left and right, with the sort of purple prismatic part embedded inside them. And you put a couple of screws, self-tapping screws into that, and that holds it all together. And then you can adjust it and just rely on friction to hold it still. But relying on friction to hold it still is probably not a very good idea. So you can see that also there's a little pair of funnel-shaped holes in the top of the part there. And what they're for is so that you can pour super glue into it when you've got it adjusted just right. And because complexity is free with 3D printing, internally there are a whole load of little channels and fan-out shapes which allow the glue to spread over the surfaces inside the part once you've adjusted it. Something else you can see there is some channels in the transparent section on the left. Those are just for running wires through. It's quite a convenient thing when you're building any piece of electromechanical apparatus to remember to leave some cylindrical holes in it and just run all the wires through the printed parts rather than clipping them on afterwards. It makes for a very neat machine. But back to adjustment. This makes adjustment easy, and you can adjust the gap between the vertical columns of this Delta 3D printer to within about 10 microns fairly straightforwardly using this technique. And we can apply it also to the Delta arms, exactly the same principle is used with them. You can see them there in the picture that I showed a few moments ago. What we do with that, they have ball joints at either end. We just clamp a couple of balls in either ends of the arm when it's not on the machine, measure the distance between them, and then once again use the screwdriver, the clamping screws, and the glue to adjust the length of the arm to exactly the same as all the other arms. It doesn't actually matter in this particular case if you get the arm to any particular measurement. They just all have to be equal for the machine to work well. Right, okay. Well, there are some things that you really can't adjust. An obvious example is a screw thread. Now, if we look back in history again, just like looking at making lathes since the Industrial Revolution, we've had screw threads for an awfully long time, since about 400 before the Common Era, 400 years before the Common Era. And the vast majority of screw threads up until the Industrial Revolution, indeed pretty much all of them, were carved by hand, which is a fairly labor-intensive process. And while we're talking about it, there's a picture, incidentally, on the left of printing press by Dürer in the 16th century, and you can see there's a screw there that is forcing the printing type down onto the paper. But why are screw threads called screw threads anyway? Well, the reason for that is because the way that they were carved was like this. You literally wrapped a thread in a helix around usually a piece of wood, and then you carved it by hand using the thread as a guide to get the helix that you wanted. And as I say there, this is not really a very accurate way of doing things. So given that we can't adjust a screw thread, how are we going to go and make an accurate screw thread? Well, this again is a problem that was solved right at the beginning of the Industrial Revolution. It was solved by a bloke called Henry Maudsley, who made the first accurate screw cutting lathe. There's a picture of a couple of his lathes on the left. The top one was slightly earlier than the one at the bottom. And how did he carve an accurate lead screw? Well, he thought of two things. The first thing he thought of was a way to take a short length of screw and copy it repeatedly, so he could make a long lead screw just by carving a short piece as accurately as he could. But even he, though he was a very, very skilled craftsperson, couldn't carve that accurately. So how did he make a lead screw very accurately? Well, there's a slight, I'm going to appear to go off on a slight tangent here, but it does actually come back to the point. And that's to revisit a piece of homework I did more than half a century ago when I was 12 years old. One day in class, the physics master said, "Your homework today is to measure as accurately as you possibly can the distance between two lines in your homework books." So we all went home to figure this out. And this is my solution. What I did was I took a set square and I used that to make sure that I was measuring exactly at right angles to the gaps between the lines, or to right angles to the lines. And I had a magnifying glass which I could use so that I could see the divisions, the centimeter divisions on the set square more accurately. And I got a reasonable mark for this. I got 7 out of 10. But there was a class of 20 pupils, and none of them actually got the right answer, which we were told the next day by the physics master, which is this, and it's obvious once you think about it. And the right answer is not to measure a pair of lines, it's to measure the distance between 11 lines and divide that by 10. And of course, the result of doing that is to average the random errors that one might make with a small measurement, and thereby reduce the error overall in the resulting measurement of the gap between the lines. And this is a very simple error reducing algorithm. And as I say, nobody in the class actually thought, including me, thought of this, though of course as soon as we were all told it, it was all immediately obvious this was going to produce the most accurate answer. Well, Maudsley did exactly the same thing. He used the same trick, but he did it mechanically. The nut that runs on the thread, when he's using the thread in the lathe to copy itself and make another thread, he made that nut out of leather, and it covers several pitch lengths of the thread. And the effect of that, as the thread rotates, is to average out the errors in the individual carved parts of the thread. And once again, that averaging reduces the random errors. And so what he's done is to mechanically to produce an error reducing algorithm like the averaging algorithm that I just described. And the result of this is a more accurate thread. Incidentally, bear in mind that the actual pitch of the thread doesn't matter very much as long as it's all the same. In other words, you can always change the pitch when you're copying a thread in a lathe by changing the gearing between the rotating cutting tool, sorry, the rotating screw thread that's the lead screw, and the rotating part in which you're cutting a thread. So by changing the gearing between those two, you can change the pitch very easily. What you want is the same pitch from one end to the other, and that's what this achieves. And of course, you can repeat this trick round and round again. You can take the more accurate thread you've produced by this and put that back into the system, and then make it more accurate again by playing the same trick over and over again. And pretty much every screw thread, until we started making threads digitally fairly recently, was a descendant of this one screw thread that Maudsley made. So talk about RepRaps copying themselves. This is a thing that really copied itself around the world, literally billions of times. So we can make adjustments to some things, but for some things we need some sort of algorithmic technique in order to make the adjustment. And here we've got a mechanical algorithm, but of course one of the advantages with a RepRap machine that we got is that there's a computer sitting inside it, so we don't necessarily have to do it all using mechanisms. We might be able to do it using numbers in the machine. Okay, well, here's something that we've all seen. If we've got a bed in a RepRap machine and the bed is not quite adjusted right and we haven't quite got the right height off the bed, then prints never print properly. And I'm pretty sure everybody listening to this talk has seen this sort of thing sooner or later, and or will do sooner or later. And again, we know how to fix this problem. It's been done in most machines for some time now, and that is to probe the bed. What we do is we move over the bed in a rectangular grid, some other grid, and probe it and have some sort of mechanical or switch-based system so that we can detect where the bed is. And then we can build a map of it. And given that map, we can then have the RepRap machine adjust to slight irregularities in the bed in the software, and also to get it in exactly the right position, so we never start too high or too low. Now, we've only got a fixed number of points over the bed, of course, so that leads to a problem, namely, as the RepRap machine is moving around, given any pair of X and Y coordinates, what is the corresponding Z coordinate we want for the bed? And so that means we need some method of interpolating between the fixed number of points that we've just measured. And the usual scheme for doing this, as I'm sure many of you will be aware of, is to fit a set of triangles to all the points that we've measured in space, and then wherever we have a point that we want the Z height for, we just find out where the line vertically, as it were, from that point intersects the corresponding triangle, and that gives us the value of Z. And this is perfectly adequate for the vast majority of printing operations. And of course, what we're doing here, incidentally, is not algorithmically adjusting the machine to give us an accurate print. We're actually algorithmically adjusting our print to make it fit in the machine, which may be not necessarily what we want. If we really wanted a flat base to the object that we're printing. This is merely reproducing the errors in the non-flat bed in that object. Admittedly, it allows us to print it nicely, but if we wanted it to be really flat, then we couldn't do this. And of course, as we move up in Z, as we're printing layer upon layer upon layer, then what we can do is we can actually reduce the reliance on this particular triangular interpolation to find out what our Z values are, and simply make an average between that value and the value of a flat plane through all those points. And if we gradually mix those two together, eventually we end up printing on a perfectly flat plane, perhaps 10 millimeters above the original bed or whatever it is. So even though we started off with something that's not quite flat because the bed wasn't quite flat, by the time we come to print the top of the object, we will actually be printing that as a flat plane. And of course, the other thing that this gives us is it tells us where the Z-axis really is. And the Z-axis is simply the line that's perpendicular to the average plane that runs through all those points. Let's look at another method of solving this problem, of this interpolation problem, which is kind of crazy to apply to a RepRap machine, but the reason why I want to look at it will become apparent in a little while. It's this. Suppose instead of just fitting a bunch of triangles, we used a technique called natural neighbor interpolation. Now, this was invented about 30 years ago by a friend of mine, Robin Simpson. And the way it works is this. Imagine we look at a plan view of the RepRap bed, and that's a plan view on the left. And let's suppose that in the center of each of those green discs that you can see, we know the Z value. Those are our probe points. We've probed the middle of those green discs. The reason for the size of the disc will become apparent in a moment. What we do is we construct the Voronoi diagram of all the points we've probed, which are the gray lines you can see there. And then let's suppose we want to know the Z value at some arbitrary point not measured, the black points that you can see in the middle of the picture there. How do we find the Z value at that point? Well, what we do is we find out what its Voronoi territory would be if we were to put it into the structure, which is the blue polygon that you can see there. And we then look at the area it steals from each of the territories of the green points where we've actually got data. And we take a weighted average of the heights of those points, weighted by the amount of area that we've stolen. And that's what the numbers we can see on those points are, and also the diameter of the green discs. And this, as a method of working out Z values, has a great advantage over the triangles that we just saw, in that it doesn't put sharp creases in the surface that we're generating. It generates a smooth surface. And in general, it would give us a much more accurate interpolant than just simple triangles. Now, if we were to do this in a RepRap machine just to fix the problem of the bed not being quite flat, it would be really a bit of a sledgehammer to crack a nut. We'd have to do an awful lot of calculation inside the processor in the RepRap machine. Now, okay, most of them are 32 bits these days, so we can probably manage it, but nonetheless, it would require a great deal of resources in the machine in order to do the calculation. And to be honest, it's not really necessary to get a decent print, because remember, we're not actually correcting the print. We're merely making the print fit the machine and introducing small errors into it in order to make it actually physically work and make it actually physically stick to the bed. So we don't want to use this for solving the problem we've just described, but the reason I introduced it is that it's going to be very useful for something that I'm going to mention in a minute. So remember this idea of stealing areas of a Voronoi diagram in order to construct a very smooth, nicely behaved interpolation between some values. Okay. Well, the bed's not flat, we've just seen. What are we going to do about the rest of the machine? Well, this is a picture of a coordinate measuring machine. They're very expensive normally, very accurately constructed. The big horizontal slab you can see at the bottom of the machine there is made of artificial granite, so it's very dimensionally stable. And these sorts of things are used industrially in order to do error checking and quality control on manufactured parts. You can see there's a little probe in the middle of the machine there, which you can barely see, but we can look at the probe in a little more detail. The way that works is really very simple. It consists of 3 cylinders resting on 6 spheres and held against them with a spring and a spherical probe. And whenever the probe touches something, it breaks the electrical contact between the spheres and the cylinders, which are all wired in series, and that generates an electrical signal. And of course, many RepRap machines these days use exactly the same mechanism as the probing mechanism, so for when the nozzle touches the bed for doing the probing that we've just seen. Okay, so that's a coordinate measuring machine. Why would we want to turn our RepRap into a coordinate measuring machine? Well, it turns out that if we do that, not only can we measure things, which might be a useful thing to do, but it also turns out that we can use the very fact that it can measure things in order to use it to correct itself. And that's what I want to look at next. First of all, how do we get our RepRap machine to have a ball on the end instead of its nozzle? Well, that's really easy. What you do is you take one of the balls that tend to be used for Delta machines, which of course have little threaded holes in them so that they can be attached to the ends of the arms of the Delta machine. If you take one of those balls and you warm the RepRap machine up and you simply hold the ball against the nozzle, extrude a few millimeters of plastic and then turn the hot end off, what happens is the plastic solidifies and you've got the ball in the end of the machine stuck there, and now you can use it as a coordinate measuring machine simply by bumping that ball against objects that you might want to measure. And here's an illustration of that happening. Ignore the slight jerkiness, that's just in the video. Here it goes again on a loop. So what's happening there is the RepRap machine is moving sideways, and as soon as it detects the electrical contacts are broken, it bounces back off, and we've taken a measurement of the side of that aluminium block that I've simply put on the base of the machine. So we can measure things with the RepRap machine, and that's quite a useful thing to be able to do, but we can also use it to sort of, in a way, do the reverse. Suppose that we were to make a set of calibration pieces shaped rather like this. And what these are a set of reasonably thin rectangular blocks and a rectangular block with a series of castellations upon it. The way in which we now use this to calibrate the RepRap machine is that we put the castellated block on the bed of the machine, and we use the probe that we've just manufactured on the nozzle, which, as I say, in many cases already have a probe mechanism built into it. We probe all those little projections and we record the measurements. And then we stack that up on one of the flat plates, and we do the same thing again, shall we say a centimeter higher. And then we can do that right up through the volume of the machine. And of course, making accurate parts, which are only going to be used once, is not a very difficult or expensive process because, of course, they can be shared among a very large number of machines. And they're rather like the traditional idea, for example, of slit gauges, which are very, very accurate thickness gauges that are used in all sorts of engineering applications. This particular gauge, if we can call it that, would be designed purely for calibrating RepRaps, and it would be made, as I say, very accurately. So what we've done is we've measured the sides of all of those projecting little cubes, like little sugar cubes on the top of the plate. And we've done that all the way up through the machine. And because we know the dimensions of the accurate calibration piece, and we can record the position that the RepRap machine thought it was in when it was probing each of those faces and also the tops of the faces, the tops of the cubes as well, we can construct a sort of three-dimensional map of all the errors in the machine. Basically, for each point in the machine that we've probed, we've got a little vector in space which tells us, well, at this point, the machine thinks it's there, but actually it's here. And so we've got that jumble of variable length matchsticks, if you like, in space, which tells us all of the errors in the entire working volume of the RepRap machine. But of course, it's only at those fixed points that we probed. But now we can come back to our interpolation technique, but this time we want to use it to, instead of fixing the non-flatness of the bed to fix all the volume of the RepRap machine. In other words, given any XYZ position that we want, what is the X prime, Y prime, Z prime position that we need to drive the machine to so that it's actually where we want it to be? Now we can use the natural neighbor interpolation technique again, but this time in 3 dimensions. And there's a picture of a 3-dimensional Voronoi diagram, which as you can see looks rather complicated, but it's not so complicated that a computer can't handle it. And we can do the interpolation on the fly, and we can correct everything that was wrong inside the machine and make the machine much more accurate. For example, if we had a delta machine and the vertical columns were slightly twisted or they weren't quite parallel, all of those sorts of errors would be compensated for in this one single technique. So we've now got a mechanism, given the accurate calibration piece, of making the interior of the RepRap volume well known and well calibrated so that the machine actually moves out in real 3-dimensional, moves around in actual real 3-dimensional space and corrects everything, literally everything, that's erroneous in the way that the machine works. And what's more, it's done entirely in software. What we've done is we've got to record this information, which is straightforward, obviously, and then we've got to use it inside the computer that's driving the RepRap in order to make the compensation as the machine is actually working to print something. Now, unlike fixing the problem with the bed, where, as I said, we've adjusted our part in order to fit the inaccuracies of the machine, what this allows us to do is to adjust our machine in order to compensate for its own inaccuracies and to make accurate parts rather than inaccurate ones. Okay, now my computer will go to the next slide. There we go. So, a repeatable, and I'll come back to repeatable in a moment, a repeatable adjustable RepRap is easier to make than an accurate one. It's much easier to print those horizontal parts of that delta machine that I showed you earlier and get them reasonably accurate, but then adjust them later to get the machine very accurate indeed. Now, for this to be useful, the machine has to be rigid. It mustn't have any backlash, and it must behave repeatably. In other words, everything needs to work the same way every time when it's moving around. But that's not too difficult to achieve. It's a little bit like having an anti-backlash nut or anti-backlash gears. It can be achieved with springs and spring loadings and that sort of thing. So if we make our RepRap adjustable and repeatable, that makes it much easier to manufacture than an accurate one. And then, if we're clever, we can do most of the adjustments in software on the fly as we're printing things to make the machine as accurate as we possibly can, given the way that it moves mechanically. And that's something that hasn't been done yet. It's an idea I had a little while ago. I haven't implemented it, but I can see no mathematical or engineering reason why it shouldn't work. Okay. Let's look at production now. Now we've had a little word about accuracy. And let's look at using RepRap machines instead of just to produce one-offs or a single bed full of parts in continuous production. Well, here's something that you all know about. It's Joe Prusa's print farm. And one obvious way to do continuous production is just to have a lot of RepRaps. Our advantage here is that they're cheap and they copy themselves. So achieving this is not too difficult. But they do need people to attend to them, though. So you can achieve quite a lot of production, and this is precisely what Joe does, by just having a lot of machines. But this is not really unattended continuous production. If we're going to do this, though, obviously we've got to make the people who are working the machines make their jobs as easy as possible. And an innovation that I think Joe introduced, though I may be corrected here, was the idea of having a flexible magnetic print bed. So what he does is he has a heated bed which has got permanent magnets embedded in it, and then he puts a flexible steel sheet on that with a coating which 3D printing material, usually PLA, will stick to. And the advantage of this is that the machine, when it's finished, the person attending to it can come along. They can simply lift the magnetically clamped sheet off the bed of the machine because it's only held on by magnets. And then when they flex the sheet, of course, the parts which are rigid detach from the bed and can easily be removed. So that certainly makes production easy from the point of view of the person who has to attend the machine. Now, a little while ago, I invented a variation on this, which is instead of having permanents in the magnets in the bed, replace them with electromagnets and use, given that we're going to be passing electricity through them, use those as the heaters too, because usually we need a heated bed to get good adhesion and no curl on the edge of prints, as you all know. So what we could do here is we could have an aluminium spreader. That's the transparent rectangular sheet that you can see here. Underneath that, we'd have a series of coils with ferrite or soft iron cores. And we'd use the ordinary RepRap machine's heater drive circuit to drive all those magnets. Now, of course, if we were to do that, using conventional bang-bang thermostatic control to get the bed at the right temperature, it wouldn't work because the magnets would keep turning themselves off when the bed was too hot. So what we'd need to do is to drive it with pulse width modulation at a fairly high frequency, and then simply pass that through a low-pass filter to drive the magnets essentially with DC current. And then the magnets would clamp permanently, the bed would be heated to the right temperature. But the important thing we can do here now is we can detach the steel sheet that clamps on with no force, because obviously as soon as we turn the heaters off, the magnetic field collapses and there's no force holding the parts and the thin steel sheet onto the bed. And in particular, that means that we could actually load the sheet and unload it automatically. We could arrange for a little robot arm or simply a simple push mechanism, which could in fact be one of the movements of one of the axes of the machine itself, to push the entire steel sheet off the now non-magnetized bed with all the parts on it into a bin or whatever. And it could also then drag another sheet onto the bed and start printing again. And it wouldn't be very difficult to set up a mechanism that would allow that all to be done entirely automatically without anybody attending it. There's been some argument recently about the idea of conveyor belt beds in 3D printers. So I thought that we'd look at continuous unattended production using conveyor belts inside the machine. And as far as I'm aware, this is the first occurrence of this idea. This is from the RepRap blog on November 24th, 2008. And the idea of printing on a continuous belt, as I say, first appeared here, I think, and the idea was by my then research student, Ed Sells. And the little diagram that I circled in red at the bottom there is simply a picture of a continuous belt RepRap. And the great advantage, of course, of the continuous belt, if you can make it, is that when you've printed a part on it, when you roll the belt forwards, then as soon as it goes over the cylindrical roller, that detaches the printed part from the belt, and you can drop it onto a conveyor belt, a separate conveyor belt, or you can drop it into a bucket or whatever, and then print something else. So the belt moving forms one of the axes of the machine, we say the y-axis, and then the machine has the z-axis and the x-axis using conventional mechanics as with any other machine. But more recently, we've had the idea of inclining the print head at 45 degrees or at an angle to a continuous belt. And this is one example of these. This is the White Knight machine, which I think was at the East Coast RepRap Festival last year, if I'm not mistaken. Now, the nice thing here is that the belt only ever moves in one direction. When you're printing on it, you're printing at an angle of 45 degrees, and that print angle means that the belt is only, in this picture, moving towards you. So you can print a series of items continuously, and they're continuously falling off the end of the bed. But you can do rather more than that. If you arrange to have a set of rollers standing in front of the machine, you can print some very long objects indeed. Here's a picture that was tweeted a few days ago of a 6-meter long print printed in one of these machines, which is a really very impressive achievement indeed. So this 45-degree, well, it's no longer a Z-axis, which is why I put Z in quotes there. This 45-degree Z-axis with a continuous bolt production is really a very clever innovation, and I think it's an elegant idea. Okay, so this, together with the other things that I've spoken about over the last half hour or more, are ways of making the machine accurate and ways of making the machine work continuously and unattended, which are the requirements we need for using it for large-scale production. But I want to end with an idea of going beyond accuracy altogether. In other words, we've got this idea that we need to make accurate parts for engineering because that's what we've done, as I say, more or less since the Industrial Revolution, if not before. But do we still need to do that? Let's consider that as the final question that we might look at. Here are some M6 cap screws from Shenzhen in China. If I buy those and then I buy some M6 nuts made from Birmingham just up the road, then they all fit together. And the reason that they all fit together is, again, back to Henry Maudsley and his very well carefully engineered screw thread, and also Joseph Whitworth, a rough contemporary of him, who was the person who had the idea of standardizing screw threads. And of course, if we've got a standard system of measurement and we standardize parts, then they fit together. And we don't even have to worry about where they were made, because we know we can buy nuts from one place and cap screws from another, and they will all go together. And that's been the mainstay of engineering for 200 years or more. The idea of standardization and repeatability in parts so that everything accurately goes together. But we don't always, in every sphere of life, need things to work this way. Let's suppose we have a heart from some unfortunate motorbike rider who met with an accident. And let's suppose we have a 55-year-old accountant who needs a heart. Then the young motorbike rider, regrettably, his family may say, well, some good must come of this tragedy. Yes, we were happy to use his organs for transplant. And we can put his heart into a 55-year-old, and they fit together too. But of course, there's no dimensional accuracy here at all. Every two people's, even identical twins' hearts are not the same in mechanical dimensions. They don't work exactly the same way. They don't have exactly the same layout of nerves. They don't have the same layout of capillaries to get blood to all the little parts of them and so on. But nonetheless, because of the extraordinary adaptability of biological systems, we can transplant a heart from one dead human being into a live human being, and that live human being will continue to live in a way that they wouldn't have had they not been able to have this operation. And we do need some sort of fit. We need molecular fit. By that I mean the person who is receiving the heart needs to have a similar immune system to the person who is donating it. They need to have the same blood groups and so on. But we can reduce the requirements for that fit using drugs. So, for example, the drug cyclosporin relaxes the required tolerance in engineering terms of the molecular fit that's needed. But we don't need mechanical fit at all within reason. We can put anybody's heart, regardless of its precise dimensions, into any other person. And if we move into the plant world, then neither molecular nor mechanical fit are required. We can graft plants together with enormous amounts of differences between them. All we basically have to do is to cut the surfaces of one plant and cut the surfaces of corresponding other bit of rootstock, stick the two together, bind the whole thing together, and they will grow together. And of course, this is the basis of the whole fruit tree industry, where they put and they have a good strong rootstock, but those roots won't produce particularly good fruit, so they graft onto that rootstock a different tree that will produce the fruit that they want. So in biology, we don't need all this accuracy that we have so that M6 screws fit M6 nuts and so on. We can put pretty much anything together, and it will still work as long as we're cognizant of exactly what's going on at the molecular level. Well, let's finish with a challenge then. Having seen what biology can do, let's look at where we are in making things without possibly needing to make them accurately. You'll all have heard of or read bits of GPT-3 generated text. It's a very, very large AI that's essentially been fed the whole internet as its teaching resource material, and it will generate realistic conversations, realistic articles that really are almost impossible to tell apart from something written by a human being. But it will also generate code. So for example, we have a bit of HTML stroke CSS code on the left, which was generated entirely automatically. You can get this AI system to look at a whole load of code and then use the models that it builds in that way in order to generate novel code for itself. Now, of course, we can use code to generate three-dimensional objects to be printed. On the right is a piece of Python which makes a box. Now, this Python was written by a person. In fact, it was written by this person, me, and it's a very small part of a program, about a tenth of a program that makes a parametric box with four self-tapping screws. It's a convenient program to have around. If I need a box or anything, I just put the dimensions of the box into this Python program, and it gives me a three-dimensional model of one. I print it, and then I've got a box, put a piece of electronics in, or whatever it might be. I don't have to think twice about it, having written it. But of course, if GPT-3 can generate code, it can generate Python. Indeed, GPT-3 works in Python. So here's the challenge, which is to teach GPT-3 to anticipate geometry by showing it a whole load of CAD files and the corresponding, for example, step files that go with them and so on. And then use that to see if we can build a RepRap or indeed any manufacturing machine that can scan one part of an existing machine and then automatically print a functional different part of the machine to fit it. Now, if you think about it, if we can do this, we don't actually need things to be accurate anymore, because we can fit anything to anything and have it still work. We can have screw threads that are not quite right, as long as the machine can accurately measure them, and then the AI can go away and generate the part that will fit the thing we've actually measured to achieve the function we want, as opposed to working with standard parts and standard dimensions. Now, the result of doing this would be that we would find it very easy to repair things. For example, we'd find it very easy to modify existing machines in new ways because we could always fit things to those machines. But we drift away from the idea of standardization and the need for accuracy in the parts that we make. So that's pretty much what I wanted to say. I've sped myself up a little bit because I can see that it's 7 minutes to the hour, and so I just about managed to get into my allotted time, even though I was late, for which a final apology. So thank you all very, very much.
Oh, there we go. Wasn't able to pull it up. Mr. Bowyer, or Dr. Bowyer, it just
Hello.
Amazing. I'm looking at the chat and people are just commenting and blown away. And I will say, I could let Vicky say it because she's here as well, one of our co-hosts, one of the co-founders. She was blown away by what you were talking about.
Oh, that's great. Thank you.
So absolutely fascinating. And I've loved watching people in the chat kind of talk about what's going on there. Dr. Bowyer does have a couple minutes left. Are there questions, or would you be willing to answer some questions, Dr. Bowyer?
If anyone wants to chip in a question, I'll do my best to answer it, of course.
All right, I am looking really quick. Definitely some comments about the better proliferation of belt printing. And what was the talking there? There's a number of thank yous, Dr. Bowyer, for sharing the time and the knowledge. I am just moving back really quickly to see if there are any. Let me actually pull Vicky in here as well, just to see people asking you to keep going, because I think they'd be willing to listen to you all day. But
well, regrettably, that's my final slide. timed it when I practiced it. It took an hour, but as I say, I spoke a little faster than I normally do, just because I knew I was late. So there we go.
I personally think you did amazing, and I'm going to apologize yet again for the confusion. I should have checked on the time, and I heard you at the beginning of the presentation say, you don't know how to use or understand a clock in across the Atlantic. I'll tell you, Dr. Bowyer, I'm not sure that we know how to use clocks at this point. It's just been one of those things.
Yes, I'm fairly sure that I asked the following question, which was to ask Alexa what time 11 o'clock was in my time, and I thought it got it right. But anyway, there we go. That was the actual source. We can blame Amazon.
I'm completely fine with that. There was a question, Dr. Bowyer, from Mark Peters. Will we lose economy of scale with the last idea that you had presented?
In a way, yes, because everything would have to be adaptive. But it would depend on how cheap it was to do. Notice, for example, that most of what I've just described in the very last idea would be in software, which is sort of free. To execute. Now, of course, it's not CPU time costs money, and disk space costs money, and machines cost money, but it is really a very low cost resource. And so what we're doing is we're substituting for the need for accuracy a sort of versatility that comes about if we let the machine do the adjustment all the time. Now, we could do that, and we could do it at scale. I don't see any reason why it shouldn't be scaled up, assuming we've got enough processors to run the AI. But it would mean that what we can't do then is to fit things arbitrarily together. If it became widespread, people make things, but they'd all be individual things, and you wouldn't be able to take item A and fit it to item B when they would normally be expected to fit together. But on the other hand, you would be able to make an item C to replace item B that would fit. So, I don't think it's universally applicable, but it strikes me that if biology does something, it's probably quite a good idea to take notice of what it does. And biology doesn't require mechanical fit in pretty much anything it does. There are very small bits of biology that do. For example, spherical joints in your body really do have to be spheres to work. Your eye lenses do really have to be lens shaped in order to focus an image, and so on. But most things in biology don't require mechanical fit like that.
Excellent. I see there's a little bit of time left. There was another question that came through. So Dr. Bowyer, if you would indulge one more.
Yeah.
The question was, well, there are actually two questions that came through. I think we will only have time for one. So I'll ask one. Do you think that more powerful RepRap mainboards will lead to better methods of bed leveling, which were previously impossible with low-powered boards?
Well, the one that I mentioned would require a fairly heavyweight processor because you'd have to be constructing Voronoi diagrams on the fly as the machine was printing. Now, I don't see that as being impossible, particularly as the number of points that you're actually constructing the diagram for would be not very great. So yes, you do require a fairly heavyweight board in order to do that sort of trick. But once you've got plenty of processing power, you can start looking at other things to do with it, as it were, like this final idea that I came up with. You could, for example, run an entire AI in one. I mean, I don't know if you can see this. This is a camera, except it's not just a camera. There's a complete AI in here, which does image recognition. So I can point this at a room and it'll put rectangles around everything in the room, and right, chair, desk, screen, keyboard, person, and so on against all of those. And that, as I say, it's not actually in a conventional processor, it's in an FPGA in this device. So once we start getting that sort of power into RepRap machines, we can do all sorts of clever on-the-fly adjustments that we can't do at the moment.
Excellent. Thank you very much, Dr. Bowyer. There are definitely more questions that are coming in, and I know that people have a lot that they want to be asking. I see some from RC Maniac. I see some from others as well. I will point people towards the Discord server, and Vicky, maybe you can. Oh, I saw Nightbot just put a link in there for Discord. There is a server on Discord, or a section on Discord, to ask questions or discuss the build platform. And so maybe we'll have an opportunity to interact a little bit more there, and you guys can ask questions there. But I want to be very respectful of Dr. Bowyer's time. Dr. Bowyer. I know I got it right. Bowyer.
Yeah,
I apologize for butchering your name and changing the
No, you
pronunciation.
haven't. You got it right. Well, put it this way. I certainly haven't noticed if you have. So, so I think you probably got it right, or at least as right as I get it.
I do remember asking you about that last year before introducing you and
Yep.
practicing it over and over again, because yeah.
Oh, well, it obviously sunk in. It sounds like my entire career as a student, where I'd learned something and I wouldn't really understand it, but I discovered I did understand it when I came back to it a year later. So you've obviously, it sunk in the intervening year, and you now got it right.
Well, we very much appreciate your time, Dr. Bowyer.
Okay.
Thank you so much. Thank you for coming on in the rush after the confusion about everything. I want to be very respectful for your time, so I'm going to let you go and enjoy the rest of Saturday afternoon and evening, hopefully with family and friends.
Indeed, yes. I think my wife is preparing supper as we speak, so I shall go and be eating that very shortly. So,
Excellent.
Well, thank you everybody for listening. Thank you for the invitation to virtually attend, and it's been a great pleasure. Incidentally, the slides I've just presented, I'm perfectly happy to put those for you to put those online. I'll email them to you or whatever you like.
Oh, that would be fantastic. Yeah, if you want to email those to me, I would make sure to get them up.
Okay, I'll do. But I'll send you a link to somewhere you can download them.
Awesome. Thank you so much.
Okay, right.
Bye.
Right. Goodbye, everybody. Thank you for listening.
Bye. And we are going to now bring in E3D and Sam in just a second here.
Hello.
Hello, Sam. How are you?
I'm very good. How are you doing?
I'm doing well. Give me just a second here. We're gonna give you the full screen.
Perfect.
I'm gonna do that. Ah, there you are, Sam.
Here we are. Is my screen sharing or?
I am just seeing video at the moment. I am not seeing screen share yet.
Okay. Well, I thought maybe I'd just explain to start with. This was originally it was originally branded as the pub quiz, sort of hosted by Natalie, but last minute crisis came up. Her laptop was playing up, and we ended up in a situation where, well, I have to host the pub quiz, to be honest. But no problems there. I work well under pressure, so you may have to bear with me regarding the Zoom sort of things because I'm a little new to this. But how do I screen share?
All right, down at the bottom of your Zoom window, you should have a green arrow in the middle that says screen share.
Okie dokie.
If you click on that, it'll bring up another window that should have a number of options for you as to what it is you want to share. Click on that, and then it should begin sharing for you.
Ah, here we go. Okie dokie. Share that. Share computer sound. Yep. All right.
And there we go. We got your screen sharing.
Fantastic. Okay.
Let me ask Sam, before you jump into it, I know Natalie had kind of sent us a link for the surveys on SurveyMonkeys.
Yes.
As you're going through the pub quiz, do you want me to be putting those in or sending that out via the YouTube chat so people can go to the SurveyMonkey and respond?
That would be fantastic. Yeah. So that's actually that's how you enter the quiz. It's not just a quiz for fun. Well, I suppose it is for fun, but at the same time, we are offering a prize of we're doing a custom. I'm not sure if you're familiar with our nozzle fun packs and pro packs. We're doing a prize for this event, which is, we're calling it the Ulti Pack. See, the working title for Nozzle X internally was the Ulti Nozzle. And then we came out with the sort of the brand name and stuff later on. But it's going to be 5 Nozzle X's in one pack of various sizes. So you can sort of try out a range of different sizes, but you can get the smoothing effect that Nozzle X offers. We're going to be offering 3 of them out to the highest scoring people. The quiz is a bit of fun. There's there's questions about E3D. There's a few questions about RepRap. There's some guest questions that have been kindly given to us by the Makers on Tap team. And there's some sort of generic pub quiz questions to go with the traditional British pub quiz style. Anywho, without further ado, I suppose I can get started. Okie dokie. So round 1 is questions all about E3D. A lot of these questions, you are able to find the answers to them if you go on our website and do some digging. Oh, something else I didn't make entirely clear is that the pub quiz can be entered at any given point across the entire weekend. We'll probably put out the results sometime next week and announce our winners then. But this live stream sort of spot is just a bit of fun if you do want to follow along and play the pub quiz. Alternatively, if you don't have the time now or you want to go and check out the Creality talk, totally understands. Creality at ERRF, that's crazy. But you can do it now or you can do it then. It's totally up to you. So, anywho, round 1, all about E3D. So because it's required for SurveyMonkey and so we can actually find you and contact you afterwards, round 1 is sort of telling us about yourself, i.e. what's your name, what country are you from? I'm from the UK. What's your email address? I'm not giving you that, but if you guys want to enter, you'll have to put that in. Anywho. Who are the 3 founders of E3D? Now, obviously, we all know about Sanjay, and the other 2 founders sometimes go a little overlooked in the community, and that's sad. That's a bit sad, but hopefully, if you know the right answer, you can put it in. So the question is, who are the founders of E3D? You can either have Josh, Ben, and Sanjay, Sanjay, Dave, and Josh, Dave, Sanjay, and Joe, or Sanjay, Joe, and Dan. And as I said, there's the link, the SurveyMonkey link is going to be at the bottom the entire time. It should be getting pushed along on the Nightbot as well. So you should just be able to click the link if you do want to enter. Question number 3. How many motors will you find in a fully kitted out tool changer? Is it 4, 6, 7, or 1024? So that's how many motors would you find in a fully kitted out tool changer? 4, 6, 7, or 1024? Next question. Which printer from the early days of RepRap is named after an Austrian scientist? Is it the Doppler 80, the Mendel 90, the Freud 80, or the Kaplan 90? So to repeat, that's which printer from the early days of RepRap is named after an Austrian scientist? Is it the Doppler 80, the Mendel 90, the Freud 80, or the Kaplan 90? Question 5, who is the father of the RepRap project? Now, if you've only just joined, you may be at a slight disadvantage here, because this chap just did a talk just before me. It's an honor to be on a live stream straight after Adrian. Is it Adrian Edmondson, Adrian Brody, Adrian Bowyer, or Adrian San Miguel del Castillo? I'll repeat those answers. Adrian Edmondson, Adrian Brody, Adrian Bowyer, or Adrian San Miguel del Castillo? And next question. What does the E in E3D stand for? All of these answers sort of work, but only one is the correct one. Is it excellent, entertaining, education, or ergonomic? I'll repeat those answers. excellent, entertaining, education, or ergonomic? Where was the first E3D headquarters? Was it in Oxfordshire? Was it on the Isle of Wight? Was it in Geldermalsen or the University of Bath? So that's Oxfordshire, Isle of Wight, Geldermalsen, or the University of Bath. What was the former use of the first E3D HQ? Did it used to be a chicken shed, a pig farm, a donkey sanctuary, or a gin distillery? That's a chicken shed, a pig farm, a donkey sanctuary, or a gin distillery. All right, moving on. Round 2, it's even more about E3D. What is the smallest nozzle size available for sale on e3d-online.com? Is it 0.1, a 0.15, a 0.2, a 0.4, or a 0.6 mil? Here's a clue, that picture on the screen is it. So if you got some calipers to your monitor, you might be able to get the technical drawings up. I don't know. Anyway, the answers are 0.1, 0.15, 0.2, 0.4, or 0.6. Next question. How long did it take for E3D to raise the funds for the Big Box Kickstarter campaign? This is years ago now. And if you remember the Big Box, props to you. That was before my time even. So to me, it's like it's a printer of legend. Was it 3 hours, 27 hours, 127 hours, or 10 years? Was it 3 hours, 27 hours, 127 hours, or 10 years? Next question. Which 3 of these mythical creatures are also the names of E3D products? There's Kraken, Cthulhu, a Griffin, Cyclops, Unicorn, Titan, or El Polo Diablo? That's Kraken, Cthulhu, Griffin, Cyclops, Unicorn, Titan, or El Polo Diablo? All right, next question. What is the maximum recommended operating temperature of the E3D's high temperature heated beds? Fun fact, that's one of the first products I was involved in the launch of back in late 2018, I do believe. So is it 200 degrees Celsius, 250 degrees Celsius, 9,001 degrees Celsius, so, you know, over 9,000, or 120 degrees Celsius? That's 200 degrees, 250 degrees Celsius, 9,001 degrees Celsius, or 120 degrees Celsius. Another fun fact about the high temperature heated beds is they can reach temperatures of 100 C in about 80 seconds. So pretty fast. It's partially because their mains powered, but still pretty cool, I think. Next question. Who designed E3D's official mascot, Rory McRawface the Lion? Was it Luby, Floelastic, Robogon, or Emmet? Is that Luby, Floelastic, Robogon, or Emmet? Next question. Name 3 manufacturers that use E3D hot ends as standard in their printers. For this, we're saying, obviously you can stick E3D in essentially any printer that you like, but these manufacturers work with us directly and use they use our hot ends as a standard in their printer. So when the printer arrives, it already has an E3D hot end inside it. We have BCN3D, Prusa, Creality, Ultimaker, MakerBot, FlashForge, Lulzbot, and Zortrax. That's BCN3D, Prusa, Creality, Ultimaker, MakerBot, FlashForge, Lulzbot, or Zortrax. Next question. how many nationalities do we have working at E3D? I don't even know the answer to this, but it's a large number. That's a clue. we have, to be honest, hired a lot of people over the lockdown period. So and because of all the working from home and stuff that goes on, I'm losing track of, you know, all the new people that we have at the company. Anyway, the answers are 2, 5, 7, or 10. That's 2, 5, 7, or 10. Next question. This is the Makers on Tap round. I organised this with Joe last week. Joe, I messaged Joe Spania from Makers on Tap saying, hey, we're doing a pub quiz. It's kind of beer related. Makers on Tap, it's kind of beer related. Maybe we should collab on this in some way. And Joe said, yeah, that'd be fantastic if in return you can give us someone for our VERRF After Dark podcast. So we do have Andy, who's the main engineer who worked on the Fusion 360 plugin for ASMBL. He'll be on at 7:20, which is 1:20 a.m. our time. So he's dedicated there with that. But without further ado, I'll start the Makers on Tap round. So let me just move myself. Hang on, here we go.
Hey guys, Joe here from Makers on Tap with your next question. Who was the original creator of the RepRap bindle?
So I'll repeat that.
Hey guys, Joe here from Makers on Tap with your next question. Who was the original creator of the RepRap bindle?
So who is the creator of the RepRap bindle? If you've watched my their YouTube video I've made exclusively for VERRF, this would be, it is noted in there. So if you need the answer, you can go and check that out. It's available on our Discord or on our YouTube channel. Is it Adrian Bowyer, Ed Sells, Vic Oliver, or Stephen Hawking? Was it Adrian Bowyer, Ed Sells, Vic Oliver, or Stephen Hawking? Next question. What was a RepRap printer made from random bits and pieces that you'd find around the house called? Oh, I just remembered. Sorry, Joe was supposed to ask the question. Apologies.
For the next question, what were early RepRaps that were built from common household objects like drawer slides and boards and maybe even hinges called?
So I'll repeat that.
For the next question, what were early RepRaps that were built from common household objects like drawer slides and boards and maybe even hinges called?
So you heard that. Was it the Rep Slack, the Rep Strap, the Rep Crap, or the Rep Trap? This information is available on the RepRap wiki page if you do want to check that out. I do recommend it, by the way. I spent a lot of time on it revising for the video that I've made, and it's fascinating. There's a lot of very interesting stuff there. Anywho, next question.
Hey, it's Aaron from Makers on Tap. For my question, what did Billy Rubin call armadillos on her episode of the podcast? Hey, it's Aaron from Makers on Tap. For my question, what did Billy Rubin call armadillos on her episode of the podcast?
What did Billy Rubin call armadillos on her episode of Makers on Tap? Did she call them horse donkeys, turtle bunnies, fish kittens, or tortoise rabbits? Is it horse donkeys, turtle bunnies, fish kittens, or tortoise rabbits? All right, on to the next question.
Hey, it's Aaron again. What makerspace did the Makers on Tap podcast start out of?
I'll repeat that.
Hey, it's Aaron again. What makerspace did the Makers on Tap podcast start out of?
That's it. Which makerspace did the Makers on Tap podcast start out of? Is it River City Labs, Streamtown Labs, Waterfall Village Labs, or Oxbow Lake Hamlet Labs? That's River City Labs, Streamtown Labs, Waterfall Village Labs, or Oxbow Lake Hamlet Labs. Next question.
Hi, Chris with Makers on Tap here to give you your next trivia question. In this episode about unrealistic expectations, Aaron and I kept drunkenly referring to Joe as this spiritual leader and shouting this phrase. Hi, Chris with Makers on Tap here to give you your next trivia question. In this episode about unrealistic expectations, Aaron and I kept drunkenly referring to Joe as this spiritual leader and shouting this phrase.
Okay, so which phrase was used to refer to Joe in, in Drunken Rambles? Was it tour guide, escort, Sherpa, or chaperone? Was it tour guide, escort, Sherpa, or chaperone? Next question. How does Makers on Tap, Aaron, like to store his file? Sorry, I'll probably let Chris ask that.
Hi, Chris with Makers on Tap here with your next question. A common thread throughout the mini episodes that we've been able to do has been the way that Aaron specifically likes to store his files. We've even made koozies about it. Joe and I have given him a lot of crap about it. So what is exactly that specific way that he likes to store his files?
So how does Aaron like to store his files? Does he use Git, SOD, Google Drive, or a good old-fashioned filing cabinet? Is it Git, SOD, Google Drive, or a filing cabinet? Next question. Some more E3D questions, some questions about pets, and some actual pub quiz questions. What is the name of Dave the director's dog? Now, this isn't the dog, this is just a dog meme that I enjoy. Still pretty cool dog nonetheless. Is it called Nozzle the dog, Hot End the dog, Heat Sink, or Sanjay's Little Helper? Is that Nozzle, Hot End, Heat Sink, or Sanjay's Little Helper? Next question. What was the code name that was used internally for E3D's high temperature heated beds? Was it Mordor, Viking, Hot Stuff, or Bed Out of Hell? Was it Mordor, Viking, Hot Stuff, or Bed Out of Hell? All right, next question. The Light 6's internal name was the Budgie, and why is this? Because E3D had an office budgie, because it was cheap, because it could be built on a budget, kind of sounds like budgie, or is it because Josh, the director, has a secret budgie addiction? So those answers again are because E3D had an office budgie, because it was cheap, because it could be built on a budget, or because of Josh's secret budgie addiction. Next question. Hot Reynolds, Hot Efron, and Hot Ollie. These are items that you'd found inside the E3D headquarters, but what are they? Are they purpose-designed hot tightening machines that are used by the assembly team? Are they tea and coffee making facilities at E3D? Are they posters on the wall of the director's office? Or are they code names that we're using for new products? Are they hot tightening machines used by the assembly team? Are they tea and coffee making facilities? Posters on the walls of the director's office? Or code names for new products? All right. Sadly, Natalie isn't here to do her question about her cat. But yes, Natalie would want to point out to you that we started doing these COVID bunker posts a while ago, where people were showing off sort of the setup that everyone was working from home in under the unfortunate circumstances that have happened recently. And this is one of Natalie's cats and sort of a work colleague, I suppose. At least she spends as much time with this cat as she would with a work colleague if she was at the office. So which one of Natalie's cats is this? Is it chocolate, caramel, strawberry, or upside down cat? Is it chocolate, caramel, strawberry, or upside down cat? Next question. What happened in the alternative uses for E3D products video that I created with Sanjay, April 2019? Yes, we skipped April Fool's Day this year. We had some ideas and stuff, but we just did not think it was appropriate at all to do anything under the given circumstances of the sort of the climate of the world at that point. So yeah, but next year we're gonna fool you so hard. Just you wait. Did we use a tool changer to make a full English breakfast? Did we use a super volcano to set off fireworks? Did we make a flux capacitor out of a Titan arrow? Or did we try to make a hot air balloon using only high temperature heated beds? The options here are, did we use a tool changer to make a full English breakfast? Did we use a super volcano to set off fireworks? Did we make a flux capacitor out of a Titan arrow? Or did we try to make a hot air balloon using only high temperature heated beds? All right. Looks like we're on to the proper pub quiz questions now. So what is the main ingredient that one would find in a British black pudding? Is it cheese? Is it blood, sweat, or tears? Obviously not a vegan option here. I don't know if sweat counts as vegan. I don't think so. But is it cheese, blood, sweat, or tears? Next question. What is the Queen of England's full name? Is she Liz II? Is she Elizabeth II, by the grace of God of the United Kingdom and Great Britain and Northern Ireland, and of her realms and territories, head of the Commonwealth, defender of the faith? Is she Liz II, Electric Boogaloo? Or is she the Queen? I'm not going to read them again just because of B and but is it Liz II, Elizabeth II, etc.? Liz II, Electric Boogaloo, or the Queen? Next question. What is the main character in the Harry Potter series called? Now, this is a challenging one, so I'm not expecting a lot of right answers on this one, to be honest. But is it Harry Potter, Charlie Bucket, Steve Jobs, or Peter Rabbit? So we're looking for the main character in the Harry Potter series. Is it Harry Potter, Charlie Bucket, Steve Jobs, or Peter Rabbit? All right, moving on. What colour are buses in London? Are they turquoise, blue, yellow, or red? Those answers are turquoise, blue, yellow, or red. Next question. What colour are taxis in London? Are they turquoise, blue, yellow, or black? Are they turquoise, blue, yellow, or black? What is the best breed of dog? According to E3D anyway, it's not an objective fact or anything, but this is, if you're not familiar, pub quizzes often have these sort of rounds in where we put a few little silly daft questions in, which are for fun and sort of to entertain the local punters at the pub. Anywho, is the correct answer A, corgi, B, corgi, C, corgi, or D, corgi? Now, Matt Janey, who's just joined our marketing team, he was working on these slides here, and he's assured me that only one of these answers is the correct one. So they may look identical, but answering the question on SurveyMonkey, only one's the correct one. So yeah, it's just a bit of fun, really. Next question. Oh, no more questions. Well, that was our pub quiz. So thank you for taking a part if you played along. Likewise, if you've only just tuned in like halfway through the quiz, you're very welcome to answer at any point over this weekend period where we're going to reveal the results next week. The prize is a custom product exclusively made for ERRF. You cannot buy this on the website. It is the Ulti nozzle pack, which is 5 different size nozzle X's in 1.75 or 3 mil, depending on your preference. And there's 3 of them that were given away to the highest scorers of this quiz. So as I seem to have a bit of time left, I might take advantage of this opportunity to show off my video that I made sort of exclusively for VERRF, which is a brief history of RepRap hosted by Sanjay. It did take me a lot of time, but I'm very proud of how it came out. And yeah, I'll share this to you now.
Hi, I'm Sanjay Mortimer, and I just wanted to run through the history of the RepRap project and how it led to the modern 3D printing explosion that we're seeing today. So the RepRap project was developed as a part of a University of Bath initiative by a professor called Adrian Bowyer. And he was thinking of this way back in 2004 even. And Adrian wrote a paper based on the concept of a self-replicating the RepRap project and how it chose to take this forward using a technology called FDM, or fused deposition modeling. And that tech had existed as early as 1989. And it was developed by a guy called Scott Crump. And he patented that technology and formed what is now a very successful company called Stratasys. By around the mid-2000s, the patent on FDM had expired, and this meant that Adrian was able to build his own 3D printer using parts initially printed by a true Stratasys FDM printer owned by his university. So way back in the early 2000s, 3D printers were huge, big machines. They looked like a refrigerator. They cost like really, really large amounts of money. The ones that Adrian bought were apparently 50,000 and 300,000 pound machines. So really significant, big pieces of equipment. So Adrian looked into basically replicating the technology of FDM by looking at its fundamental principles, learning from the machines he had from Stratasys, and turning it into a new 3D printer that he built from a mixture of 3D printed parts and non-3D printed parts. And he was able to replicate a functioning machine that was able to print new parts of itself for around 2% of the price of the 50,000 pound machine. So Adrian christened this printer Darwin after the father of the principles of evolution. And this printer Darwin was capable of creating 3D printed parts, but also 3D printed parts of itself. So you could build clones of a Darwin by printing on a Darwin. Based on his initial success, he kind of saw that he was off to a winner and began documenting his findings and his approaches and even his background with thought processes on a University of Bath blog. And he decided to make the entire source of the RepRap project fully open source, essentially giving free rein to anyone to use, build, or profit from that work. And the reason behind this is that Adrian basically saw it as practically futile and kind of self-defeating to create a machine intended to clone itself and then try and prevent people from using it to clone itself. It just didn't make any sense. So the most sensible approach in Adrian's mind was to make that project fully open source. So initial interest in RepRap was kind of slow, and Adrian quotes that within the first 3 years, there are only 4 RepRaps. But around 2010, there were a bunch of articles and something clicked and the popularity of RepRap kind of just exploded. And suddenly there were 2,000 RepRaps all over the world. So because of the open source nature of RepRap, eventually this led to lots of volunteers contributing their own efforts and ideas on how to kind of improve the printer and iterate and take it forward. Despite this not even really being Adrian's initial intention. The thought process behind this was not too dissimilar to how natural selection played out in Charles Darwin's Survival of the Fittest, where Only the most successful mutations, or in this case printer modifications, would go on to be adopted by the community and produce offspring, whereas the less successful modifications would die out. So the only difference that the evolution of RepRaps had to animals in the wild was RepRaps' need for a symbiotic relationship with humans in order to reproduce. Humans are responsible for helping the printers reproduce by providing them with vitamins, which are like bearings, pulleys, and even hot ends. And by assembling the RepRaps in return, the RepRaps would provide the humans with printed parts which are useful to them. The kind of symbiotic relationship is kind of inspired by and very similar to the one that bees have with flowers in the wild. The bees assist with the pollination of the flowers, and in return, the bees will receive nectar and building materials for their hives. Over the next few years, the RepRap community grew to thousands, each working on their slightly, or in some cases even drastically different methods to improve on Darwin's initial design. They were designing their own printers based on Darwin and sharing their findings and documenting their thought processes on their own blogs, much like Adrian was as they went. So the first big successor, RepRap version 2, was named Mendel after Gregor Mendel. He was the father of genetics, so continuing the evolutionary theme.
Hi, this is just a short video to introduce Mendel, which is the second generation of the RepRap machines.
It had a lot of improvements over Darwin. Its design was lighter, it had a larger build volume, and it was much simpler to assemble. So the Mendel design was later mutated to become the now famous Prusa Mendel, which is how Joe Prusa got started in the 3D printing world. The Prusa Mendel simplified a lot of aspects of the Mendel's build process, with a focus on making it cheaper and easier to build, and with a lot less fasteners, which, as you'll know if you ever built an original Mendel, is a big improvement. So lots of other contributions were made by individuals that focused on improving the build process and the performance of the Mendel. One huge contribution, in my opinion, was the Wade's geared extruder and the subsequent Greg's Wade's extruder. And that was cheaper, faster, better performing than Adrian's original kind of geared extruder. That extruder continued to evolve over the next few years, spawning what later became known in the community as remixes. Each of those improved on its usage or eased the implementation of the extruder. Speaking of variations, in early 2010, the RepRap Huxley was introduced. And Huxley was an effort to miniaturize a Mendel, and that meant that you could print the parts for a Huxley in 1/3 of the time it would take to print the parts of a Mendel. So it was around this kind of time that the E3D story begins with Dave and I. We were at a teachers trade fair for design technology teachers, which is what we were training to be at the time. And we bumped into a guy called Jean-Marc Giacalone, and he'd started a company and done a crowdfunding campaign for what was the eMaker Huxley. The company eMaker would actually later go on to join forces with Adrian and become RepRap Pro.
Hello, my name is Adrian Bowyer. I'm the person who invented the RepRap machine and started the RepRap project a few years ago. And this is Jean-Marc, and I'm the founder of eMaker. We've now got together to form a joint company called RepRap Pro in order to take that machine, develop it further, and ship 100 more of them for Christmas.
The printer we bought was an eMaker Huxley. I think it was serial number 93. And we built that printer in Dave's kitchen. And I still remember commissioning it way back in 2010. So in all honesty, this video was meant to be for Maker Faire Malta, and we were supposed to have the more recent history of RepRap displayed as a kind of story on our stand. That didn't happen because of COVID-19. However, if you would like to see a video about the more recent history of the RepRap project, then let us know down in the comments below and we'll see what we can do. Thank you very much. They're magnesium die castings on it. It's a really, really nice piece of die casting. Have you ever seen one of the bodies in white, like when it's unpainted? No. So the whole body of one of these is die cast, like a Chimera heatsink. Yeah. So it's kind of like injection molded out of metal, but it's like They're super complex. They're like some of the most complex die-casted things in the world, until Elon's going to die-cast an entire Tesla Model Y. Whoa. Like, yeah, like real talk. It will be like the largest die-cast thing ever. It's amazing. It's got really cool.
All right, smashing. So yeah, that's pretty much all I've really got, to be fair. Nick, I don't know how you'd like to use the rest of this time slot. Obviously, we finished a little early, but I'm happy to try and answer some questions. I'm not an engineer, but I'll do my best.
No worries, Sam. No worries. And I'm looking over the chat now and seeing if people have questions. So if you got questions for Sam. Oh, I know we've got a couple noting that the really cool to see the video. While we potentially wait for questions, Sam, I'll say I was looking through as you were going through the quiz questions, really making me think about a lot of different things. And I was like, oh, wait a second, huh? I mean, you know, there were some obvious ones. Everybody knows that the best breed of dog is obviously a corgi. So, you know, that was easy. And everybody also knows that Queen Elizabeth's full title is Liz II Electric Boogaloo, which I believe has Jean-Claude Van Damme in it as well. So super fascinating there. But it also kind of reminded me of some things like blood pudding. And I was like, oh, I haven't had blood pudding in so long. I could really go for some right now. So yeah, some thinking, and by the way, some longing for stuff that I haven't had in quite some time.
Smashing. So you're actually a fan of black pudding then?
I am. I have.
I can say I'm not.
Fair enough.
Despite being British, but yeah, you can't win them all, I guess.
I was lucky enough to. I have a friend who owned a British pub near where I live, and every once in a while he'd open the pub up nice and early for Premier League games or World Cup games if they happen to be on, and we'd get the traditional English breakfast and some black pudding to go with it. So yeah.
Was it American or British bacon though? Because you have a tendency to.
Oh no, it was British. Yep, he did it. He did it all the way it should be done. He was
very nice, very nice.
Grew up south of London, south part of London, I believe.
So do you still have access to this pub now, or?
Unfortunately, he decided to close the pub when his lease wasn't renewed. But I still have access to the friend, which still occasionally means some really, really good English food.
Very nice, very nice. I envy the variety in Mountain Dew flavors that you have in America. We only have one officially in the UK. It's the green one, the classic bright green one. But like I regularly import Mountain Dews from America, so you can't get hold of black pudding. I can't get hold of Mountain Dew. I feel like we're on the same page in a certain way.
You know what this tells me, Sam? This tells me that next year ERRF has to be live so that you can bring some black pudding over, and I will just get you cases of the different versions of Mountain Dew, so that we can make this trade and make this work. Everybody goes home.
That would be fantastic. Yeah. So have we got any questions then?
I'm seeing comments about things being cool. I am seeing people jumping in and saying, you know, they want Mountain Dew now. So I think we have maybe pushed some people towards that. I'm also checking because on the Discord, we have something set up for questions for the build platform or talking about the build platform. I'm looking really quickly. I am not seeing anything, Sam. Oh, apparently people are enjoying the nonsense.
Oh, fantastic. Yeah, I'm glad it went down well, because I didn't really have much feedback really when I was doing it and just presenting to a screen. I'm like, I hope people are enjoying these jokes and rambles and stuff.
Nope, I think it was awesome, Sam. And I appreciate, you know, I know there have been a couple of different changes to what you guys were going to do. I really appreciate jumping on and saying, yeah, I got this. You know, pull this up and go with it. Nice work.
I mostly thrive under these sort of situations. Yeah. And I think I'm worse if I do have time to plan really, because it doesn't just naturally come out. Anywho, yeah. Fair
enough. Well, Sam, I'm not going to hold you here. I know it's what, probably 5:45 now?
5:45 here. Yeah,
Quarter,
yeah.
yeah,
You're right.
5:45.
Hmm.
I know that Dr. Bowyer was going and having supper. I don't know if you're gonna go have supper or maybe find your way to a pint or a pub or a
Yeah,
pub
I
or a
might
pint.
go and grab a fish and chips or something like that. Celebrate.
Oh, you're just rubbing it in, Zeus. I mean, I know we've got fish and chips here too, but
we don't have Arby's. We don't have Arby's. We don't have. I've never tried a what's that California burger one? The In-N-Out.
In-N-Out burgers. Yep.
Is that California or Florida?
It is West Coast. Yep. West Coast.
Never tried one of them, and I've like heard fantastic things from all the YouTubers. But you win some, you lose some, I suppose. Yeah.
I'm not gonna lie, just chatting. I'm like, it'd be good, steak and kidney pie or a good shepherd's pie. I could also go for that.
Yeah, absolutely.
See, you're longing for In-N-Out burger. I'm longing for shepherd's pie. We got to make this happen.
Absolutely. All right. Well, thank you very much.
Well, thank you, Sam, and have a great rest of the afternoon and evening.
Certainly will. Thank you, Nick. All right. Take care.
Bye.
Bye.
All right, and I saw Vicky. You jumped in.
Hello.
Hello. Vicky has been like the silent rock for all of this for people who are watching, like keeps us motivated. I have said on many occasions my favorite ERRF/VERRF member, and I'm not joking when I say that, although sometimes Lauren looks at me like, what's going on? But Vicky, so far we have seen Dr. Bowyer and talking about accuracy in RepRap printing and just connecting it to like everything. We got history, we got biology, all kinds of different things happening there. And then we had E3D, and Sam came on and was bringing us through a pub quiz and some of the history of RepRap and everything that was happening there. What are you thinking, Vicky? My mind right now is like blown.
Yes. And for me, this is a very special treat because I'm usually working the registration desk. So I don't get to see the Build Platform speeches live like Nick gets to every year. So I'm just really enjoying this. I might be using some explicitives to, express how much I've been enjoying some of the presentations. I also really liked how we did the quiz, and then some of the quiz answers were in the history of RepRap. So you may want to go back and watch that video again, which is available on YouTube if you need to rewatch it.
Absolutely. And Vicky, I thank you for saying that, because I am going to go ahead and get Nightbot to put that back out in the chat so that people who do want to go look at it or check it out on YouTube will be able to do that. Super cool video about the history of RepRap, which I loved. And I'll be honest, we're kind of, I feel like it's a good segue, Vicky, don't you? I mean, we got history of RepRap, and then I know the next people that we have coming up on the Build platform in a little while here are kind of like the present, not the full present, but
so the person who made that schedule must have thought ahead.
Look, we've been in enough board meetings to know that the person who made that schedule didn't think ahead that much, right? I mean,
well, it's a nice lucky accident.
Exact happy accidents, right? So awesome, super excited about things. I will say that I've kind of been watching the numbers here because I'm a little bit of a numbers guy from time to time. And the number of views that we have to this point, I mean, Dr. Bowyer was just bringing people in, which was phenomenal. And for those of you who are on the Discord server, Dr. Bowyer did go ahead and put a link to his notes from his presentation into the Discord server. So you can go ahead and take a look at that if you really want to and get back to it. He's been interacting with some people in there. So I know that there were people who had questions that we didn't get to ask in the stream because, we've only got a finite amount of time. And I'll be honest, I would love to sit here and pick Dr. Bowyer's brain forever and a day. And last year I was really kind of lucky enough to get to do that after his talk, which was awesome. But that's in the Discord server. if you've got questions for him, like I said, he's been interacting, going back and forth with some people who had some questions. So you can go ahead and then jump into the Discord server and maybe get a chance to speak with him or ask him a question. We were able to record some of his talk, most of his talk. Your host here hit the button a little bit late. So I think we missed the first couple of minutes, unfortunately. But that will be up at some point as we're working on it. And man, Vicky, I'm just talking, unfortunately, and you're just having to sit here. What do you got?
Smile and nod.
Smile and nod. What do you got?
I do have a story how Dr. Bowyer had impacted my personal life outside of 3D printing, which is, I'm in the DC area and I go to a lot of maker events. And there is a gentleman that I respect and admire. And every maker event I go to, I introduce myself. And even though he's met me many times before, he looks at me with a blank look in his eye. He has no idea who I am. Well, last year at ERRF 2019, he wanted to get Dr. Bowyer to sign his printer. And I went and I got him and I brought him down and he signed his printer with a Sharpie. And now that guy remembers who I am. Now he won't forget me.
Never forget your name. No, it's pretty sure. And
because of Adrian.
Yeah, now that I'm thinking about it, at the same time, I probably should have jumped on that opportunity to have Adrian do that. At the same, tied to that though, I probably would never print on that printer again. It would probably just sit there. Perhaps this would be the one time that I would put something in like a case. I'm not big on having cases around my printers. I print a lot with PLA, and so I don't necessarily need it all the time. But yeah, I'm thinking this would require some kind of enclosure to have around a printer signed by Dr. Bowyer. So yeah, oh, that's awesome. But that's what, as I think about it, for me, this is what RepRap Fests are about, right? They're about connecting people in these kinds of ways. Yes, there is so much cool stuff we all get to see, and there are amazing sponsors, amazing companies that bring things out there and release all kinds of stuff, which makes us all super grateful and keeps us going what we're doing. But that connection, that ability to, have Dr. Bowyer sign somebody's printer, or for the people who I know are coming up here in just a couple of minutes, I will say that one of the things that I love to do is talk with some of these people in this particular group. Always fascinating to me, good to hang out with, and just kind of having that connection. I love it. I'm a people person. What can I say?
And the people coming up totally nailed their slot earlier today on the exhibitor and sponsor channel. So I'm really excited to see what they could do with a longer time slot.
I was lucky enough, because it was before the build platform got to kick off, that I actually got to catch that part of the channel 1 lineup, and I was super excited to see that, and heard some really, really cool things that came out of that as well. Oh my God, it's only 1 p.m. It's not even 1 p.m. Eastern time. I'm already like babbling. Stay with it, Nick. Stay focused. We got more to do today. Awesome. Well, I have reached out to the next people who are in the waiting room because I see them and they're ready and I want to bring them on, but I also want to make sure that they're prepared to come on. Because they did have a time slot a little bit later. Look, I can just tell you though that, showing up early and everything.
I can plug our swag again if you want.
Oh, plug the swag. The swag.
Where is the swag? Here it is. Okay, everybody, you may have heard this before, but if you're just joining us, even though this is a virtual event, we do have some physical souvenirs of all the fun that is virtual East Coast RepRap Festival. First off, we do have our badges sponsored by Printed Solid, and you have your little number on the back. And then we also have stickers, which we're hoping that the virtual only apply to this year, which is we have the virtual ERRF2020 stickers. So for these, we're going to come up with a plan for the international viewers, but for the United States viewers, go ahead and send a self-addressed stamped envelope. We'll put the PO box in Discord and also the YouTube chat. You send that self-addressed stamped envelope to us, and we will send back your sticker and your badge. In addition, if you want to add to your collection of ERRF shirts that you have bought over the years, this year we have one that's a little bit different. We have our ERRF Goes virtual shirt designed by Lauren from A Buzz Designs, and that is available for purchase on Teespring. We'll put the link in the chat and also Discord.
Excellent. Oh, I forgot about that. I love swag. Oh, every year the stickers. I got a big like bundle of stickers now for different things, which is awesome. And I will never go. All right. If you're watching the chat, and I know that there are 111 people who are currently watching this channel at this point, I'm seeing that it looks like our next speakers are ready. So I am going to go ahead and let them in and let them take over what they're doing. And for those who are waiting for them to come on at 1 p.m. Eastern time instead of a little bit earlier time, I am going to record this so that we will be able to go back. You will be able to go back and watch this at some point. But as they start to come on, oh, I see the names. I see the videos popping up now. I am going to go ahead and back off because these fine folks can introduce themselves and you don't need to hear me talk anymore.
Okay, hey everyone. I guess we're still waiting for Joe. Matt is here. Nice.
There's Joe.
Yeah.
I just had to get my audio fixed there. Uh-oh.
Uh-oh. Uh-oh.
Joe, there we go.
So are we live now?
We are live.
Oh, hello everyone again.
Hey.
Howdy. It's suddenly dark outside your window. A little change from earlier.
Yeah, it's already 7 p.m. here. So the virtual ERRF will be running very late here, I guess.
Yes.
So how do we start? Should we get some questions from the Discord, or just do first the Prusa printers, and if we have time at the end, we will do the questions?
Yeah, I think we'll talk Prusa printers real quick, and then we'll definitely have time, on the end to grab some questions from people too. So, and it looks like people are definitely interested. I would say it's much easier for us to probably take questions from the Discord. So if you're in Discord, pop into there. It's a little bit easier than taking stuff from YouTube because of the time changes and stuff. And
I will try to keep an eye on the YouTube chat also, but we'll see, I guess.
Yeah. All right, great. So welcome. We are, members of the Prusa team here. Obviously, Josef Prusa with us, the man that brought us all together. And yeah, this is kind of your Prusa Live crew going on here. If you ever watch our Wednesday live streams, that it's just like this. But we want to talk a little bit about Prusa printers right now, and really the community side of that, and what all's going on with Prusa printers, because it's really exciting, and I think something that whether you're a fan of our printers or not, it's something that's accessible to everyone out there, the entire community, and we want to make sure that all of know that Prusa printers aren't just for Prusa printers, but there are some advantages if you are a Prusa printer owner. What is Prusa printers? Let me pull this up.
I would say Prusa printers right now is very big success, which is not it goes a little bit under the radar with all the other stuff we are doing, but it is growing very nicely. So, Matt is screen sharing.
Yeah, there we go. So this is Prusa Printers, and yes, like Joe said, it is a site that is growing exponentially all the time. We've just passed over 27,000 individual designs up on Prusa Printers, and that grows by about 50 or more designs every single day, and those numbers are going up. I think we have around 91,000 registered users right now, which is great. That's a huge, wonderful community, and we obviously encourage all of you guys to come out and join Prusa Printers. Even if you're a fan of other platforms, we all know that some of those other platforms are having major problems right now, and so backing your things up to Prusa Printers is a great way to make sure that your designs continue staying accessible to everyone. And if a certain site went down, you would still have access to that. And we do have Thingiverse import tools, so you don't even have to do everything manually. You can just click on it and it will bring all your files over to Prusa Printers. One of the exciting things I think we've been doing for quite a few months now is running our contests on Prusa Printers, and we just finished up our lamps contest, which was actually an idea that Joe just struck out while we were on Prusa Live one day. He's like, why don't we do a contest about lamps? And yeah, do you guys want to talk a little bit about what all happened with our lamps contest? Especially Mikolas has one of our
I have
entries right there behind him.
I have two right here because this is the Desks Stranding by Nilskal, and I also have this nice lamp, and it has smart LED bulb in it. So if I dim it, you will actually be able to see it.
Oh, yeah, I saw that one in the office. That is very nice.
I actually took it home and I put it on the ceiling, and I had a friend come over and he looked at it and he was like this must have cost like a fortune. It looks like a designer super fancy glass lamp, but it's like 100 grams of PETG. If I show you from the, I don't know if it's, maybe if I turn it off.
Yeah, I desperately need to get some clear PETG and print this.
It's just bridges. It's very little filament to print this.
It doesn't have to be like transparent filament.
No.
Right. It just looks nice with the light and looks all kind of like a crystal, chandelier kind of thing. So
Matt, maybe you can, if you go to blog on Prusa Printers, the latest post will be the winners of this competition. And this lamp, I've seen it also printed in Galaxy Black, and that gives like very nice whiskey steakhouse like club vibes. If you put this Edison IKEA light bulb or something that has really warm color. So
yeah, you can definitely see. Yeah, you can see the kind of makeup of that lamp a lot better there. Yeah. But yeah, this contest actually had two segments to it. One that was kind of a more traditional lamp side of things, and then the second one was, what can you do with cool LED lighting? And Ray Jizza, who is a constant uploader to the site and contributor to the contests, he ended up taking it with his cute skull lamp here, and we just love his design. So much fun.
Yeah. And that is the Desk Stranding. Mikolas, did you actually manage to motorize it? I know you were working on it.
I have the prototype working with the one arm. I'm waiting for more servos. So now it's the tedious refreshing the shipping if the servos will come. Yeah, I'm really hoping I can make something out of it for when we can go back to events in person, actually, to show this.
Yeah. But of course, the site has plenty more things other than just lamps. Obviously, we have lots of different categories for models. So you can really find what you're looking for. The search works great when you're searching for things. You can search on the models themselves. You can search on individual designers, and we have plenty of the designers out there that you guys all know and love. I know Luby was on a little bit earlier, and she definitely has designs out here. So continuing to grow, continuing to build. You can do a lot of filtering on the site as well.
I think
really,
what's really
easy
kind of
usage.
setting us apart at the moment is maybe it's like sort of advantage in the fact that we started a little bit later, that maybe we don't have like that many million prints. We have 27,000 prints, but they are like very high quality. Like the ratio of like random L brackets that no one will ever use to actual high quality models is, I think, they're pretty amazingly high on Prusa printers.
Yeah, for as much as I love Customizer on Thingiverse, one of the issues there is like as soon as Customizer came out, people started just putting their name on keychains and hitting customize and then uploading that to Thingiverse. So Thingiverse has about sure, it has over 1 million things, but it also has 500,000 keychains on it too. So
yeah.
So here's an idea how to raise the number of the prints.
Yes,
yeah,
I would love to see us have some kind of customizer, but yes, I love having a higher quality print level.
Yeah, we had, for example, a competition about reusing the Prusa spools, and that also had like an incredible amount of. Actually, we can see one right now, the Prusa, and these are like all really like high quality. They have manuals. The prints. It's not just random STLs and like there you go, do whatever you want with it. People actually write very like detailed instructions on how to assemble the prints.
We have wonderful people entering stuff into our contests.
Yeah,
I would have never imagined that such detailed things will be put in the contest.
Yeah, it's been really inspiring with each and every contest that comes about, like how many high quality things that we get out of it. I think there were like 300 entries in the lamp contest or something like that. It was crazy. So,
yeah. And that wasn't even the biggest turnaround we had. Yeah,
right. Yeah, because that one was kind of tricky, right? Like designing a lamp and like designing a good looking lamp was actually a hard contest. And so it's impressive that we got that many entries just on that one. And these contests, there's a good reason why people are putting forth the effort and things. We're giving away printers with our contests. So definitely check it out. There's definitely a chance to win a printer there. But also, like I said, just uploading your normal everyday models. It's also a place where we put all the things for that we designed. So the face shields that we designed are up here too and have been highly downloaded. We can see that the US version of the face shield has over 20,000 downloads on it, which is very impressive in and of itself. Lots of people out there. I
think all our variants have like 200,000 downloads. Mikolas.
Yeah, the face. Yeah.
Yeah, that's just crazy.
But I think it's overlooking some of the features to see Prusa printers only as another model sharing website, because
we've
see in the tab, there are more functions that Matt is showing.
Yeah, we've definitely pushed a lot more features. One of the key things that we're kind of building upon here is our world map, and so this map will tell you where there are Prusa printers. As I continue scrolling out here, where there are Prusa printers throughout the entire world.
The video is a bit slideshow on the stream, but I guess that's what it is. What it is.
Yeah.
I guess you need a Starlink connection.
Oh yeah.
Yes. So Prusa printers all over the world, and we're adding some new features to this. One of the things I think is really exciting is our print on demand feature that we recently added, again kind of during COVID. We thought people are at home, they may not they may not be working right now with everything that's going on. Let's find a way that they could potentially make some money by using their Prusa printer, by using their printers. And so we created this print on demand function where you can list your printer as being accessible for print on demand. And then if someone sees a print that they really want on Prusa printers, but they don't have a printer themselves, they can look for people who are in their local area who have print on demand turned on and send out a request to say, hey, can you print this for me? We aren't handling any of the financial transactions on that or anything. That's entirely, you know, up to you guys to figure out. But that also means we're not taking a cut of it too. So, you know, it's completely up to the user how much they want to charge and, you know, how much they want to make off the kind of final thing. We're not injecting into that.
Oh, that's actually awesome. Greybird3D is saying in the chat that someone local found him on Prusa printers, and he was able to manage to help someone printing again to fix the machine.
Oh, wonderful.
Yeah, because that's one of the other functions that we have is we have you know, tech support that's in there. So while we have amazing techs, you know, who you can get in touch with via chat or, you know, email, all kinds of things. You know, sometimes it's just easier to see if there's someone in your local area. You know, go over to your local makerspace, you know, talk to people at 3D printing meetup groups and things like that, and see if somebody can help you out with your printer. So yeah, if you turn on tech support, you're saying, hey, I'm someone who will help you with your printer, and you know, makes it a lot easier for people to go and find someone nearby that will help them. You know, not necessarily the biggest used feature right now during COVID times, as we're all kind of keeping our social distance from each other, but something that, you know, definitely can be used in the future. It works really great in conjunction with our groups feature too. So
Matt, I will jump in.
Yeah, go ahead, Joe.
Just for a tiny bit. If I'm not mistaken, we are adding a new thing to help people price the prints, and that is in final stages of testing. So if you are open to print on demand, it will be much easier for you to know how much it's okay to ask for the print.
Yeah, I wasn't sure if we were talking about the pricing tool yet, but yeah, that's going to be super useful to help make sure that, like, you know, you kind of run through a list and figure out the price for an actual print, and make sure you're not kind of forgetting the little things in there and kind of finding yourself in trouble for how much you quoted later on.
Let's see. We can go back to that if I can manage to log into the. Oh, I'm actually there, Matt. If you.
Yeah, I'm gonna stop the sharing. You can take over.
Yeah, I'll take over. Yeah. So we made a calculator. What we describe here is probably what I'm gonna kind of say right now is that there are already some 3D print calculators online right now, but I feel like they are either one or the other. Either they are too simple and they are just straight up, you know, it's just filament used times spool price. So it's just Lighter can tell you that. Or they are super complicated, but they are like missing any default values, and you have to fill so many fields, and you're really not sure what to fill them with. So we made a new calculator where you can actually upload G-code, or, you know, just fill the printing time and the weight manually, but there are default values in as many places as possible, and if you choose ASA, it will change everything. You can set a markup, everything updates in real time. And yeah, for example, electricity, very often asked, is it important? Not really, so it's off by default, but you can turn it on, and there is some default price for kilowatt hour. And yeah, very important things like print preparation, you should probably price that somehow. If you're running this as a business, you might want to, you know, the printer should probably pay for itself if its only purpose is to make you money. And yeah, stuff like that, you can share it in the end if you fill the name. You can share it, and this will actually create a permalink. And yeah, if you send it to someone, he will see the filled calculator. It's pretty nice. We are still kind of finishing touches on it, translating it to other languages. But yeah, this is how it will look like.
Yeah, it's a great added feature to help out people, especially when they're looking to turn their 3D printer into something more than just a hobby, but also, you know, a potential business that helps either pay for the hobby or, you know, helps pay for their general lifestyle.
Someone was also asking about the Thingiverse import and if we can make a tutorial on it, and I can do it right now in like 20 seconds. If you're logged in, you click create, and there is the option Thingiverse import. If you're doing this for the first time, it will ask you to put a link in your Thingiverse profile so that we can verify that you're actually importing your models and not someone else's. And once you do that, it will just show all your Thingiverse models here, and you select the ones you want to import. And I think this will create drafts. And I think the only thing you have to select is category or something like that. And then you can just hit publish, and you now have a model on Prusa printers.
It's very
really
slick.
easy.
Yeah. And I from the data, I see already 2,200 people imported from Thingiverse.
Yeah.
Yeah. Which is great. You know, little caveat there, every once in a while people come back to us and say, hey, you know, the Thingiverse importer is broken. Like, why does the import break? To be honest, it's never broken on our side. It breaks from time to time because Thingiverse breaks from time to time. And so, you know, if you're having problems importing, like everything else on Thingiverse, maybe wait a day or two and try again, because sometimes Thingiverse just doesn't work right now. So.
Mikolas, which other model sharing site, or we don't have to name them, but I think we found out that one of the sites who did Thingiverse import, it was done manually by people in the office.
Yes.
The import is only working during business hours, which I know
right.
it sounds funny, but you have to give it to them. At least they are giving in the work, which is really impressive too.
Yeah, they're at least trying. So I feel bad for all those people hand importing all of those in, but they are definitely trying. Yeah. So let's see. I will share again. So yeah, so I started discussing. We have groups, and this kind of ties in again with the map and finding people who are local near you. Groups was something that we kind of had in works beforehand to work on some other things, but we thought would be a great addition during COVID for people who are kind of collaborating together to try to work on face shield production. So groups is you know, a simple way that people can find local people in their area to work together and work on a single task. Of course, you know, we'll see how people use it in the future. It'll be very interesting to see how it grows and how it expands, and you know, if it stays as kind of local groups or if it kind of expands out to be, you know, people working collaboratively on projects across the internet, as well as you know, what kind of projects are they necessarily working on? So yeah, so here we see the Canada 3D printing group. This one seems to be based out of Quebec, Canada. Has 146 members in it, and members are able to, you know, message each other and leave comments within the group. They can look for nearby groups in you know, a geographic area, see who all's members. It really is a great little tool that a lot of people have used, you know, very well during these times to like hurry up and make face shield productions and things like that to work together. I know some of my friends down in Rhode Island have been using it a lot for the efforts that they put forward to outfit shields there.
Yeah, and also it has great use for, you know, other 3D printing enthusiasts after the whole COVID thing ends, because I think 3D printing is, you know, you are creating things in physical world. So, you know, nothing beats to showing it off in person. And you know, I think everybody is getting bored of the Facebook and looking forward to meet up in real life.
Yeah, absolutely. Absolutely. And, there's already expanding groups of local meetups that are going on out there that, people are getting together, and pre-COVID, we were helping kind of, bring some of those together. But yeah, people getting together and sharing their tips and their techniques and showing off their prints, while enjoying a glass of beer, something like that. And, groups was kind of a little bit of an extension of that. And, we're hoping that as people, in the future, as things get fixed and people are able to kind of go back to being together in public, that groups is one of the things that they'll be able to use to kind of organize, monthly, meetup groups in different areas around the world. And we will definitely be helping out there. But yeah, I look forward to seeing things, other than like, face shields and COVID kind of things, but, people working in the groups for collaboratively for things like, I know that ERRF had the 3D printed, like Pinewood Derby kind of things last year. It'd be interesting to see groups like that created where people are, sharing their tips and their techniques for how to get the fastest 3D printed car. Or, I used to run a 3D printing competition called Moatboat Paddle Battle for 3D printed paddle boats. And yeah, it'd be great to have a Moatboat Paddle Battle group of people talking about, how to build paddle boats with their 3D printers. And as we see how more people are using the tool, we'll expand what the tool is capable of doing, because, we are kind of constantly updating Prusa printers and adding new features to make sure that it, definitely fits what the community needs. In fact, I think,
speaking of new features,
we have a very exciting new feature that we would like to preview for you guys right now that never before seen. So this is Prusa printers 3.
I don't know if maybe I can screen share it.
Why don't you do it? Yeah, why don't you do it, Mikolas?
Because I have it on local machine.
Right. Yeah, so this is something I have been dying for, and I'm so excited that it's here. But yes, we have 3D previews, so both thumbnails and an interactive 3D preview on all of our files. And so this doesn't just work on STL files, but it's STL, OBJ, 3MF, and we're even getting very close to having G code working. So you'll be able to get full 3D preview of what the G code will actually look like at the end. So for all of those people that are concerned about, someone could put up G code that isn't what you think it is. Well, 3D preview will be able to ensure that you're not printing things that you don't want to be printing when someone says it is something. So
that's
I think you all know what I mean.
I haven't seen a single issue with that so far. So that's luckily going very good. Yeah, I really like that. It's even in the 3D preview, there's a download button. So, if you're looking just for one file from the set, you can immediately download it. You don't have to, what was this file name? I need to search for it in the list again.
That is wonderful.
Yeah, and you can just stay focused on if you want to look through the 3D files, you don't have to go back and forth. You can just focus on them and stay in the 3D view. One thing that's I don't know, maybe a little bit strange is, for example, this box is very likely a modifier in Prusa Slicer. Yeah, but it just imports it as a geometry. But yeah, I mean, it is what it is. You at least know that there are modifiers, and that will often be the case with 3MF files. With STL files, there will obviously not be any modifiers. This is not live yet. This is a recording from our test server. Finishing touches. I don't know the ETA, but I would say week 2, something like that, probably.
Yeah, definitely coming soon. And there's lots of other features coming soon to Prusa printers. Email notifications, woohoo! Email notifications are on the way, and so that will also cross across to groups and things like that. Combined avatars that will move across, all the different kind of areas between Prusa printers and the forum and groups and everything else. That will be soon, and lots of other other great features. But yeah, so we have like 5-7 minutes left, something like that.
Yeah.
I think it'd be great to take a couple questions instead of just us talking.
Yeah, I mean, if you have any suggestions for Prusa printers features, please just send us to us anyway. Tweet it, post it on Facebook. Text chat on Prusa Live, whatever way you can get it to us. We read it.
Yeah, for sure. I get stuff from people all the time over Twitter. So feel free to reach out to me if you have ideas. I'm here to listen.
I need to give a shout out to Neil Scal. Like an hour ago, he posted, wonderful badge area, which we knew that we want to do badges, but I guess he made the work for us. So we will just
this is very high effort page. You don't have to make it so fancy. If you just say, I want this in chat, it's really important to us, kind of to know the demand kind of sets the priority in the task list for us, because if all of you want something, then we obviously should make it faster than some nice feature that might not be so critical.
Yeah, that is really great. That looks really, really great. And it will definitely be soon, because all of us are dying for badges. It's it's something that comes up pretty regularly. So that looks great. All right. Do we have any questions out there on
update on Excel and print farm? Yeah, we kind of went over that in the main segment. Difficult to really develop and get anything into manufacturing at the moment. So
yeah,
unfortunately, no, not really any updates.
Sorry about that, but we cannot do much. So I'm trying to find some questions in the Discord. Do we see something?
Yeah,
maybe we see the same thing on Discord by Zomi, or
I will say there was a question I caught in the YouTube chat by somebody who asked, what things are you guys excited for, either Prusa or just 3D printed in general, 3D printing related in general?
Well,
working with Prusa.
That is such a hard question for us, because obviously we know some of the super exciting things that we do have coming, and we can't talk about those things, but some of those things I'm straight up calling are like game changers. And so, which it's an overused term, right? But that's one of the reasons why we have the reputation that we do is, Joe and Michael and our entire dev team really just keep pushing things further and further. But, unfortunately, we don't want to tease too much, because, you guys are a little upset with us about the tease on the Excel, and then the Excel's, taking some time, but, that was out of our hands, as so many things have. But yeah, things are coming.
But I would say the coolest, visually, and from the point of view of something you will be at Dubai Expo, 2020, which will be in 2021, maybe. But we will have the part of Czech exposition there. That'll be wonderful.
That will be epic.
Nice.
Yeah.
Yeah, super cool. I mean, to be honest, I'm excited about a lot of the things that are rolling out to Prusa printers. It's something I'm, super passionate about. And yeah, some of these new features that are on the way, and continuing to get more of you guys on board the platform, so that we get more and more cool items out there.
So it seems like we answered all the questions in the Discord.
Crazy.
Yeah.
The typical Prusa Slicer 2.3, when is it coming out? We do not have next question. We don't have a set date. It's kind of when it's stable enough and when all the critical bugs are fixed.
Yeah, and also the new Windows update, which just rolled out, broke a few things and made it super slow. So Wojciech almost like thrown the PC out of a window. How mad he was.
It wasn't even like a Windows update. It was Windows build server update, and just suddenly the window is super sluggish, and we have to change the whole thing. How like system UI controls are rendered and how many can be loaded at a time, and it's such a pain.
Yeah. So Wojciech is not working on Linux, but yeah, they are fixing it, and I think it's already in testing for the alpha release. So
yeah. So I actually think that's our time. I see 129 here, so we are wrapping up. What was that?
No. I also
I thought I heard voices.
I also heard a ghost or something.
Yeah. Okay, so yeah, that's our time. We really appreciate you guys, flipping over from the main channel to catch this discussion with us. We know that there's a lot going on today, and we appreciate it. If you want to see more of us and hear more of us, this Wednesday at 3 p.m. Eastern is Prusa Live number 11. We've been doing Prusa Live for a while now, basically just like you see here, but an hour of us and talking about more of what's going on and sharing some of the contests and things like that.
Who wouldn't want to hear us rambling for an hour?
For a full hour, exactly.
Sebastian in the chat noticed that there is also a separate G-code previewer in Prusa Slicer 2.3. Yes, there is. And it's also a standalone application, so you can associate G-code files with it. And when you double click it, it will just quickly open the preview. It's awesome.
That's great. Yeah.
Wonderful.
All right, guys. So we hope to see you guys Wednesday on Prusa Live. And until then, so long from the Prusa team.
Enjoy the weekend.
Bye.
Awesome, guys. Thank you guys for being here. Thank you guys for taking a couple minutes extra and coming on early when I asked. Greatly appreciated. I know that everybody loves seeing you guys. I will tell you that the numbers jumped a little bit. You guys got up to 150 people on the build platform, which may have been the highest of today, if I were going to say something. So enjoy the rest of your Saturday. Thank you guys for coming on. Joe, Mikolas, I know it's late there, so go enjoy. Matt, I know where you're at, so I know what time it is.
Nick and I are going to be neighbors in just a couple of weeks, which is wonderful. So, all right. See you guys.
Bye, guys.
Okay. Bye-bye.
All right. And with that, we will move right into bringing in our next presenter. And as Zoom is working to get her in, I will introduce her. You guys probably know her. Lots of people on YouTube probably pretty familiar with this next person who is coming up, Miss Chelsey. I like to think she is the better half of Chaos Core Tech, though don't go ahead and tell Garrett that. Of course, now that's recorded.
He's not watching.
And it's perfect. That's right. We're good.
He's busy, so there's no evidence. It's fine.
Awesome. Welcome, Chelsey.
Hello, everybody. Yeah, like he said, I am the better half of the Chaos Core Tech duo. And he unfortunately is busy. He is doing flooring right now in our house, so that's fun for him, and I get to be here with you guys, and that's a little brighter. Perfect. So he's the better talker, he's the better teacher, he's the better everything as far as that goes, but I have gotten pretty skilled lately, maybe stepping up into his territory of modeling. So that's what he told me to talk about today, because that's what I know. So talk about what you know, right? So we're going to go, and I've had a lot of questions about 3D modeling in ZBrush, and specifically more into my like filigree work and stuff like that on like the skulls that I've put out. So I'm going to share my screen. And let's see, we're going to share this screen here. And we're going to share. Okay. Hopefully that is showing. All right. So this is kind of what a lot of people have been asking me questions on. So I'm kind of going to explain some tips and tricks and specific brushes and stuff like that that I use to do things like this. So if you're interested in learning some little tips and tricks for modeling really intricate details, or maybe I'll even show like wrinkles. I know a lot of characters and clothing and stuff like that has wrinkles. So I'm just going to show some tips and tricks on that. So this specifically is what I've had a lot of questions about, my favorite brushes to do this kind of work. So that's what we're going to start with. As you can see, there's a ton of detail on this, and you really want a decent amount of depth going into the model as well as sitting on top of the model, whether you're wanting that detail extruded or into the model. That, like, when you're 3D printing it, that's really important, especially for FDM, to be able to actually see a lot of those details. So we're going to start with a base skull here so that we can really show you the detail. One thing that I do that's really important to be able to see the detail and get that detail in there is you're going to want to have a really high poly count on these models. If you don't know what that means, basically the lower the poly count, you're going to have a lot of flat edges, like squared kind of looking geometry. And once you start subdividing, they're going to get smaller, if you guys can see that. And you divide again, smaller, divide again, they're not visible. So that's really important when I start doing really high detailed models, is to get it really subdivided to a high poly count. I actually have now 3.2 million polys just on this skull here. So one thing that I do want to mention, if you're getting into ZBrush, this is not going to be exactly what your screen looks like. I use the Shane Olson brush set, and also the Shane Olson, the UI, or not UI. Yeah. Let's see. Yeah, the custom UI from Shane Olson, so that my screen looks like this. And he actually gives that stuff away for free on his character workshop website. So if you are interested in any of these brushes that I'm going to show you, a lot of them are very close to the regular ZBrush brushes, just tweaked a little bit, but that's where you're going to be able to find some of these if you're looking for them. So the first one that I'll show you, and this is probably my favorite one lately to do a lot of high detail stuff with, is this chisel brush. And that one is a standard ZBrush brush. And let's see, we've got it on symmetry right now. So basically the biggest thing about doing these high detailed filigree or lace type things is making sure that they are very apparent. So you're going to kind of mess around with some of your sizing. You can mess around with some of the intensities of the brush, because you can see how it sticks out really far, it sets in really far. That's going to be a big thing for just making sure that you don't have it too set out that you're going to need supports, but you do want it set out enough that you're going to be able to see that detail. Also, lazy mouse is something very cool with ZBrush. As you could see when I was drawing, you've got that red line. It kind of gives you a little more smoothness. It drags behind a little bit. It's called the lazy mouse. And that's going to allow you to get some really smooth swirls. So if I turn that off and I try to do the same thing, I mean, even if you have a pretty steady hand, it just does not look near as good. You can see there. So that's another huge thing with my designs I've been using. Lazy mouse, you turn that on and you can adjust how lazy it is. So I'm going to turn that on with the chisel brush. And then we're going to size it down quite a bit. And then you can kind of just start, do an insert design. And then you can hold the Alt button, and that's going to give you the inverted of this brush. One thing I do want to mention, when you're using the chisel brush, you're going to get this weird issue. If you're going over lines that you've already drawn, you're going to have this weird stuff in here that's going to happen, and that's going to happen every time, unless you can delete all that. And then we're going to hit Store Morph Target down here in the bottom left. Now watch if we're going to do this, and then we go over that again. Now you don't have that issue. It's not trying to go over that same line twice. So that geometry is just going to stay the exact same in the middle there. And that's what you're going to want when you're doing these designs. So the chisel brush is great for something like this because you really get that defined line that you're going to want. Use the Alt, and you can kind of do, like, let's just do a little bit of a lacy flower detail. And this is what a lot of people have been asking. I just put out on our Patreon, I'm doing Sculptober. And that is a new model every single day of October. I've actually put out more than one STL a couple days. So if you were to join our Patreon, you're going to get, at any tier this month, you're going to get over 31 STLs in the month of October. And I've put out some kind of fun ones. They're mostly simple because, I mean, I'm doing them in a day and then processing them for 3D printing. But I just put out a genie lamp and it had a lot of this filigree detail on it. And people wondered what the brushes were that I was using. So the chisel brush is like one of the main ones that I use because it's so defined both in and out. And another secret I like to do with this chisel brush, if you want to do raised dots or set in dots, you turn off the lazy mouse. And if you have it set, the intensity set pretty high, you can just hit hit a dot on the screen. And the harder you hit with pressure sensitivity, obviously, you're going to get a deeper or bigger hole. But that's a good little trick for dots or anything like that. And then if you want to smooth them out a little bit so they're not as defined, you can do it that way. So the chisel brush is great for stuff like that. They also have a couple different types of chisel brush. You've got one that kind of looks a little inappropriate there, I guess, but that's going to give you, you've kind of got a double raised bar. So it's a little bit of a different look. A lot of them are, that one's really set in. You've got this one that's really spiky. And that's just that you're gonna need to up the poly count for something like that. But so the chisel brush is great for filigree detail, something like that. If you're wanting to design something for 3D printing that has a ton of detail, try out the chisel brush. One other one that is really nice, let's do some wrinkles. ZBrush actually, if you're having the full version, just released a new like cloth simulator that you can make wrinkles a little bit easier. But if you're gonna go full, like from scratch wrinkles, This brush is the cloth brush. It is a Shane Olson brush. I know it's just a different take on another brush, but I really like this cloth brush that he has. And let's just give the side of the skull some wrinkly detail here. So what I like to do for that is you can kind of play around with the size of the brush a little bit. And sometimes you're going to want it bigger. Sometimes you're going to want it smaller, even within the same little area. So let's do, you start by maybe like insetting some there. And then what you're going to want to do is you're going to want to invert that brush and use Alt to do that. And see, you're inverting some of it here. Do a couple of those. And you can kind of start getting, you know, some wrinkle effects. But one thing that I noticed that helped a lot to do wrinkles, especially when I was doing the Rancor model, is if you do this and kind of give it a bunch of wrinkles like that, but then you go back in with the move brush, or you could probably use the snake hook too. I've been using the snake hook in replacement of move quite a bit. If you use the move brush and you kind of just work that geometry a little bit, you can get some tighter areas of the wrinkle and then some looser areas. So you kind of make it look a lot more natural that way. Like if you wanted to bunch up this area, just kind of work that there. And that kind of gives you a really cool wrinkled look. That's one technique that I've found works really well. And I used that all over the Rancor, the Star Wars Rancor model. If you guys want to take a look at that, we do have a video on that. And that is also on our Patreon, as well as our cults and stuff. You can also thicken up the wrinkles. If you want them to look a little bit like fat rolls or something, you can use the inflate brush and kind of go over those. Make them really bulky. So they're just going to be without those spaces in between. So that's a really fun technique for something like that. Let's just reverse out of that there. And then let's see what else. The detail brush is also one that will give you a lot of good crisp details. And this is a basic ZBrush brush as well, but he has altered it slightly. But this is going to give you the same crisp details. You just have to make sure that you're going to get enough set in to really give you that definition when you're doing FDM printing. This may show up on a resin print, but more than likely, this right here is not quite enough to really show up really well if you're going to print that in FDM. So you may want to bump up your intensity a little bit on that brush. And then you can kind of go through and see, and then that's going to be probably too much. So it takes a lot of playing with the intensity and the size of the brushes to get certain looks. But see, now that's going to be about perfect. And you're definitely going to be able to see that on FDM. And detail brush is really good if you're maybe going to do some detail here like this. Maybe you want to do a little snail or something. And you can also invert this brush. You can invert all brushes in ZBrush with Alt, and it's going to raise it instead of sink that in. So that'll also give you a really nice point there. And speaking of that point, there is another Shane Olson brush that's kind of handy when you're wanting to do some sharper edges on stuff. He has this pinch brush, which is kind of amazing. let's say you want to sharpen up the way the skull looks a little bit. So I would take this pinch brush and I would invert it so it's going to pull out. And you can kind of go around all these openings and really sharpen this up. The pinch brush is a little weird because it really does move geometry a lot. But now you can tell, if I reversed out of that, that was before, and then that's after. So you can really tell that that pinch brush really sharpened that area up a little bit, which can come in pretty handy. I mean, look at that, like, definition compared to not. So that is a really great brush also for doing stuff like this, but you can really kind of make a lot of stylized stuff with this brush, I feel like. You know, some sharper cheekbones, a little on the nose, ridge that out a little bit. It really gives it a whole different look, a lot harsher, rather than that soft skull look. Okay, so let's go back to a open skull here. There we go. So let's try a different one here. It's also really helpful for detail stuff. The one that I've been using a lot for hair is actually going to be the standard brush. I feel like the standard brush doesn't get used much, at least with people I talk to, and Garrett never uses it. But the standard brush is going to give you these really raised pieces without being super, super defined. So what I mainly do with this to make hair is I'll make some raised areas. We'll do some lower areas, kind of overlap a little bit. And then you really start messing with the size. And that's really what starts to build here, is you kind of just build on the sizes a lot and just work with it that way. And I think that that really starts giving you nice defined pieces. You really have to kind of back and forth, bigger pieces, smaller pieces, but that'll kind of give you a really nice look. Sorry if you can hear my dog barking. There's a lot going on downstairs, but let's see here. So yeah, like I said, let's turn this to maybe, I know there's one of these that you can see it a lot better. Okay. Oops, don't want that black. So that'll really give you a nice in and out of hair strands, smaller, bigger, smaller, bigger. You got to work with it, but as you can see, like from far away, it's like if that was on a head, it really does give you a nice flow for hair. We've still got symmetry on, so that's not going to look super great there, but this can also be used for detail. It's just a little bit more muddy. So I still prefer the chisel brush for stuff, but I think that that's kind of my main stuff for filigree work. I know a lot of people were having questions on how I get it so defined and what my favorite brushes were. So that is kind of what I had going for that. I don't know. I don't have chat open, but is there any like questions that anyone has about brushes or how to do certain types of things that maybe I could show you quick here in my last couple minutes?
Chelsey, I'm looking at the chat for you because I know that you've
Thank
been
you.
busy. You're very welcome. A lot of praise and a lot of Chelsey is completely awesome.
Thank you, guys.
Which
Thank you.
is not surprising. I'm not seeing any questions yet. A lot of comments about how detailed and how they love what you're doing.
Thanks. I'm having a lot of fun with it. It's the Sculptober challenge is really, I've been having an issue with how slow I am. So Sculptober, they're definitely a lot simpler models. I'll stop my share here. They're definitely a lot simpler models, but it's forcing me to have to just make a decision and go with it and just block stuff out and just do it, which has been helping me a lot. Because that's mainly what I've struggled with is the first blockouts and just getting that shape of the characters and stuff like that. Garrett used to actually, we would kind of flip-flop models, and we work really well as a team because he's very quick and good at getting that general shape. And like the Rancor model, I keep going back to that one, but we worked so well together on that. He did that general first shape, and then I really enjoy doing that tedious, like just custom wrinkles and the bumps and the, all of that skin detail and the teeth and all that. I really like doing that sort of stuff, all the high detail, and he does not. So, and I think mine may come from when I used to do cakes. I did a lot of really tedious stuff, so that doesn't bother me. But I've always, that's what I've liked to do. So this Sculptober challenge has kind of forced me to do the opposite, which has been really good. So yeah, if you guys don't follow me or Chaos Core Tech, Garrett, check us out on Twitter and Facebook, or not Facebook. We don't do Facebook. Sorry. I know that's some people love it. Some people hate it, but YouTube, Twitter, and I have been posting every day my Sculptober models, and those are all uploaded to our Patreon. So they've been pretty fun, just cutesy little models. Some of them are really super easy to print. So if you're looking for fun prints, there's a lot of fun ones today. Bob Ross went up. That was Garrett's idea for nature, and that turned out super, super cute and fun. So you'll have to check that out over on the Twitters.
There are a couple quick questions for you,
Perfect.
Chelsey.
Perfect.
So we got some time. One of them was, how powerful of a PC do you need for ZBrush, and do you use a mouse or a stylus?
So honestly, I just recently switched over to a decently powerful computer. I was actually on a pretty old, crappy laptop, and it did pretty well. You do have to be careful about how high your poly count gets. But the best way to get around that is to use the subdividing. So you really have a really low poly count, subdivided a bunch so that it's not solidly in that like 10 million mark. You can kind of bump it down, work on it, bump it back up, see that detail. So really you can get away with using not a crazy powerful computer. ZBrush is intensive in some ways, but for the most part, it really does not require a whole lot. Garrett could answer that question better on technical stuff. So if you want to know that, message me on Twitter and I will get to it as soon as possible. But like I said, we're super busy today. But then what was the other half of that question?
Do you use a mouse or a stylus?
Yes. I actually used to use a mouse when I was sitting on the floor with my injured dog. I used a mouse for a very long time. The only issue with a mouse is you do not get the pressure sensitivity with a lot of the brushes, and it definitely makes a difference in some of those. So ideally you want to use a stylus with even if it's not a monitor drawing tablet, you could get one of those like $50, Wacom tablets that it's just the drawing part and you look at your screen while you do it. That would work great too. But you really do want pressure sensitivity with the stylus and the drawing monitors for for ZBrush. It's ideal unless you're going to do all Z modeler, which then you probably don't need ZBrush. So
All right, and I think Chelsey, you got a couple minutes left. Time for another one?
perfect.
All right. So question was, how do you export for 3D printing without losing a lot of quality?
So actually, ZBrush does a pretty good job. Like this one right here, when I did it, it was probably up in the millions for a poly count. Let me share my screen one more time here. So this one that I was showing off easily was potentially 3 to 6 million in the poly count, which you cannot have a file that large for 3D printing. So when you are going to export it, there's a Z plugin for Decimation Master. And what you're going to do is you're going to decimate it. And honestly, I usually get it down. This is actually the STL that I put out for 3D printing, and it's about 300,000 polys. That's about good for something like this. You could probably go a little lower, 200,000, but as you can see, if you zoom clear in, you can see those polys like in there. But I mean, this is in ZBrush, so it looks way worse than what it would look actually printed. But this is clear decimated down, and it looks great when it's 3D printed. I have one printed in resin, and it looks super fantastic. So you can decimate it, down to like that 10% of 3 million, so you can get that 300,000. And that's usually about where I like to keep it. I don't like to keep it much more than 300,000 polys for exporting for 3D printing. So.
Awesome, Chelsey. Well, we are right at the top of the hour, 2 o'clock. You answered that in perfect amount of time. And I wanted to say thank you so much for popping on.
For sure.
And maybe some people who still have questions, I forwarded them towards the Discord server.
Okay.
I don't know if you want to have the opportunity to jump in, or if you really just want to go do flooring.
I mean, I don't want to go do flooring, but I'll try to pop in and see what I can answer in between the rest of our day here. So
awesome. Thanks so much, Chelsey.
Perfect. Yeah. Thank you guys.
All right. And with Chelsey leaving us, I am going to bring in our next speakers, who probably don't need too much of an introduction. One for sure you guys are going to know as one of our platinum sponsors ever since the beginning of ERRF/VERRF, Dave's man, I almost just butchered that. Dave Randolph from Printed Solid. I almost just called him Dave Solid. I kind of feel, David, sometimes like it may be that you and work are very similar. When you're posting things about falling asleep in front of a filament line, it's questionable.
Yeah, I live and work all in the same space.
I will let you guys to it. It is all your show.
All right, wonderful. I'll start off real quick, just so we have that, and then we'll move on from there. So today, what we're going to do is, actually, I should start off. I'm David Randolph from Printed Solid. We're a 3D printer reseller here in Newark, Delaware, USA. And one of our specialties is 3D printer enclosures, safety enclosures. And we do a lot of time focusing on safety, air filtration, heat retention, things like that. And one of our best partners in that journey has always been BOFA International. We went searching for a really good, high quality filter, and BOFA fit all those bills. But in the time that we've worked with them, we've also really learned a lot about filtration. And one of the things I wanted to do is I wanted to get one of BOFA's engineers online here and do a presentation basically on the anatomy of a HEPA filter and what makes a good filter, why you should filter, things like that, and actually kind of dispel the myths and put out some facts and some truth about air filtering and 3D printing so everyone knows. With that said, I am going to head and hand it all over to Josh. And if they did it correctly, I should be able to stop the focus by turning off my camera here. So let me do that. And let's see, I don't know if it actually did it or not.
I don't currently have the facility to share, so I don't know if that still needs to be passed across. Oh, no, got it now. Here we go. Okay. Hello, everyone. I'd like to introduce myself. I'm Josh Evans. I work, as I said, for BOFA International. We're a fume extraction specialist company based in the UK, but we do have offices worldwide, and larger, we're part of the Donaldson brand, which is a huge, huge organization to be part of. We specialize in fume extraction and filtration, so taking dirty air and making it clean and safe for people to breathe. My background is in chemical engineering. I'm applications engineer and head of learning here at BOFA. I've been working at the company for since 2017, actually, but my specialty is in chemical engineering, so particle mechanics, absorption chemistry, fluid dynamics, basically all of the good stuff that makes up capturing a hazard and filtering it safely. A few things I'd like to go through today. First of all, we're going to talk about what's actually given off by a 3D printing process. We're going to look at a few examples: filament printing, stereolithography, and direct metal laser sintering. Then we're going to say, okay, what's actually harmful about this stuff? Why do we want to filter it? Why do we want to make it safe? Next, we'll look at the legal position. So what regulations are in place to look after people? And then finally, as you said, look into what we actually need to do to filter it. Now we've seen what's coming off and what we need, the regulations are. How do we actually do it? What makes a good filter? What makes a bad filter? What are the considerations we need to make? So first of all, we'll look at what the fume actually consists of. And we'll start with filament printing. As you know, this is where you get your filament, pass it through a heated nozzle, and lay it down layer by layer to make your product. First of all, we'll look at some research that was done by the Health and Safety Executive here in the UK. So there's been a bunch of different research that's showing some good stuff. The Health and Safety Executive here has done some really good work, but also the University of Illinois, if you want to look that up online, have done some really great research and analysing what's actually being given off. First thing we're going to look at is particles. We'll divide it into particles and gas. So the particles being given off, this graph on the left is what we call a particles distribution graph. So it looks at all of the particles being given off by a process and then sees what size they come up with. Don't know if you can see along the x-axis, we have the particle size in nanometers. So for those that aren't aware, a nanometer is 1 billionth, that's with a B, of a meter. And what we're seeing, this is taken from a PLA filament, is that the majority of the particles lie in the 10 to 40 nanometer range. So very small particles being given off. The other thing that they looked at was the number of particles being given off as a factor of nozzle temperature. So as you can see here, we're looking at temperature in degrees centigrade. I'm afraid it's not in Fahrenheit. But as you change the nozzle temperature, you see this quite drastic increase by a factor of almost 10 on the size of, the number of particles being given off. So it's one of these things where actually reducing your nozzle temperature can significantly reduce the number of particles that are being given off. Another thing that they found, which I didn't show here, is actually the higher the nozzle temperature, the smaller the particles expected to be given off are. And we'll go into why that's important a bit later. Then if we look at the gases being given off, So again, this is taken from a PLA filament. And what you can see is there's some variation in temperature, not as much as we saw with the particles. But as you can see, PLA, polylactic acid, one of the main emissions are lactide, and then variations of lactic acid here in this group. But what we find quite often is people think of PLA or ABS. And because ABS gives off styrene, which is it's horrible. It's people listening will know it's really not nice. And then they switch to PLA, and because they don't get as much of a smell or burning, itching, as I've heard in some cases, they think it's safe. But what we have to explain to people, just because you can't smell something doesn't mean it's there. It's not there. And the PLA filaments are in fact giving off quite a large number of particles, quite a large number of different gases. Then we'll look at stereolithography. There's a wide variety of chemicals being given off. And one of the annoying things about this, particularly from our perspective, is that a lot of these is held as proprietary. So you'll never actually know exactly what's going into it because the company holds it as a trade secret. But looking at the material safety data sheet, which is an excellent tool to find out what's actually in your product, you can see a bunch of different chemicals here. Acrylate oligomers, methyl methacrylate oligomers, acrylate monomers. These are the building blocks of the plastic that go into it, and then photoinitiators, what you can expect. And you'll really expect a lot of the emissions from this just to be the vapors from that raw material. And if we look at the first aid measures for a typical component, you say this product is light yellow in colored liquid with a characteristic odor. This product may cause skin and eye irritations. The inhalation of high vapor concentrations may cause a headache and nausea. And then under inhalation, in case of exposure to high concentrations of vapor or mist, remove person to fresh air. If breathing has stopped, administer artificial respiration, seek medical attention. Now, obviously, they're putting a lot of this stuff in there to cover themselves legally, but it shows that high concentrations of this stuff really isn't good for your health, and anything you can do to minimize this is really good. Then we'll look at metal laser sintering. Just briefly to talk about this because it's something that people aren't necessarily aware of when they buy this equipment, is that it's often done under an inert atmosphere, either nitrogen or argon. This is to prevent the metal from oxidizing. But what you can find is that it's done under this incredibly inert atmosphere, and you need a filter system to protect the laser and prevent any beam dispersion, actually, to preserve the quality of your mark. So you need a filtration system which collects all of these very fine particles that are generated by the laser. And then once your build is over, you pull the filter system out, suddenly expose it to air, and you're normally dealing with aluminium or titanium, which are actually highly flammable when they're in a fine particulate. And when you expose them to air, they suddenly combust. We've heard stories of people, it's their standard procedure, major companies, it's their standard procedure just to take these filter systems outside, leave them in a field, open up the top and walk away. And then it just catches fire and just wait for it to burn out, which, as you can imagine, isn't the best operating procedure. So we're actually working on a filter system that will solve this issue and help you safely dispose of the particles that are being generated. Okay, next we'll look at what's harmful. There's a couple of diagrams on the screen at the moment. These can be a little bit of oversimplifications of what's actually happening, but they're good indications. And what they tend to show is that around 10 microns, so again, before we were talking about nanometers, now we're talking about microns, micrometers. So these are 1/1,000,000th of a meter. So they're 1,000 times bigger than the particles that are generated by your typical filament printing process. So around 10 microns, particles will enter the mouth and the nasal cavity. When you get down to 5 microns, they'll start entering your respiratory tract, your trachea. And then 2.5 microns, they'll start getting into your lungs. And then when you get down to 1 micron, it's when it can reach the furthest extremities of your lungs. And if you remember from the filament printing, the research, we're talking 2 or 3 orders of magnitude, so 100 or 1,000 times smaller than 1 micron. So the particles being generated by 3D printing processes can get right into the extremities of your lungs. And that's kind of shown by this quote. This was research actually done into the effects of nanoparticles. It wasn't specifically looking at 3D printing. It was actually looking at, because nanoparticles are generated by diesel engines and other industrial processes, but this is a quote from that. Insoluble or low solubility nanoparticles in biological fluids are the greatest cause for concern. Because of their tiny size, several studies have shown behavior unique to nanoparticles. Some of them can pass through our various defense mechanisms and be transported through the body in insoluble form. Thus, some nanoparticles can end up in the bloodstream after passing through all the respiratory and gastronomical membranes. They are then distributed to various organs and accumulate at specific sites. Others travel along the olfactory nerve and penetrate directly into the brain, while still others pass through the cell barriers and reach the nucleus of the cell. Several effects have already been shown in animals. Among these, toxic effects have been identified in several organs: heart, lungs, kidneys, and reproductive systems, as well as the genotoxicity and cytotoxicity. The paper does then go on to say that concentration is obviously very important. If you're exposed to 1 nanoparticle, it's very different to one being exposed to 1,000,000. But it's some interesting data there. What it's effectively saying is, if the nanoparticle is made out of something that's insoluble, like say a plastic, which you would expect a 3D printing process to be generating, then it doesn't just dissolve in the bloodstream and get diluted. It passes into the bloodstream and gets transported around the body. And then anywhere where you can kind of create a blockage, particularly I think the kidneys, because the kidneys themselves are filters, you can get this build up, and it's when it starts to build up that you can see serious issues. Next, we'll look at the gases. So your lungs have a rough surface area of a tennis court, which is this huge surface area. And it's a direct path into your bloodstream, which is why things like inhalers and cigarettes affect you a lot faster than tablets, because it's a direct path into your bloodstream. And you've got this huge capacity. And anything that, as we say, is water soluble will have this driving force to pass into the bloodstream. Or as we said, with particles, it can pass into the bloodstream and then start building up. Now, I'm afraid I'm going to have to use some UK statistics. I'm aware that many of our listeners are from the USA, but the UK government does a really good job of tracking workplace-related health, and they come up with this really good survey called the Labour Force Survey. And what they've found is that every year, and for the last several years, these numbers haven't changed, they haven't gone down much. Every year, 12,000 people in the UK die from workplace-related lung disease. So to scale that to the US, the UK has a population of about 65 million. So roughly a fifth of what we can see in the US. And I can tell you that the UK regulations tend to be a lot more stringent than in America. Now, a lot of these deaths are linked to asbestos, and they're historical, as you can see from the pie chart. But it really shows you how important it is to understand the air that you're breathing in, particularly when you think about how long the build on a 3D printer takes hours. So you're getting these long-term exposures to particles and chemicals. So then we'll take a quick look at the legal position. Every country's got its own set of regulations, but they tend to come to down to the same two rules. And the first rule is it's the responsibility of the employer to look after everyone on their site. So in the USA, it's the OSHA Act of 1970. Each employer shall furnish to each of his employees employment and a place of employment which are free from recognized hazards that are caused or likely to cause death or serious physical harm. So there you can see, making it the responsibility of the employer. And I'm aware a lot of people listening will be hobbyists, or that they won't be using printers in a working capacity, but a lot of these kind of regulations translate. So the next thing is to set what we call occupational exposure limits. And what these are it's a list of chemicals, and it tells you what concentration of each chemical you're allowed to be exposed to. One thing I will note about this is there are regulations for particles that you're allowed to be exposed to, but there's no specific regulations for nanoparticles, which is something I think is really lacking in these regulations. As we saw before, the size of the particle really does matter, and whether it's large or small, nothing's good for you, but the smaller it is, the worse it is. And I really do think that there needs to be an update in these regulations to account for micron and nano-sized particles. But if you want to look at the exposure limits for the USA, they can be found in OSHA annotated tables Z1, Z2, and Z3, or Z1, Z2, Z3. And this is what it looks like. As you can see, you've got a substance name on the left-hand side, but each chemical has 20 different names, depending on the naming system you use or the language that you speak. So each one has one CAS number, and that's a registration number specific to that chemical, so you can't get confused. And then, as you can see, in America, there are a few different governing bodies. So you have the OSHA permissible exposure limits, which assume that you're working across kind of an 8-hour time-weighted average. Then NEOSH have their own numbers, and the ACGIH have threshold limit values. A lot of these numbers, as you'll see, are very similar, if not the same, and they show you how. So for acetone, which you may use post-build to kind of clean off your product, across 8 hours, you're allowed to be exposed to 500 parts per million. They also give a short-term exposure limit. So this assumes that, oh, maybe you'll be exposed for 15 minutes or so, and therefore you're allowed to be exposed to a slightly higher concentration. So the short-term exposure limit is 750 parts per million. It's a brief overview of how the regulations work. So now we're going to look at the filtration of fumes. Just so you know, BOFA extractors tend to work for 3 stages of filtration. The first stage is a low-grade pre-filter. This filters out the large particles, normally kind of general background dust from the room. The main purpose of the pre-filter is to protect the next stage of filtration, which is the HEPA filter. HEPA stands for high efficiency particulate in air. It's a high-grade particle filter. We'll look a bit at the mechanics later, but that's the one that's really high grade, and that's the important one. And then after that, we have a carbon filter, activated charcoal, which filters out the gases. So we're going to look at the HEPA filter. As I said, HEPA stands for high efficiency particulate in air. BOFA filters are 99.997% efficient at 0.3 microns. And people say, oh, 0.3 microns, we're getting particles smaller than that. Why don't you have a higher grade filter? But filters don't really work like people think they do. They don't work like a sieve or a strainer where you've got holes, and if the particle's too big for the hole, it can't go through. There is a little bit of that. As you can see, we've got a graph here where we've got particle size along the x-axis and filter efficiency along the y-axis. And this is your sieving effect. So your particle comes along here, it can't fit through, but as you can see, this drops off pretty quickly. This effect, as particle size decreases on the blue line, the filter efficiency for that decreases. But then you've got inertia and interception, which go a bit further. What these are, either the particle will just come along and hit the filter fiber and be filtered, or as the air moves around the filter fiber, it'll the particle will try to move out the way, but it's not as free moving as the filter fiber, so it'll either hit that one or it'll go and hit the next one. But those are kind of more conventional ones. The important one is diffusion, or what's known as Brownian motion. And this is the one we want to focus on. What it is right now, as you're sitting in your chair or wherever you are, the air is hitting into you. It's exerting a pressure. The air molecules are hitting you. But because they're very small and you're very large, they don't really have an effect. You can't really feel it. But when you start getting these really tiny particle sizes, the air hitting into them really has an effect. And instead of moving through an airstream like this, nice and straight, they start moving really erratically because the air is constantly bouncing into them. The smaller they are, the more erratically they move, and the more erratically they move, the more likely they are to come into contact with a filter fiber. And that's why, as the particle size decreases, the filter efficiency increases, and that has a massive effect on this. And this is test data that we've had done. So as you can see, particle size decreasing, you get this lower dip, and then it actually increases. So for the nano-sized particles, you get this increase in filter efficiency. Final thing I want to look at is the activated carbon. So BOFA's activated carbon is actually made from coconut shells. It's then specially treated and impregnated with particular chemicals to give it specific properties. It's really good for organic vapors, which are the type of things you expect to see coming off 3D printing. And there's a few things that are really important to consider. One thing is granularity. So the size of the grain is really important, because obviously the smaller the grains, the higher the surface area, the more filtering you can get. But that increases the pressure drop, so the resistance to airflow, which decreases your airflow and means that you get less capture. So there's a balancing act there. Another great important thing to consider is the residence time, so the amount of contact time between the gas and the filter, and that really is really important. You need to make sure that you've got enough, but if you've got too much, then you'll get higher resistance to airflow, and that will affect the rest of your system. And the other thing is packing. So air will choose the easiest flow path to the least path of resistance to flow through, and so getting the packing uniform throughout your filter is really important. And if it's shifted over to one side, then all of the air will go through the other side, and that will mean that you're only using half your filter. And we actually use specialist packing tables, shakers to set up our filters. And that was everything I wanted to talk about today. Thank you.
Well, thank you, Josh, for coming. We're getting real close here. We're about to run out of time on this, but we did have one little question that I was hoping you could touch on for everybody. Could you tell us probably why it's not a good idea to put a filter inside an enclosure?
So are you saying like just leaving, say, some carbon in an enclosure, or
actually let's say putting a filter machine inside of a heated chamber?
Oh, okay, yeah. So that's that's not great. So for adsorption chemistry, if you increase the temperature, the forces holding the chemical to, say, your activated carbon are weakened or overcome, and that can actually start liberating gas. And when you constantly swing your carbon through hot, cold temperatures, it can reduce its effectiveness. You've also got to think about maybe the sealing on your filters. And the final thing is, if you're putting this inside your enclosure, then your enclosure isn't under negative pressure. So there's nothing stopping particles and vapors just diffusing out any gaps in it. So yeah, not a great idea.
Well, wonderful. I know it's extremely late or early, one of the two over there for you.
It's getting late.
It's getting late. So, and it's the weekend for you. So I appreciate you coming on board and kind of giving a quick rundown. So I think this stage is better to kind of teach more consumers about air filtration and 3D printing and a little bit what they're looking at. All righty. I think that's everything. And I think Nick is about to kick us off.
I wouldn't kick anybody off, but I do appreciate that, Josh. That was amazing as I was listening to it and thinking about our current setup here and how maybe we should filter just a little bit better. But thank you so much. It is greatly appreciated. If you guys have questions for Josh or for Dave, don't hesitate to jump into the Discord. I know I've been looking at the Discord. I know that some people have been putting stuff in there. Dave, you've been responding with them. So keep that conversation going, guys. And again, thank you so much for educating, I will say me for sure, on stuff that I need to be thinking more about.
It's a pleasure.
Have a good one, everyone.
Right. And with that, I am going to bring in our next speakers, because what we have next is very much in the realm of Ms. Vicky Somma. And so I am going to disappear and I am going to let Vicky run this.
Everybody's joining us. All right, well, good afternoon, everybody. Again, this is Vicky Somma from the ERRF team, and what we have for you right now is a education panel, and we have very seasoned educators who've been working with 3D printing for at least 4 years or more in their curriculums in their schools. And today they're going to talk about their experiences, and they are going to share some tips and tricks, some best practices, and maybe some challenges that you can expect as you try to incorporate 3D printing into your lesson plans. And I think my co-host today is Matt Flinchbaugh from the How I Do It channel, and you may also know him from the Friday Night 3D Printing Community Hangout. And I believe he has some introductions for us.
Yep. Thank you, Vicky. So first of all, I just want to thank everybody, all our educators who signed up to join us today on the panel. First up, we have Michelle Styer from the Janus School, which is a kindergarten through 12th grade school level. Michelle teaches or has taught for a total of 21 years and has incorporated 3D printing for 4 of those years. She utilizes 3D printing for math, reading, science and social studies, art, and general education aspects of everyday life. Her accreditations, I had to include these, Michelle. Her accreditations are through trial and error and self-education. Next up, we have Joel Cilli. Joel is from the Pennsylvania Cyber Charter School, teaching middle and high school level. He has 10 years of teaching, 7 of which include 3D printing. Joel utilizes 3D printing for the understanding of mechanics and subsystems, design as it relates to additive manufacturing, for example, support lists or minimal supports and tolerances. He also utilizes subtractive manufacturing with CNC milling and laser cutting. He focuses more on utilizing the equipment and technology as part of the educational experience. Then we have Josh Ajima. Josh teaches at the academies of, Josh, forgive me if I pronounce this wrong, Loudoun, and the Loudoun County Public School. He has 24 years of teaching, 7 years of which include 3D printing. He utilizes 3D printing as a tool for teaching STEM. Some of the students that he teaches include entrepreneurship students, radiology students, biology, research and development, and mechanical engineering students. He utilizes 3D printing for development, research, and spatial awareness for all of those different categories. His accreditations, Josh is the Zero Things project founder. He is published in multiple magazines regarding 3D printing, a lot of maker magazines. Tinkercad, Pinshape, Thingiverse. He's a featured designer on all of those platforms. And he is VSTE Innovative Educator of the Year. Next up, we have Don Dagen. Don is a teacher at the Thaddeus Stevens College of Technology. He teaches college level, of course. Don has 7 years of teaching, 6 years of which utilizing 3D printing. He utilizes 3D printing by integrating 3D design into projects, as well as assembly of Jellybox 3D printers by the students. Don's accreditations are Ultimaker Educator Pioneer and Morphe Educator. Last up, we have Josh Ayers. Josh teaches at the Worth Industry North American Indiana School for the Blind, kindergarten through 12th grade, and also engineers. Josh has 8 years of teaching, and Josh is a little bit special in this one. He has 8 years
I believe you're talking about Jacob.
I'm sorry, Jacob. Sorry, Jacob. Jacob has 8 years of teaching, 9 years utilizing 3D printing in the classroom. Jacob utilizes 3D printed models for the blind, utilizing hands-on education so they can feel what they may not be able to see very well. He uses 3D printing for workforce development and additive adoption in industry. Did I get that right, Jacob?
Yeah.
Okay.
So I don't work full-time at a school anymore. I have a industrial 3D printing job now, but I still teach.
Okay. And Jacob, sorry, too many J's.
Yeah, we have a Jacob, a Joel, and a Josh.
Yeah. Jacob, his accreditations is over 70,000 hours of printing. So that introduces everybody. And of course, we have my co-host, Vicky Somma, and Vicky has the YouTube channel, T-Golf 3D. So for the format today, we're just gonna let the educators talk amongst themselves. I do have one starting question there to get the conversation going, and this is gonna go to Joel. As you guys heard, Joel teaches for the PA Cyber School. He has a unique perspective that is very useful to educators currently, considering the current pandemic and remote learning. Joel has been doing this prior to the pandemic, so he has some experience. Joel, how do you accomplish using 3D printing and subtractive manufacturing with your remote students?
Thank you. So I've been doing this for about 7 years. I've been doing 3D printing with students, and it really is kind of like ordering your parts from Shapeways. The students complete a design, they share it to me digitally, and I print and ship it to them. So to bridge the gap that they're lacking the machine hands-on experience, I put a lot of emphasis into things like, so if you're a remote teacher and you want to send your students the 3D parts that they design, you print it out, pack a piece of filament in the package, because they don't understand what it looks like before it goes into a printer, right? Show them videos of your printer running. I often will pack them little extras. So like if I have a student whose print fails, I'll print it again, but I'll send them their failed part, right? So there's ways that you can give that machine experience. I also,
gummy bears?
Yeah, I should send gummy bears, right? That seems to be part of the experience of being a 3D printer consumer, right? Is that you, not just from Prusa these days, that I got gummy bears from Atomic Filament on my last order. But one of the things that I also really enjoy is having my students do cardboard like demos of things as well. So we did these little phone stands where I gave them the scenario, you know, when you try to read a recipe on the kitchen counter, you have to lean over your phone. Wouldn't it be nice if it stood up and looked at you? And so the idea of like, how tall does it need to be if your phone's not going to knock it over? How wide, you know, how a little brace that maybe would cover the base of your phone and things like that. You can cut those out of cardboard and model them at home. And then use it as a guide to make your 3D design. So it's all about just finding ways to connect that. And what I'll do this afternoon, and I'd be happy to share as well, is I also have a 3D printer that's color-coded by axis, because it visually makes a video while it's 3D printing, very engaging about how the 3 axes of a 3D printer come together. So,
which I believe if anybody in the audience went to ERRF 2019, that was on display, right?
It was, yes. I have a new version for this year that's a little tighter on the tolerances, and I'll be sharing the design this afternoon. That it now is fully editable for you to just customize the openings if it's too tight or too loose, and some other cool features.
Michelle, I know you said with the remote learning prior in our conversations, this is kind of, you know, utilizing 3D printing remotely and being able to let the students still do it. Do you have any questions for Joel as far as, you know, how his curriculum goes or anything like that to involve the students? He said he sends it out to them once they design something. But if any of you guys, the whole panel, not just Michelle, if you guys have any questions for Joel about how to do this remotely, have at it. Go. You don't have to wait for me to ask you.
Thanks, Joel, for sharing what you were talking about. That's kind of a big question. It's been about 8 months now since we've been doing virtual, at least in some aspect. Right now we're hybrid, so we have 2 days in and 3 days at home. So at least with the hybrid, at least we can do some more of the designing when we're at home and then do the actual printing when we're in the building at this point, at least. I was also thinking how, especially with our kids, they see, you know, the designing, Tinkercad, things like that, they see it as the end result being actual printing something, you know, tangible, but there's so many other ways that you can use 3D design that doesn't have to be, you know, that tangible object. I think this would also be a good chance to, you know, talk to kids about where else 3D design is applicable, you know, besides actual printing.
That like video games?
Mm-hmm.
So that's a really excellent tangent there about how it's not just right to 3D model to get the printed part. I actually find that a lot of my students, when they make something that's not one of our class projects, it'll be something where, especially if they're using Tinkercad, that Tinkercad has all these things like where you can make like these little house dioramas and things like that, where it's like, oh, cool. So we'd never see any of this on the inside because it's a solid wall to it, right? That some stuff is just a good modeling experience. And I believe that in my format, because we were cyber school and we must have a print on demand structure to ship it, that, you know, I don't often encourage just modeling something without an end result of getting it in the mail. But that is a really relevant thing right now as we're doing hybrid, is like, you could be prototyping and using like an AR app, you know, 3D Bear is a good example of this, where you can just download your file and like pop it in the, you know, like look at it on your desk as a 3D AR thing through your phone, right? And like other tools like that, so that you could just experience like, you know, what is that 3D object and how might it interact with your life, even if it's not printed.
I'm going to put a shout out for, you talked about rough prototyping, and I'll just use this quick. Matt Wettergreen, I think is a professor, this is out of Make Magazine, low fidelity prototyping cart. And that's intended for in this COVID hybrid times. And I think once somebody gets turned on with 3D printing, they want to 3D print everything. And certain things should be machined and never 3D printed. Certain things should be laser cut or water jet cut. So I think it's important as we introduce technology that we also introduce the things good designers do. And I'll end with a quick story on this comment. A lot of times if a print takes like a day, I'll push my students to make a cardboard mock-up while it's printing. And I've already had my students stop a print. They realized they made a horrible mistake, and they found that by doing a cardboard, I call them paper dolls. So I'm a big fan of teaching all the iterative elements that designers use.
So I want to just toss this out there because I really love Cocoa Press, and I feel like they should be marketing themselves as the like test your dimensions by printing it in chocolate, eat your test dimension, and then go and print it for real. So if Cocoa Press is watching, you know, there's your shout out.
That's an excellent idea. That would go over really well in classroom too. So one of the questions that I've heard a lot from educators who are trying to get into 3D printing or bring 3D printing into the classroom is how to overcome the challenges. What challenges have you guys faced bringing 3D printing into the classroom? Feel free, whoever wants to jump in first on that one.
I'm gonna throw something out there that, you know, I watched a lot of the Construct 3D sessions and things like that, and people usually when they tell their stories about doing 3D printing in the classroom, it's usually a seasoned teacher. It's usually somebody who can recognize before they even try to print it, hey, somebody left a gap in this model, it's gonna come out and split apart and whatever else. The beginning 3D printing teachers need to know that like a lot of bad models will slow you down, and you will spend a lot of time wondering, should I have not tried this, right? And the answer is you should try it, and you should keep pushing through because experience will teach you those things. You'll grow just like your students will grow. But I watch a lot of presentations where I feel like people don't want to talk about the like first 3 years where you were wandering blind in the dark. Sorry, Jacob, I wasn't meaning to get that out there. But you feel like you can't see where you're going, and you're worried about how you're going to get to the end of that road. You know, you have all these backlogged prints, things aren't working, you got troubleshooting that you don't know how to do. You know, pick good friends that are also into 3D printing in the classroom, have them support you and encourage you, help you troubleshoot. You know, I go and help a local friend of mine every time her printer, you know, isn't working correctly. Network is key. Network with other people that are doing this, and they'll lift you up when you feel like you can't do it. And tell your students, you know, like, hey, I can't tell why I can't get your model to print, but something might be wrong with it. They'll grow too. And before you know it, you will run smoothly. I still hit bumps in the road all the time, and I've been there for like 7 years. So that is normal to have things that don't go as planned.
For me, running a makerspace service bureau inside of a school, my issue was always getting people to wrap their head around like what was possible and what they could do. Like it took about a year or two before the staff really kind of figured out what was possible and what was reasonable to ask for. And for me, I ended up just like looking at, you know, 50 people's interests and making them some little widget that would be like their aha moment of like, oh my God, this is what this is. Because like when I started formally working in a school, outside of doing just printing at home and whatnot, it was you find that like some people's expectations of what 3D printing is like a paper printer, and overcoming that in 2015, 2016 was a struggle. And then once you got people on board, they wouldn't leave you alone. So.
Michelle, with your use of 3D printing kind of jumped out at me in the surveys that I had sent out to you guys ahead of time. You're utilizing 3D printing in virtually all aspects of elementary school, all the way to 12th grade education. How did you get started for like reading class, things like that? Like art class, that kind of, everybody can picture how that works. Science to some extent, you know, printing models and things like that of atoms and molecules and things. But how'd you get started with the like reading and spelling? How'd you end up utilizing 3D printing for that stuff?
When we started about 4 years ago, there was just a lot of enthusiasm. There wasn't a lot of, there was enthusiasm, but they weren't sure how to use it. They didn't quite understand 3D printing enough to see the kind of use for it. And so our ed tech committee kind of got together and we just sat down, we just brainstormed and did a lot of Googling. And once we kind of thought of one idea, it kind of gave us ideas for other ways that we could use it. I'm the director of technology. I'm a department of one, so I do pretty much everything in our school and I teach as well. So it was a lot of, I would learn everything and then I would just take that and I would be the support for teachers who want to use 3D printing in the classroom but don't know how to. And they weren't, you know, they didn't feel brave enough to take it on themselves. And it's gotten to the point where like our teacher, she can just go do it and she's really good at it and she doesn't need my support anymore. And it was supporting each other and just kind of talking as curriculum areas about ways that we can use it. And it's been really, really neat to see. Yeah, it's been great. I'm sorry if you can hear my garage door. I'm sitting right above it and it just went up. So I'm going to mute for a second, continue talking.
Josh, I believe you have 3D printing incorporated in a whole variety of subjects as well. Was that difficult to sell the teachers on?
Well, I'm at a STEM school, and so definitely for the engineering programs, 3D printing is like water. So it's not really difficult to get them on board. Those teachers understand the capabilities of 3D printers and how they fit in their curriculum. But we also have a lot of career and tech ed programs, like for instance, radiology or biology teacher. Like, how do they go and incorporate that in? And so sometimes we'll get things like, could you 3D print a full-scale human skeleton for me? And it's like, well, if there's a model out there available for you, sure. And so, you know, getting teachers to understand there's a difference between something you saw in a magazine, or there's a difference between there being a model of it and being a good model of it. And so, for instance, we printed out foot bone. So this is a heel bone for the radiology class. And so I have a pile of bones here. And so you would think that there would be an entire human skeleton available that's anatomically correct for you to print out all of the pieces. But I've had difficulty finding one, but I could find the foot. And so we were able to print these out. The kids were able to look at that in NetFab, label all of the parts, color code them. We made some really cool diagrams. And then the kids kind of in a forensics file sort of lab took all of those pieces and assembled it together. But, you know, that really relied on us being able to find a model that really fit what that teacher wanted to do. And sometimes you hit the point where you don't, and that teacher doesn't have time to scan and find all that stuff. So you really sometimes have a narrow window for a content area teacher to really get the thing that they want, print it out, and be able to write a lesson or incorporate it in a unit in a meaningful way.
So quick note, out of all the 0 things, I did not expect a human skeleton to be in the 0 things category. And you may want to explain that real quick for people who aren't familiar with that.
Yeah, before I worked at the STEM school, I worked at a regular high school, and I was a technology person, was trying to figure out how to introduce digital fabrication into the curriculum. And so we had a high English language learner population in our school. And when National Hispanic Heritage and Culture Month came up, which is right now, as a matter of fact, when I went out and searched for some things, found very few things, 0 things. And as an instructional lesson, had the students design models and write about them. So going from 0 things to 1 thing. And so that's a way to engage content area and teachers. Like, if you can't find the thing, then there's a real low floor. Anything that your students design and publish is going to be a contribution to the world.
Sorry, my mute button stopped working. So talking about like the 0 things, the 0 things project helps a lot with kids acquiring spatial awareness. How have you guys utilized that Don, that's a big thing that you like to focus on is spatial awareness. How do you utilize that in your classroom?
One thing I've realized when I started teaching, I've averaged like one female student in a very traditionally male-dominated field of maintenance technicians. And I had a preconceived notion that they would struggle and the male students would automatically have 3D spatial awareness. And it turns out most 18-year-olds have very little spatial awareness, even those that have lived in video game worlds. So a couple of the things I use, and I'm very curious because I'm guessing sometimes maybe the rest of the educators are creating this and you don't know you're creating it, and your students progress later into their higher ed and don't even know where they got it from. And the id is spatial awareness. So one of the things I use, this is a card that comes with this Kiva Brain Builders, and I saw this on Google. So Michelle mentions just Googling things. And I've read a lot of research about spatial awareness. There's a guy out of Purdue, Dr. Bodner, and he does folding things with his chemistry students. And he saw a really strong female-male, and I think that was in the 90s. So if you research this, you'll see a lot of things. But the way this Kiva blocks works, and I color code them, they don't come that way. And students have to create, and this is called orthographic projections in CAD. And when you learn how to take a 3D object, and that's pretty obvious, that's a field goal post. So it's showing, you know, the edges of the blocks and how to build them up. So that's one way I tackle it. But I'm curious the other educators in the room. And actually, Vicky and Matt, I suspect your kids have spatial awareness that their peers do not have.
I know my kids are very adept at Minecraft, which I keep pointing out to them, like, this is 3D modeling. This is 3D modeling. And it is amazing how they go from, like, literally when they started Minecraft and night came, they would just dig a hole and wait in there all night because they didn't want the skeletons or the creepers to get them or whatnot. And then now they just build these amazing things. And I'm like, did you see this somewhere? And they're like, no, this is, like I imagined it and I made it. And
some of my strongest students are Minecrafters.
Yeah. Which I guess, I was going to ask a follow-up question to Josh. Like in 2018, he was one of our first speakers at ERRF, and he talked about some of the most engaged students in 3D printing were the people in the anime club. And so now I was wondering about the Minecraft and the gamers, if maybe they're a little bit competitive now too.
Yeah, so in the makerspace, we don't see quite as much of that. What we have done is made 3D printers available in the library. So students can go and do their lightsabers and other cool stuff. So I don't end up seeing as much of the passion projects as I used to, because we're trying to make that kind of forward facing where they don't need to go through me as a filter to be able to do that. We have had some issues because we didn't have a top of the line printer. So a lot of times the kids will do something crazy and it just doesn't print. But that's one avenue we've given for those kids.
And Michelle, I think I saw you nodding when I mentioned Minecraft. Do you guys use educational Minecraft in your school as well?
I believe some classrooms do. We do a lot of Legos, and Legos right there is a big spatial awareness thing. And what I found is spatial awareness, I mean, you're working on it just through the act of 3D design and printing, is you're working to strengthen those spatial awareness skills. And it really helped us at the beginning to do a lot of, I made a lot of models that show like layer height and wall width and infill percentages and those kind of 3D, spatial examples of these abstract terms that we're talking about really helped with that too.
And I have another spatial awareness issue in math, right? Sometimes you have super complex shapes, and we normally use 2D representations to show kids that. And so being able to have 3D models of things like that can be very helpful.
So Don, with your point about spatial awareness, I think I spoke to you about this particular problem before. So this is a little drawer box, that a student of mine made. And when we talk about, hey, you know, this perimeter needs to be like at least 0.8 millimeters to, you know, be structurally sound, the question then becomes, okay, so if this is 40, how big is this shape that goes inside? And the kid will just subtract 0.8 millimeters, but they need to subtract 1.6. And that's a problem that I put up every single year in my 3D design. I usually use a circle rather than, I find that with a circle, they tend to go the wrong direction. They'll just subtract it once instead of having for both sides. When it's a you know, multi-sided shape, you do hexagon, octagon, they usually will catch it. But when it's a circle and you say, I want to have, let's just say a 2 millimeter wall for this shape, what should I subtract from the center? They don't subtract that 2 millimeters twice, they just subtract it once. And I think that showing them scenarios like that and helping them realize where the conclusions they might jump to by default, you know, that they can learn something that they'll remember, right? They only need to see that experience once, and they'll always remember that whenever they're making whole subtractions like that.
Joel, I have a comment on that. So in my job now, I work a lot with seasoned, old, crusty engineers that have been designing for injection molding and machining for decades, and I get to see the full gamut of progression in terms of like spatial and 3D whatnot on the industry side now, where it's like you've got the people that are just now coming out of college into industry that have had like maybe an intro into 3D and like the tail end of high school and then going into college, versus the older people that are just the diehards that have been doing traditional processes. And it's interesting to see that the younger groups of where they've got these skills versus the older ones, because the older people, they will just send you anything and say, print this, make it. And it's like, no, we have to work through all these little things. And these younger groups of people get that. And I'm like, I'm really excited to see in like 5 to 10 years, like what the workforce looks like when you've got people that have worked through all these little problems like you're talking about from like elementary school all the way through to college, and who've just like mastered these little things. It's like, what does that make industry look like long term? It's like, that stuff is really cool. But so little things like your drawer are going to make someone's design engineer so much happier and their technicians happier in the future.
You actually remind me of a really potent story that when I first got into this space, I was actually an English teacher originally. So to end up teaching students about 3D modeling is nothing that I would have pictured for myself. So I went through a lot of those stumbling experiences personally, and it made me capable of recognizing the opportunities to teach those out to students.
Mm-hmm.
And I think that right now, a lot of educators in this space are moving from another space. So I'm not sure, like I know, Don personally, I've met Josh, Michelle, it's my first time getting a chance to meet you, but does anybody have any stories about when you first got into this particular space, how it being new for you, like, you know, might have shaped your ability to recognize the students' needs?
A comment came up before, I think somewhere about the metric system. That was I can't believe how much I love the metric system now. I didn't really get that before. I was an elementary school teacher eons ago, and then I kind of moved into this technology position. So I kind of understand where you're coming from, Joel, about starting somewhere completely different. But yeah, that was for me.
Have you found in your transition to metric that you understand metric and like scale on a very small scale, just inside the volume of your printer? But outside of that, when you start going into meters and kilometers, you have no real conception for what that is yet?
Yeah, and my sister's a scientist, so she understands the volume side of metric a lot better than I do too.
That's a really great point, though, that our knowledge base is often limited by where we use it. So, you know, we should be looking at our, you know, in our vehicle where it says, at least my meter, you know, it says miles per hour and kilometers, that it has like both on that little dial. So, you know, wouldn't we be smart to condition ourselves so you're prepared when the scenario arises that it would benefit you to know? But I can 100% relate to switching to metric. I don't think I ever had a cause to learn metric before 3D printing. And after 2 years, I go to describe things in terms of centimeters and millimeters instead of inches now. And I actually find, so I've been doing 3D stuff with students for about 7 years. So the past 5 years, I actually find it now more difficult when people give me stuff in inches, or they're talking like, they go like, oh, well, like 3/4 inch. I'm like, can you just give me metrics? I don't want to do fractions. And I actually find that to be the most distinct advantage to showing the students on why, because some of them will switch their Tinkercad. I use Onshape as well. They'll keep it in inches. And I'll say to them, you know, when you're in millimeters, you don't have to have like 3/4, 1/4 inch. You can just do, 8 millimeters or something like that. And that is the sell that gets the students interested. And that's another thing too, right? Is that 3D printing can be a bridge to encourage a student, that the motivation of, hey, I'm going to make this and it's going to get 3D printed. Now is a reason for them to learn metric. Now it's a reason for them to have spatial awareness now. And that's where, like, I personally feel like 3D printing transformed who I was as a teacher, because instead of my world being about content mastery, right? It now has become about getting kids to feel connected with a cause in a way that I found my calling, right? Is kind of the thing that I like to think about, because I feel like 3D printing is a jumpstart to being curious about mechanical engineering. What's a subassembly? Well, let's look at your 3D printer. It's made up of different subassemblies and things like that. And that's where I just find it just vast opportunities for education.
The thing I like about 3D printing, if you think when you get to slicing, I like having constraints, because a lot of what happened in my industry life was driven by a price constraint, a volume constraint, a speed constraint. And when we need to get 4 days worth of prints done in a day or two, my students, like, they have a meltdown, and it's like, okay, let's look at these. Why can't we just crank this layer height up and really shorten that print of that part that has no aesthetic value? And so it really forces my students to think, and it's nothing you can give on a test that I've found. And it's just kind of the way everyday business life happens. You always have some kind of constraint, and knowing all of the nooks and crannies of the material, the machine you're using, and the way you're slicing it pulls all those constraints together and causes some problem solving that ultimately that's what businesses are going to employ somebody to do, is to solve a constraint or conflicting things.
What you described sounds like you could set up a budget for a project, right? You have 6 printing hours and this much material volume that you're allotted. Design this that meets these different specifications, and that's part of your rubric. Is, can you keep it within those constraints?
It's a good problem solve. The whole problem solving skill, like it seemed like some of the actually my generation, to some extent, you missed a lot of the problem solving skills coming out of school, and so to speak, thinking outside of the box, utilizing the slicer settings, design aesthetics. If a piece isn't going to be seen, it doesn't matter. What can we do to maximize the efficiency of the material, the time? It's a highly valuable tool to any employer and to a lot of things in life. Is what do you need to do to get this to work, get by, and move on to the next thing, or do it as cheap as possible? It's kind of done here, and that you use the slicer settings as part of the lesson is really actually kind of interesting to hear that, rather than just here's your profile, put it to the slicer and hit print.
And I like 3D printing is essentially very similar to palletizing robot that's in almost every factory. And it's just using motion control, power transmission, things we spend a lot of time in my curriculum on. So, hey, Matt, I don't know, maybe Jake and Josh, I think Price taught, maybe Joel, teach the broadest range of students. Actually, I think Michelle has kindergartners too. But there's been in the chat question, and I know we're getting close. This time's gone really fast, which I didn't expect. But a parent keeps asking about how the educational word is scaffold. So where do you start with a 6-year-old or an 8-year-old or a 10-year-old?
Okay, my favorite project that I did with every new student, whether they were elementary, middle school, or high school, was we would model a Lego brick from scratch and make it. And that was typically the gateway drug project of getting someone in, because you were teaching all in the span of an hour. You're teaching basic modeling skills, teaching how to read a print and interpret it, and interpret those orthographic and isometric views, and then ending up, by the next day, something tangible that they can probably relate to from their childhood in some form. It's such a relatable, everyday item that they can wrap their heads around.
What we start with everyone who's starting with 3D printing at Janus is just the simple, make a keychain. All you have to do in Tinkercad, which is what we use on our Chromebooks. So the kids have primarily is what we use, and it's really simple and easy for beginner level users. You just drag the letters over, and then you're teaching them how to make sure they're flat on the bed and how to make sure they're touching each other and there's no gaps. It may look like there's no gaps, but you zoom in and you see there is one. And making sure that there's a hole big enough for a keychain, and then it's a easy, quick to print, and they have something tangible really quickly, and it's worked really well for us.
I think that keychain project really illustrates the two extremes for 3D printing as you spiral up. Is the name is the first thing that the kids want to do because it's personalized, right? It's them. It's something that belongs to them. The keychain is nice is because it's standardized. It's a specific definable project that you can teach. And so I think as you go up, you kind of go back and forth between trying to have things where the kids get to customize and personalize it, while you can in your class be able to teach concepts and skills in parallel. And so you're kind of always bobbing between those two sides of something that's personally meaningful for the kids, and also covering your content area and objectives as you go along.
So one of my favorites is to do dice blocks, because this requires that you be able to rotate the camera, be able to do alignment, be able to handle the depth of the holes that you're placing in it. And that's usually one of the key projects that I look at. We do keychains too to kick things off, but once you get moving towards, all right, when do I know that they really have mastery of alignment, making in the case of like Tinkercad, placing holes or removing detail, and if it depending on the software, dice blocks. And I tell my students all the time, I tell them, it's like, you're probably not going to be thrilled that I want you to design a dice block, but it's a way that I can see that you have mastery of this wide range of tools, because it does require a lot of tools to be able to do a dice block.
Quick aside, Joel, last night, nobody on Jeopardy knew the answer to what is a 20-sided die? What's the geometrical term? Isotetrahedral or something like that. It just cracked me up because none of them knew that that was a 20-sided die.
And even a project like that scales because right now we're working with a math class to create fair dice. So these are shapes that look like they shouldn't possibly be fair, but you can design them so that they have equal faces and an equal likelihood of doing that. And so
that's a really cool project, Josh, because there's no better motivator for certain personalities than how could I cheat?
That's whenever somebody goes to try to figure out how do I put the infill really heavy on just one part of my model. I have had students before who have made an attempt at a loaded die project, because that does exist, right? That there's that interest. But Josh, that is a phenomenal project. Is that something you'll be sharing, or you have shared? I haven't spotted it yet on your Twitter feed.
What happened is the SKU dice were not available for sale. And so the teacher was like, hey, can you print these 3D SKU dice for me? And so it's kind of led into this, me doing the research to find out how unfair dice work. And I've been kind of pitching the teacher on, like, you need to have the kids make their own unfair dice and then have other kids test it. But, right now there are some limitations because the kids aren't back in the building yet and all that sort of stuff.
I think I'm going to be doing unfair dice this year. I think might be the next iteration of my dice project. That just is that's just a crazy, fascinating project.
I like the kids are really into playing games like you talked about, utilizing Minecraft for spatial awareness, using dice, kids playing board games and stuff, and now you're taking things that they're used to. Jacob, you said about using Legos. It sounds like kind of the gateway to getting kids interested in it and getting them to think about it is utilizing something that they're already familiar with, playing games, playing with Legos. I mean, who never picked up a Lego in their life? Very few people could say that they never did. It sounds like that's kind of the gateway to starting at that lower grade level and getting them interested in it. Is you're relating to something. Or Michelle, like you said about the keychains, it's very quick. I know that's a big question that I hear is, okay, we want to do a project with the kids, but it takes so long to print. How do we do 25 kids in one classroom when the school only has 22 printers? That type of deal. The keychains, you can print a few of those at night to get them cranked out or through the class and stuff like that. But it sounds like, the simplest part of that question is asking how to relate to your kids and what interests them, what they're already used to.
I take that comment and veer it a little bit. This is another thing that I like to use. And Joel mentioned Construct 3D. For any educator listening or any parent that wants to get some of the spatial awareness 3D stuff into their kids' minds, I would go back and listen to the Construct 3D. What would have been a brutal summer for me coming off of the COVID semester in the spring was radically altered. I got so much inspiration from Construct 3D. So Matt Griffin and Liz Aram are two of the main people. There's a couple other people, but and I know, Josh, that's kind of where I first heard about the Zero things. But this design engine, Matt was just mentioning, find what kids have and feed that, whatever their interest is. The other thing that I find I need to do and why I like to use the design engine, a lot of people think they're not good at art, they're not creative, they can't sketch. And the first time I played this, Matt Griffin came to print in solid, and there was like 8, maybe 10, 12 people there. And there was a father and a daughter, and she checked out right away. She's like, oh, I'm not good at this. I'm not doing this. And then you start pulling cards. If you haven't seen it, just random cards, and there's different groupings. So 8-bit glory. I love it already. That's mine. Site. Make a low poly model of a favorite design, and there's modifiers and stuff. But there was something on the cards that her dad drew that she couldn't hold back. She had to tell him what he should be doing in his design. And he's kind of like, were you going to be in this or not? So, and I do that with my students early on as freshmen, because more than 3/4 of them think they can't sketch. And some of them aren't as good. I'm a horrible sketcher, and I think I've got better in my life. But I think sometimes you need to give people some exposures in a non-threatening way. And this Ultimaker design engine, which I think you can download all the files, you don't have to purchase anything, is a really valuable way. And I'm sure you guys all have similar, get people to get out of their comfort zone.
So I think for the final question, just to give some of the other educators who may watch this, may be watching now or may watch later, some inspiration. Let's run through the panel. What is your top favorite educational use of a 3D printer that you've utilized in your classroom? Let's start with Josh.
Okay, so that's a tough one. I do have two projects here. So I had a teacher come in who wanted to do a thing on orbital mechanics and things, and so we were trying to come up with this super crazy way to have these giant, like, here's the sun, here's a planet spinning around, and it's just the type of thing where 3D printing lets you find solutions to things really quick as part of designing classroom manipulatives. But I think one of the things that I'm most personally proud of recently recently as a teacher came in and wanted me to fabricate some pulleys for them, and then like a kilogram and super big. And so, we're thinking about laser cutting and all of these things. And, I started looking around, I realized, oh, we have all these empty spools of filament. If I just create a little hub here, this can go on this little adapter that they have. So we've made like 36 of these pulleys so far, recycling our spools. And so we have like lab sets of physics students taking this with weights on it and reusing our waste stream for our 3D printing projects to solve a classroom learning problem.
Cool. Thanks, Josh. Michelle.
So at the moment, I'm very happy for the student who designed door stops for us, because we are printing them like crazy, keeping all of our doors open this year. We printed toys for Tots last holiday season through IC3D, and that was great. The kids loved it. There was a purpose, for it, and they just had a blast with it. And then the one that really stands out in my mind, one of our seniors was interning at Lancaster County Public Parks, Lancaster County Park, and his own initiative, he decided that he wanted to do an interactive display for people going to the park to learn and identify animal tracks. And so he designed in Tinkercad, he found, a picture of an animal footprint, and he used that to cut out of just a rectangular block what the animal footprint would be. And then he made an interactive display that people coming to the park could, try and guess what each footprint was. That was pretty neat.
That's cool, because with the actual footprint, you can't really touch it and feel it too much. With that, you can feel everything. That'll lead right into Jacob with 3D printing for the blind and how he utilizes it. Jacob, what's your top use?
This is my favorite project ever. We brought the pieces of it to ERRF last year, and we realized when we got there we were missing like 25 parts to finish it. We left the files at home, but over the course of like 2.5 weeks, me and my students made a life-size Tyrannosaurus through the T-Rex head, and that was like, it was one of those like really powerful moments, because it was like, you visually it's like a kid's never going to get that if they have low vision or they're blind, and be able to have a kid come in and there's this big monstrous thing sitting on a cart and say, this could eat you. It's a very powerful like teaching moment that brings this kind of abstract concept of like, what is a dinosaur, to life. And that's something that not a lot of people get in that arena. That was my absolute favorite thing.
Cool. Joel.
Plug on that one. Lubon, if you haven't heard of it or seen it in like Facebook or anything, it's a digital fabrication software that does all kinds of awesome file prep for CNC, laser, and printing. And if you're an educator, it's free. So look it up. Lubon. So that whole dinosaur head, in like 30 seconds, it chopped it all up, put all the pins in, and exported it into one folder.
All right, I'm going to drop that in the chat. Luban is like Jacob said, is a really powerful tool. I went back 2 years ago for ERRF. We did the Friday night 3D printing community hangout logo as a community print, and I made it 4 foot by 6.5 feet and sent pieces all over the world. People printed them out, brought them into us, just like the T-Rex that Jacob showed. That software was just starting to be known right about then, and I didn't have time to figure it out, but man, seeing what it's capable of, if you wanted to do, a construction project in a classroom, it would be a really cool way to split a model, have each of the kids putting their pieces into the model. And Vicky, what's the group? We the Builders.
We the Builders, yeah.
They do a lot of community based projects like that. And I know when they did the We the Rosies project, a lot of people would pause prints and do unique things with their print to insert people's names into the print. Vicky, I think you were one.
Yep.
My pieces have my daughter's names in them, stuff like that. So like even teaches you, you know, how to now introduce mechanical parts into a print, things like that, from pausing and multiple processes and stuff like that. So Joel, what is your top use?
So we do this project every year, and it is to repurpose an Altoid tin for something that you can make it better with a 3D print. So, you know, we all save these random stuff in them. This is the first one I was able to grab off my shelf, but this one has slots for your Nintendo Switch games. So you can get your games in there. But it's not so much about what you can use it for, right? You know, some students will make like a camping kit where it's got Band-Aids and, you know, matches or something like that to take camping. Somebody might make it for, you know, just things that they, you know, want to keep organized. Maybe you are in the circuit building, you got LEDs and resistors, you make a little Altoid kit, right? But it's really my favorite project because they have to understand the fit to pop it in there. They have to understand those real size objects in real life to make their device actually usable. They've got all these different metrics that they're going to have to hit. So this is actually one of those things that takes a lot of forethought, and it has a great story about upcycling. So whenever I get any chance to talk about upcycling, and if you catch my slot, I think I'm at 355 today in the mainstream. I have a 3D printer that's all from upcycled parts. You just like gut an old wooden printer bot and you can build it. And I love upcycling because I think that a lot of people are guilty of, we just throw these Altoid tins out all the time, right? I've got like 100 in my garage. So like if anybody, you know, has too many Altoid tins, it's me right now. But I really love that project because it is upcycling. It's learning about designing something to fit inside of something else. It's about thinking about the sizes of the objects you want to hold with that device. And so it's one of my all-time favorite projects.
Multiple monitors and typing in the chat. Don, go ahead. What's your favorite use?
Well, I'm going to pivot off of Michelle's own initiative story, which I got to go check that out now. I didn't know that existed. I walk that park all the time. So what I like is a general category, and unfortunately I'm not at school around a lot of the examples of these things to put in front of the camera, but its own initiative. And here's an example that's recent. Each of the college instructors are all of a sudden nurses. We're checking everybody's temperature when they arrive at school or at the college campus. And so the electrical engineer instructor said, hey, I think I can hack this. And he bought a $20 security pad and he hacked the trigger. So you just stand on the pad and it initiates a cycle to read your temperature. And then he said, hey, can one of your better students work on a design for this? And I said, yeah, I know just a guy. And this guy went off the deep end. Like, and I kept asking for it because I was wearing like a mask and a shield and, you know, breaking social distancing just so I could read their temperature. And every day I'm like, Brandon, when are you going to have this done? And he figured out a clip on the back. So one of the early problems we figured out, we kind of mocked it up, and height was going to be a problem. So we kind of had to find, you know, tall people can stoop more than short people can jump up in front of this thing. So we figured out an optimal height just by mocking it up, going to the early conversation. And then one of the other problems we saw was it was intended for a user and the person that was being measured temperature, and we wanted it to be facing the person that was being temperature measured. So he broke the thing apart and then he 3D printed kind of an enclosure and a holder and stuff. And own initiative means it's not for a grade. In this case, I was like, you got to have this done by Friday. I'm giving you no more improvements, you know. And he's like, oh, I got, you know, this is on the printer and I'm trying that. That didn't work out. And to me, education is all about getting that fire set. And this student has won a national award last year, led a team, and they made a stool for a register, somebody that's cerebral palsy. And they had end capture 3D printed, but that was much more of a metal design thing. But to me, that student is going to be an incredible employee the rest of his life because he has this fire, he has this spark. And I feel like all I have to do is get out of the way of him, and every once in a while kind of give him a challenge. And sometimes he ignores the challenge, and sometimes he grabs onto something. And he's just incredible. So 3D printing allows him to act on those things much more near term and iterate. And it's really cool when you see a student like that get hooked.
Cool. Well, I'm going to hand this over to Vicky here to finish up the outro, but I just wanted to say thank you to the educators for coming on the panel. I feel like, we could have probably had a 3-hour slot with the crew that we have here and been able to keep on going, and I wish we had more time. But Vicky, I'll go ahead and let you close things out.
All right, I'm just going to keep it pretty simple. Just thank you guys, not only for joining our panel, but what you're doing and helping inspire more people into our 3D printing community. And then one little minor thing that I want to mention is Joel had said when you're starting out, find your friends, find your community, find your support system. If you are starting out and you don't have friends or a community or support system, make the 3D printing community your support system. You can find us on Twitter, and all of our wonderful panelists, I'm sure, are welcome to, we'll welcome your questions, and we would just love to help you and help you light that fire for yourself and your students. So panelists, thank you so much for coming, and everybody, thank you for watching.
Thanks, everybody.
Thank you.
Wow, just so much there. That was, whew. All right, I will be rewatching the video recording of that at some point, and trying to take in even more of it. But while I am still in the throes of processing that, I'm actually going to bring in our next speaker. You guys may know him, maybe because of a certain firmware that he works with, that so many of us are familiar with. And as Zoom allows Mr. Scott Lahteine in, oh, there we go. I see him connecting now, and getting ready to go, hopefully. Possibly with the connecting, we'll see. Look, for those who have been watching all day and unfortunately have had to see some video of me, you can see that the sun is now far off to my left, which means we're getting later in the day. And as we get later into the day, look, I'm thinking technology is doing the same thing we are, kind of taking a little bit of a break on a Saturday afternoon. Scott, it looks like you're connected. I don't see video yet, but can you hear me?
I hear you.
Excellent.
I'm just connecting up my headphones so that I don't echo back too much.
Perfect. I was just wondering. I was like, I think he's connected. I think we'll be good to go, but I want to make sure.
So this is the waiting room, huh?
Oh no, you are live, Scott. You have been waiting.
Well, then everyone's in the waiting room with me, apparently. All right. Hello, world. Welcome to my waiting room. I'm just getting this stuff set up. I don't know why these headphones are being annoying. I think it's because they're already paired to another device. Hold on. That usually was a trick. Okay. Hello. That's better. Okay. Say a few words for me so I can just check the audio.
Can you hear me, Scott?
I do hear you.
Perfect.
Strangely enough, yeah, it's not going into my headphones though. All right, hold on. One quickie. And try again, really quick.
All right. How we doing now?
Bloody bad.
Seems about.
If my audio's not coming back at you guys, then great.
I'm not hearing any feedback, Scott. I think you're doing okay.
Set up, and I did all this setup here. Let's start the video. Let's start the video. Hey, how's it going, everyone? Welcome to my bedroom. My name's Scott. I'm a bedroom coder, I guess, and I've been working for the last few years on Marlin. Recently came out with 2.0, and we're working on many improvements. Just put out 2.07.1 early this morning, and if you've downloaded it, download it again. There were a couple glitches that fell in, and it's fine now. Yeah, so yeah, generally speaking, that's how I spend my days. In case you're not familiar with what Marlin is, and you're just joining this because you're curious about 3D printing, it's the piece of software that you find on your 3D printer. It takes care of all those boring details, like, you know, you're interpreting commands, you're moving the motors, keeping the heaters happy, running the screen, taking your user interface, interpreting G-code. All that stuff happens on that machine, and so you need a pretty, you know, fancy program to do that, and that's what Marlin does. And it's getting fancier all the time, especially with these new 32-bit boards. Of course, it's an open source project, and it's entirely funded by community donations. I couldn't do my daily maintenance of the project at all if it wasn't for Patreon and GitHub sponsors and everyone just chipping in coffee. So thank you all for all the help you've given to the project. It's been an amazing ride, and it's only getting better. Anyway, I'd like to take a second to thank everyone at VERRF and ERRF for throwing this thing together. They have been putting together an amazing event from the get-go, year after year, and I wish we could be together and meet up, because that's what these events are about for me. You know, I love to just come together with the other people and see what you're doing, get creatively inspired, see what what limits you're hitting and what kind of things I can do to help, and just kind of get inspired and throw a pile of wood on the fire for the next year of inspiration and stuff to do. So at the moment, let's see, we're getting a lot of support for 32-bit boards and touch screens. That's a big deal. A lot of Chinese printers have come out recently with various different types of touch screens, and there are all kinds of different quality to them. Some of them are like these D-Win screens. Other ones have all kinds of other different features, and they're just they're a real challenge to support. So we've had a lot of cool help from that. There's a couple others on Patreon and elsewhere that are assisting, and they have their own Patreons. And there's Marcio, who used to work at Lulzbot Aleph Objects, and he's got a Patreon for his extra work for kind of continuing to maintain the work that he did on those projects, and that's really cool. There's a guy named Victor who's got a Patreon, and you should definitely check his stuff out. You'll see him popping up on Twitter, so follow him. He's part of the team. Yeah, there's just a whole slew of really talented people who I just don't have. I wish I could thank them all. There's just so much going on right now. Anyway, I wanted to give you a quick overview of Marlin itself. For those of you who haven't seen it before or haven't used it before, it's usually just on your 3D printer, and you just deal with it that way. It's already installed, it's pre-set up, but very often it's not exactly what you want. You want to add some feature, you want to tweak something you don't like where it homes or whatever. You want to add a probe, even that can be, you have a need to recompile the firmware. It can seem a little daunting at first, but it's we're trying to make it easier all the time, make it more of a single button kind of process if possible. So I'm going to just show you a quick thing here. Let's see if I can do a screen sharing. We'll try that and see if that works. Oh, there it is, the big green button. Welcome to Zoom. All right, so let's try, let's see, I'll move that Zoom meeting down there so you're not all looking at it. And here we go. Zoom, there you are. And share, I guess my big desktop is one. Is that right? Hello. And share. We don't need, oh yes. I've already done this before, but it wants me to give it permission. Let's see if I need to quit it or not. I hope not. It'd be great if I could. Okay. Without quitting. Would be good. Let's see here. It's set up, so let's try the share screen button once more. Oh, look, it's got it. Yeah, see, they tell you need to quit and start over, but you don't always. Okay, so you should be seeing my screen now. Let's put that away. There we go. Reading up on Bresenham, which is kind of the original topic of this. I have a bit of a presentation I was going to put together, but it's a little confuzzled. I need to clean it up, and I'll put it out as a follow-up. But I'll give you a little background on that later. So first of all, when you want to get Marlin, the best place to go is marlinfw.org, where you'll find documentation that we try to keep up with. Some of it's a bit behind, the configuration stuff's a bit behind. I need to automate some of that. You'll find the download button at the top here, and latest version is 207.1, and we've moved configurations also to a different place, so you'll need to get those. So typically you'll just hit the download button, download Marlin, it goes into your download folder, you unzip it, you open it up, and you'll want to open it up in, something like Arduino probably, but lately we've been recommending Visual Studio Code. Visual Studio Code is a free development environment, or you could say an extensible editor that can become whatever. So it's really cool for managing stuff like projects like this. So I will just go and open up my Marlin folder here, and you'll see that it shows up, the files on the left, and there they are. And the easiest way to deal with Marlin now is to just get a plugin that I've been working on with some help, called Auto Build Marlin. And so we install that. And once that's installed, you'll see a little AM icon show up, and we'll just show the panel, and that shows up. And it just reads your config and presents all the options that you need to be able to build or upload your stuff. So you just hit the build button and off it goes. And no, I don't want to update Zish now, thank you. Oh shit, it took, oh crap, I should say. It took my yes and I meant no. All right, build. So yeah, it goes build. And it takes a bit of time the first time, but once you've done one build, it makes a folder which has got your stuff in it. And as you can see, I've already got one there. So it takes no time at all. Once it's done building, it shows you the last build where it was. You can close this with a little trash can, and you hit the folder and it opens up a window and reveals your firmware hex file, and voila. So you just copy that to your SD card or whatever you need to do. If you're using certain boards, you can just have your board connected and hit the upload button as usual, and it'll do the upload for you right from here. And it does a pretty good job of auto-detecting your serial port and stuff like that. You don't have to go to a lot of trouble. So that's the general build method now. And yeah, if you need to configure stuff, of course, the same methods apply. You still open up your configuration files. They're still there. And you just go through and, read carefully and edit as you usually do and make sure that everything is just the way you want it. So it's, it hasn't changed fundamentally a lot from the original 1.0 version if you're used to that. You'll still be doing the same kind of thing, build, upload. Still can be a single button process using helper tools. And and going forward, we really want to make this even more advanced. Like I've got a configuration tab here, which is completely empty and just waiting for stuff to fill it. And what it needs to do is, read the configuration, put up form fields for you, and allow you to, go through a wizard and just get through the stuff you want, or grab a configuration from somewhere else, like that's already, just download it right from this interface instead of having to go download it, copy it, compare it. And then the other thing would be, once your changes are made, you can save them off into some compact form, or keep your old configs around, and this tool will take your old options and move them over to your new ones once it's ready. Of course, this is the promise of having enough time and space to really work on this. The configuration utility is something I really want to get to, but ultimately the issue queue takes up a vast amount of our time. So we're just trying to keep up with it, but every bit helps. We're gonna ultimately try to work out our schedules in such a way that we can sort of devote a certain time, a block of time to this every couple days, and make sure that it keeps advancing, because it can be it's very easy to just like lose myself in the issue queue all day long. So I really want to provide this for you guys and make this better. And especially because, that's one of the main things we get is how do I move my configs over and why does it have to be difficult? And I definitely understand and feel for you. And what I'm going to do is basically move the configs into a database, not an Excel spreadsheet, and make sure that they're, able to be pulled out with all the descriptions, and we can just, maintain that and basically always keep a sense of like, if you want to go from one version to another, you can just easily convert from one version to another. So that's stuff that I'm going to be working on. Well, I guess I'll give you a brief introduction to what I was going to do today, which is the Bresenham line algorithm. And this is sort of the soul of Marlin. This is the algorithm that takes care of making sure that all the steppers arrive at the same place at the same time, or as it were, wherever they're going to arrive at the same time. And of course, each one is moving by many different numbers of steps, and you just have to there could be a lot of complex math involved. So it can be quite, a scary proposition to try to think about writing something like this. Fortunately, a dude back in 1962 named Bresenham discovered, I would say, you could say invented, but this is something that you would hit on eventually, because it's a modular mathematical way of making lines that, it is one thing you can do with it is draw lines and get them to be, arrive at exactly where you want. And it uses nothing but integer counters. And it's just, it seems almost magical, because you think, as a geek starting out, when you're getting into computer graphics, gosh, you're going to have to get into all kinds of math and trigonometry, and how do you get a line to go from here to there? And typically when you do stuff in computer graphics, you're going to be doing a lot of sines and cosines and arctangents to figure out your angles and stuff. But if you only need to go from here to there, and you're doing it in a couple of dimensions, 2, 3, 4, 9, whatever it may be, an algorithm like this is perfect, because you don't need to know immediately, say, every point in between, or be able to predict every point in between with it. All you need is to be able to go from starting point, point A, to the ending point, point B, and have everything, work out. And so this technique is really brilliant, because it makes sure that, let's say, for example, you're drawing a line which is, say, on your bed, 100 by 25. So it's going to go 4 times as far this way as it is this way, or maybe we'll say, assuming the steps are equal, they're going to go 4 times as many steps in one direction as the other. So for every 4 steps one takes, you're going to take 1 step for the other. And so there's this really cool trick, the Bresenham line algorithm, which is you determine what the longest line is going to be, and you make that your ceiling. So if your longest move is going to be 200 steps or whatever it may be, say 100, make it even, and that your least number is 25, you make your ceiling 100, and then you just count that, you make a little counter. And so you have 1 counter for your X, say, and 1 counter for your Y, or in your case, X and Y. And the idea is that you simply add the distance to each of those. So the first one's moving 100, you add it to 100, and you go, did it reach 100? Yes, so I keep moving. The other one goes, okay, I'm going to only add 25 each time. So it adds 25, 25, 25. It takes 4 times before it finally adds up to 100 and gets to that 1 step. But this actually works out that it don't have to be round numbers. You can just put in anything. It could be prime numbers, weird prime numbers, and it will still work. This algorithm will still work. The only trick is you have to prime it at the beginning so that it's filled about halfway. You have to half fill it, and then you're guaranteed that your line will at least be like perfectly symmetrical. It'll have a nice break in the middle that'll make it exactly symmetrical on one side versus the other. So I'll give you a quick demo since I have my screen shared. And let's see. Hey guys, so I was doing all kinds of very essential hand gestures during that you may have missed, but you probably get the idea even without the hand gestures. So let me grab that demo, which is in my downloads. Brez. This is Lou's been working this last couple days, and it's just about ready, but it's sort of like I want to make it a little clearer for you guys. So here's a little grid, and I've just clicked the point, and here's another point that I want to go to, like say here. So now let's set up our counters, and we're going to do a step starting from the beginning. And there it goes. There's our first step. Each time you're guaranteed to get a dot, because when you're drawing a line on a computer screen, you always want to draw a dot for every, say, let's just say you're going in X. You want to draw for every X or for every Y, you're going to definitely draw a dot. It's just where is that going to be on the other axis? And you can see as I'm going up, it's like doing this counter trick, adding up, boom. But then it takes the remainder. And so each time it goes over this, it actually subtracts, say, 100 from it. So if you were doing an even number, it'd go back to like 0. But if it was an odd number, you would end up with some remainder at the bottom. So each time that counter goes up, it doesn't end up stepping at the same time, as it were 3 steps later. It could be 2 steps later, it could be 1 step later. So let me bring that demo up for you guys. Hold on a second, and you'll see it. There we go again. So here we go. Once again, start from here and going to here.
Scott, wait a second. Hasn't popped up yet. Have you been able to share screen?
Now we go step, 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 step. I think it might have started at 0 instead of the point, but you get the idea. It's stepping, and as it steps, it's doing this remainder thing. And yeah, you'll see the animation is meant to show that it goes up over the top of the bar, and then comes back as a remainder. But what I needed to do was actually cut these bars down to like about half height here. So, okay, there we go. So as you can see, each time you definitely get a dot, but where is it going to be on the Y? And it's magic. It really is, because all we have to do is set up these counters, and we can do this. Now, the really, really cool thing about this that's coming up in future is, oops, hold on. It keeps asking me which screen to share. I forgot that I have multiple screens. So one more time, demo, one more time. Dot here, dot here. Let's start. Step, oh, see, it's starting at the top left. I don't know why. It's supposed to go from here to there. Well, anyway, so let's just say we're going there. And you can see, as I'm going, step, it's filling up the bar. It's filling it up. And then it goes, yeah, there we go. Oh, and it arrives. Hey, amazing. So let's try again. There we go. Step, 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 step. This circular thing is not what I had in mind. I was sort of like wanted to show each of these as a clock, because in modular math, instead of a bar, you would really want to show a clock. It goes, past 12 o'clock, as it were, on the top of the clock. And then that remainder is just, it's just there. So you just keep going around the clock. And the next time you may arrive at 4 o'clock. Next time you go around, you might go around a whole way and then arrive at 6 o'clock. So yeah, showing it that way would seem to me to be the better way to go. So in any case, I'm going to improve this demo, and you'll and get it properly in shape for you guys, because I think this deserves to be, this is one of those things you really want to understand, like how do you get this magical movement to happen? So yeah, that's kind of just all I wanted to show you, was just this really cool aspect, because it works in any number of dimensions. It guarantees you'll start and arrive when and where you want to, which I think is just so neat. So anyway, sorry about the technical difficulties, but we're live. It's improv. That's how it works. So while I'm here, I guess it's pretty much as I want to say about Marlin, but if anyone in the Discords or elsewhere has any kinds of questions or anything, or anyone in the host area wants to toss anything my way, please feel free. Otherwise, I want to thank everyone for coming, and thank everyone for continuing to patronize Marlin and use it. And I hope everyone's enjoying it and making the best of it, because we certainly love work. I love working on it. I get a kick out of every day, all the new and interesting kinds of problems that there are to solve in so many different weird areas. And whether it comes down to like keeping the heaters stable, or making the motion more smooth, or just being able to take the best advantage of the new processors that we're encountering, it's just always an exciting and interesting project. So yeah, thank you. And it's been an honor to be in this community as well. Thank you, everyone.
hey, Scott, that was awesome. Like I'm excited about this. As I was hearing about it, I'm like, okay. And I know that a lot of the what was in the chat was kind of quick to the, hey, we're not seeing it. We're hearing Scott talk about it, but we can't see the screen. So it was awesome when you
it's
brought
the
it.
bloody Zoom, man.
Well, yeah.
Two
I mean,
buttons to share a screen, 2 clicks.
Yeah.
I'm confused by that.
Spend way too much time on Zoom, so I am right there with you with too many clicks and making things happen there.
Truly.
But yeah, absolutely. There was, feedback. There was a question regarding, I think it was the Bresenham algorithm. Isn't it used by CAD programs as well for displaying lines?
I wouldn't be at all surprised. I mean, ultimately, CAD programs, maybe the older ones, would be using it, but typically now you just tell the GPU to do it, and it's using something like that. Actually, there was another interesting thing I wanted to mention, which is that this lends itself really, really well to FPGAs, and so there is actually some FPGA stuff coming on the horizon, which I would love to talk about more. But we'll talk about it more when I can talk about it more, because FPGAs offer the possibility of offloading a lot of dumb stuff that you don't need the processor to do, like keeping these counters and stuff. So there's a lot of real cool tricks that I think are going to be showing up on boards that are really cool. In fact, I also have a Panda Pi here, and Marlin now runs on Linux, and so you can have Panda Pi with Marlin running on the Raspberry Pi right alongside your Octoprint on the same processor. And I don't know how the original author got the real-time working as well as he did, but it apparently is quite stable. And there's a whole separate project, but we're working on integrating that into the main Marlin fork, because typically, as usual, these projects, they don't always keep up to date with our changes, and it gets harder for them to keep their stuff in and merge it in. So I want to sort of do that for them and get them up to that point, because I really like this concept and I love this idea. It's taking it to a whole new level and offering the opportunity to use new devices, hook up your printer to your TV, I suppose, and whatever else you want to do. There's just, the Raspberry Pi is, especially the Pi 4, offers just amazing power, and who knows what will come out of that in the future. I'm just anticipating a lot of really interesting and neat things coming.
Awesome. There were a couple other things that came up in the chat. I'm going to bring it up here as I play with multiple windows as well. The first one was a question about, can you port Marlin over to Duet?
Oh yeah, I actually I had that on my notes, and I was I skipped over it, because yeah, it's one of those things where it's like, do you really want to put Marlin on a Duet though? Do you really? Because the Duet is really made in companionship with RepRap firmware, and they are really meant to go together. And once you have, and if you want to get the most out of your Duet, RepRap firmware is really the way to go, because it has all the insider knowledge, and it's just deeply ingrainedly knowledgeable about those boards. That said, of course we want to get it running on the Duet, and I've got a Maestro, and that would be my first, really, I think that'd be the board I would focus on first, just because it is more of that smaller form factor, before I go jumping into the Duet 2 and the Wi-Fi and all that other stuff. But there is also a lot of interest in multiple axis, more linear axes, for various robotic systems and stuff. And with that in mind, I'm also, you need something like a Duet, or maybe the Big Tree Tech just came out with their huge, massive multi-tool type of board setups. Same kind of idea, 2 boards that you have to hook together, and that looks pretty promising. So yeah, as we get more into that, I think we'll definitely see it coming up on Duet. But again, I think your best experience with Duet will tend to be with the RepRap firmware, and so as much as we can communicate with RepRap firmware and try to keep things compatible and moving forward and keep the standards, we're going to do that as well. So yeah, this is I guess that's as much as I have to say about Duet.
Excellent. And I think the last one that I saw was, does Marlin incorporate a vanilla Bresenham, I'm butchering that name most likely, vanilla Bresenham algorithm, what kind of modification do you use?
Well, I mean, there's different approaches. Instead of counting up, we count down, and then we check if it's negative. So, there's that's one optimization instead of doing a subtraction, and then an extra subtraction to see, and then see if the end flag went high. You can just take your result and say, oh, it's negative. So now we just have to add our ceiling again and carry on. So that's one, and then it's still seeded the same way. It's seeded, adding 1 and dividing by 2. So yeah, it's pretty much exactly the Bresenham algorithm that you know and love, and we even do make the lines symmetrical in the middle. So how much that matters, I don't know, but.
Excellent. All right. I think, Scott, that was all that I saw as far as questions. We're definitely getting some thank yous for the conversation and for the educational moment. Anything else? You got a minute or two before jumping off.
Hey everyone, I hope you're taking care in this terrible, trying time. We are just cloistered and staying in, ordering our groceries and not doing a lot of socializing. We really miss you, and I really look forward to seeing you hopefully next year, when we're all vaccinated and happy and ready to get out there again. But in the meantime, please everyone take care, stay safe, and I love you all.
Scott, I think that is a great message. I couldn't agree with you more. I'm very social when it comes to doing all of this, and I truly miss interacting with all the people at ERRF this year. I'm glad we've been able to do this, but there is something about walking around and having those conversations that, yeah, I miss as well. So
yeah, I think it'll be fun if we get to compare all our new tics that we developed from being cloistered indoors for so long.
Good point.
So
awesome, Scott. Thank you so much. It's been awesome having you on. This is third? This is technically first VERRF, but third ERRF, and I believe you've spoken at all 3.
I have. Last year, you could say I spoke, but yeah, I was so wiped out from coding all night that I just kind of lost it. But yeah, this is great, and I look forward to continuing to come and speak and get better at this. So
awesome.
Thank you.
Well, thank you so much, Scott. It's been appreciated.
Yeah, thanks. Till next time. Bye, Nick.
Bye. All right, Vicky, I saw you there. I'm being flagged by one of our other board members.
I was just going to inform you I'm going to come sit and chat with you.
Oh.
You have to take your headphones off because I can't hear anything.
Oh, we're getting a special guest on the build platform for the moment.
Actually.
Yeah, we are taking a brief pause for from the build platform for just a second. I know that Matter Hackers is up on the schedule, guys. We haven't forgotten about Matter Hackers, but we've got them over on the main channel right now. And as they wrap up on the main channel, we are going to bring them back to the build platform. So we are going to be a couple minutes behind, a little bit of change to your scheduling, your program scheduling. Sorry for that. But in the meantime, like I said, we are joined by the amazing Abuzz Designs, Lauren Ange, another one of our board members.
And also Vicky's here.
And Vicky's here. I mean,
I'm here. Well, they've been seeing me all day, so I'm old news.
Oh, goodness. Well, I think this has been an overwhelming success. I think people have really, really enjoyed, based on what I've been reading in the chats. People seem to have really enjoyed the build platform this year, which is super exciting. What do you think, Vicky?
Yeah, I think I think it's going well. I've didn't realize, when we were doing the education panel, I did not realize how fast an hour would go. And just every single one of those panelists, I'm like a sponge. I'm like, I want to hear more. And, we had to, have the finite time with them.
Yeah, there's been so much this year. Like I wasn't sure how the build platform was going to go kind of in the virtual world, but man, I got to tell you, I'm kind of digging this.
I think it thrives in the virtual world, to be
As
honest.
long as you get the time zones right, then it thrives.
Well, there is that,
True.
Vicky. I mean, if you want to point at certain things, yes, getting time zones right could be a little bit of an issue, but beyond that, I don't know. I've been fascinated. Not that I'm not every year. I'm lucky enough that in the 3 East Coast RepRap events that we've had, I've been able to be at the build platform and hear speakers every year. And I'll be honest, I don't know. This year just it's kind of cool. I feel like I've picked up more this year than maybe I have in previous years.
Oh, neat.
So yeah.
Maybe that's because you're not being pulled in 800 different directions like we normally are.
No, there's that possibility, but come on.
I don't know. There's quite a bit of social media chats. That's a lot of directions.
It's true. I think I've got 7 chats open right now on my computer.
Yeah.
That's a little crazy.
Just 1 or 2 things going on. Just 1 or 2 things.
Yeah.
I do think that was a good question. I'm looking at it right now. Seems to be 113 people that are on the build platform webpage, or I'm sorry, YouTube page. And I do think that was a good question that you asked, Lauren. So I'm going to follow up on it. So far, what have people seen? What have people heard? That, oh, there we go. I got 3D Maker Kid who's jumping in. I should have looked at the chat first. It's Adrian Bowyer was always really interesting to listen to. I always feel like I need a degree in physics or math to understand him. Yep, I feel like, although I really liked
the tie-in to biology.
Yeah, he was talking. He tied it into biology today, and for some reason that really resonated with me. And I was like, oh, I get it now. Like what he's talking about. And maybe it's just the way that my mind works.
I unfortunately missed his chat, so I'm gonna have to watch it on the replay.
Yeah, I would recommend that.
I'm very excited to do that. Actually, with any of the ones I've missed, I'm excited to watch on the replay.
Have you've been watching the sponsors and exhibitor channel?
I actually haven't been watching either of them because I've been literally moderating chats the whole time. So I've pretty much missed everything, unfortunately. So I'm going to have a lot of replays to watch back on.
I did see a comment in the chat from a certain moderator saying that, and I'm guessing this is directed at you, Lauren, that you probably need to be involved in more chats.
I mean, I'm
watching more of them.
I'm on the Discord. I'm on both of these, plus our own behind the scenes chats. I think I got them covered.
Do you though?
I do.
Yeah.
I do.
Okay.
I'm gonna say I do. I mean, I don't right now because
Yo,
I'm
you
here.
did that 8 years ago. You said I do, and that's look. There's judgment questions involved.
Lauren, the shirt arrived.
What was that?
My shirt arrived this afternoon.
Yay.
Well, yeah.
That's awesome.
That is awesome. We are rocking the old school.
Yes, we are.
Our shirts did not arrive.
No.
That is quite all right.
Yeah.
Vicky, you want to take the time to talk about swag? I think we've kind of got, I don't want to say a new audience.
Oh, I'll do it again. Yes, I can do that. All right, everybody, except here we go. Hey, everybody, we are virtual this year, but we do have some physical souvenirs that you can have at your own house. If you send us a self-addressed stamped envelope, we will send you first your ERRF badge, which is sponsored by Printed Solid, and you'll have your little number on the back. And then we'll also send you this virtual ERRF2020 sticker. And so I'll go ahead, and this will be another good opportunity for me to put the P.O. Box number into our YouTube chat. And in addition, Lauren designed these ERRF Girls virtual t-shirts, and this one's super, super duper soft. I love it. those are available for you to order at Teespring, and I'll put that link in the YouTube chat as well.
Excellent. Vicky, have you ever thought about a career in sales? Like,
No.
just gonna toss that
I'm
out.
not good. I'm not good at asking people for money. I think Lauren probably looks at my Etsy shop and be like, price is too low, price is too low, price is too low.
Hey, to each their own, you know? Whatever works. Well, this has been I didn't know what to expect this weekend in general, and I'm overwhelmingly pleased at how this has turned out.
Yeah, same here. I mean, look, we weren't sure how this was going to go. A bunch of you have probably heard us talk about it to this point. You know, we made the decision early on, and we wanted to do as much planning as we could about it, but we were just figuring on Murphy's Law. Like, if you planned for everything correctly and, you know, something's going to come up that you hadn't planned for. Obviously, we got that out of the way early, Vicky, this morning on the build platform. Time zones.
Yeah, smooth sailing.
Should have maybe accounted for time zones a little bit better. But, you know, short of that, I mean, I think, yeah, it has gone smoother than I expected. And maybe this harkens back to our very first year of doing this, where it went a little smoother than we expected.
Well, I think you always try to prepare for the worst just in case. So then when things go smoother than you expect, it's like, oh, what were we worried about? But if we weren't worried about it, it would have been more chaos because you're not prepared for it at that point. So
again, I feel like you're talking about 8 years ago when you said
I'm
I do.
not.
Like, you prepare for the worst, and you know, if it goes smoother, you're good there. If it doesn't, well, you know,
that's
at
not
least
what
you were
I'm
prepared for it.
talking about at all.
Really?
I'm literally talking
Oh.
about doing events.
Oh.
Because you always prepare for the worst and hope for the best. And, you know, when you get very minimal issues, it ends up being a lot better than you expected.
Not gonna lie, I kind of think of myself as an event. I'm not sure that shocks anybody, honestly.
Oh my goodness. Your ego could eat small children.
Could. That's why I work from home nowadays, right?
Okay, well, we've got a couple more minutes. I think they should be finishing up over on the other channel in the next 3 to 5 minutes. So if anybody has any questions for us, I believe after Matter Hackers, who's going to be up next, we'll have Cocoa Press.
Cocoa Press will be up after Matter Hackers, yes. Talking about 3D printing food.
Yeah, which I'm not going to lie, I am super excited to watch their chat on that. And then after that is going to be...
That's a wrap for the
That's the last speaker for today, yeah.
Yeah, that's it for here. And then everybody can move over to go look at the Fresh Prints of Anywhere contest.
Right.
Which is super exciting.
Yep, Builder's Mark, absolutely. Prep for the worst and pray for the best.
Exactly.
But, you know, she's also right. Oh man, I'm never gonna live that down. She's also right that if you prep for the worst and everything goes smoothly, at least you were prepped for it.
Yeah.
And you're in a good spot. So.
And then you feel like, oh God, what did I stress out about for? And then you're like, oh, I stressed out so that it would be smooth.
Right.
Yeah, it's good times.
So Vicky, we asked the chat, didn't hear you. What's been your favorite so far today on the build platform?
Oh gosh. Well, I have a maker crush on Josh Ajima and all the education makers. So yeah, that's definitely probably the highlight so far. And then Adrian, I just loved all the intermingling of different sciences together into his speech. That was definitely a highlight for me as well.
Yeah, I would agree. I'm trying to think. I mean, there's been so much other, like, I loved the fun that E3D had with it, and the pub quiz made me think about and want some things that I can't get at the moment. Ooh,
like a corgi.
I guess we could get a corgi. I'm not sure how it would do with our morgie. You know, so there's that. But the rightful naming of the queen, which we all know is Liz 2 Electric Boogaloo. So, you know, that whole, just that idea brought a little bit of fun. And then we brought Prusa in, and they were talking about community and Prusa printers and what's happening there. And then Chelsey with the modeling.
Chelsey was a highlight for me too. Yeah.
Was just, I mean, unbelievable when I looked at what she was doing. And then that leads into printed solid, and we learn about the importance of filtering our air, even with things that we think, you know, and a lot of times I think take for granted. And then we moved into that educational roundtable, and you're right, there was just so much there, Vicky. I think I said at the end of it, I'm gonna have to take some time to rewatch that and kind of process everything that came out of it. You know, and then Scott telling us about Marlin and some of the things in Marlin that are going to be added, you know, and how that's going to relate to everything that's going on. I gotta say, it just, yeah, lots of good. I don't, you know, I'm partial. I think I would probably agree with you that listening to Adrian was probably it. Probably my top moment for the day. But man, there have been so many good moments. So
Yeah.
many.
And maybe we should segue into what we have in store for tomorrow.
Oh, should we segue into what we've
good
got
idea.
tomorrow?
Yeah, because the fun is going to continue.
It totally will.
It absolutely is. So tomorrow morning, we're getting a little bit of a later start. We'll be starting at 11:30 tomorrow morning. The first speaker will be on at 11:30, and we're kicking it up with Slice, who's going to be talking about, well, I mean, I believe they're talking about the process that they have, or the newer process that they have that just came out not that long ago. I'm trying to remember.
Is this the how to make a PTFE compound safe for 3D printing?
Yes, for 3D printing, absolutely. And then we go from Slice into a video that was sent from us by Jay Wall and Print That Thing with some tips for using 3D modeling software.
We may have previewed that a little bit yesterday.
May have, definitely did.
And it looks really, really awesome. I can't wait to see the whole video.
Yep. And then from that, we move into Uncle Jesse, who's going to be speaking with us. And then Paul Poxtelis, who's going to be talking about a project that was done, I believe, at the University of Maryland that involved gardening and 3D printing. And then at 1 o'clock, we jump into a diversity makers panel that's going to go for an hour. And I'm really excited to kind of hear what comes out of that panel as well. And then at 2 o'clock, we're going to wrap up day 2 on the build platform with Auto Drop 3D. So yeah, I got lots of stuff coming tomorrow too.
I really love the panels.
I do
You know,
too.
the education panel, the diversity panel. It's really cool to get different perspectives on similar questions that are asked.
Yep. And like I said, we wrap up the day after that diversity panel, and probably I'm imagining some really cool stuff that's going to come out of there with another return speaker. I believe it's Lawrence Nightingale, is right?
Yeah, he's the moderator. Lawrence
Yep,
Nightingale
moderator.
was one of our speakers in ERRF 2018, and he spoke. He has his PhD, and his dissertation was on the effect of 3D printing on community college students, and so that's what he spoke on in 2018. And he's going to be moderating our diversity panel tomorrow.
Yeah, and then like I said, we wrap up with Auto Drop 3D, who is going to be talking about 3D printing and the monetization of 3D printing. So wrapping up maybe for some business savvy, some business minded folks, and how to turn that 3D printer that we all use for a hobby into maybe something monetized.
Like the person sitting next to you.
I know nothing about that.
I would say yes, maybe like the person.
Because I seem to recall you were on a panel last year, right?
That I was. It was actually, I really, really like panels. I would totally be on one again. I think they're a lot of fun. To be able to chat with people about different things, like I said, and being on the maker panel, or the what was it, Makering a Business panel?
Makering a Business, brought to you by RepCord.
Yeah, it was, to be with such great businesses on a panel like that was fascinating, and I really, really enjoyed it.
I'm also seeing I'm bouncing back into the chat, seeing people bouncing back and forth between the main channel and here. Another uptick for Adrian, although kind of liking them all. I'm also realizing that the sun is getting low in the sky, and I'm starting to look like a White Walker here with the lighting. So yeah, This is why I am not on camera. This is one of many reasons I'm not on camera a lot. This naturally pale complexion is great for hiding in the snow in the winter, but doesn't come across on the camera screen all that well.
I just got word that Matter Hackers is finishing up over on the main channel, so they will be heading this way very shortly. And then we can continue with our awesome lineup for the rest of the day.
Right. Oh, excellent. So how about anybody else in the chat as I'm looking? I have a nice glow. I appreciate that. Thank you. It is a nice glow. It is in no way a halo.
Oh, I see some people popping in the waiting room.
I do see people popping into the waiting room. And so without further ado, there we go. We got 3 in the waiting room. I'm going
to hop off. Bye, guys.
Bye. Nice seeing you.
And I am going to turn it. Oh, look at that. It's like I've got a key grip. She's adjusting my lighting right now. And by adjusting the lighting, I mean closing the shades. Without further ado, I am going to admit everybody from Matter Hackers who has just finished up on the main channel to head right into the build platform. Oh, and I am seeing people. Oh, no. Mara, one of my favorite people. There's Dave, another one of my favorite people. Oh, I'm seeing the virtual hugs, Mara. I am right there with you. All right, I'm going to turn it over to you guys.
Oh, well, what are we going to do?
It's your time, whatever you want, as long as it's family friendly.
So originally what was planned, we're just, welcome to Matter Hackers. For those of you who don't know us, this is exactly how we roll. We're going to do a little bit more of a deep dive on, well, mostly we're here to answer your questions. We'll do a little bit of intro to who Matter Hackers is. Who are we? And then we'll do a little bit of a deep dive into some of our new offerings, like the things that we just teased out on the last stream. So we'll tell you more about the Pulse. We'll tell you more about the re-release of Pro Series materials, Pro Series filament. We'll talk about teasing maybe some resins that may or may not be coming out. And then anything else anybody wants to ask us about 3D printing, about how we're working with the community, and about how we can help you with your projects. I'm also at some point going to give you the email address that if you do have a really awesome project and you want to tell us about it, email us and you may be featured on one of our next newsletters or on our website. We'd love to see what you're up to. So with that, I will pass it back to Dave and Alec. And or actually I'll give a little bit of the intro for those of you, because I realize that there may be people watching that have never heard of Matter Hackers. So Matter Hackers, we're a retailer. We sell 3D printing stuff. We sell digital manufacturing stuff. So desktop 3D printers, CNC, laser cutters, vacuum formers. We sell all different brands, so people like working with us because we're agnostic. We're going to tell you about one printer that we do make, but other than that, we sell pretty much everything you've seen on all the streams today. So Creality printers, Protopasta, E3D, Pio Poly, BuildTac, Capricorn tubing, Slice 3D. Like, I look at the sponsors and the attendees today, and it's like, yep, we support and sell all of those products on matterhackers.com. So if you've seen things on the streams today that you're interested in, you can just go to Matter Hackers and we pretty much have all of them. We also love our community, so we do tell stories. But what we're really most excited about right now is the new features for this 3D printer that you see in the background of Dave and mine and Alec streams, the Pulse printer. So please do put any questions in the YouTube chat. I'm going to be monitoring that and tossing questions back to the guys. And with that, actually, let's have Dave and Alec take it away. Tell us more.
Hey, what's happening? First, I miss everybody. And, I guess if the best we're going to do is these virtual events, I'm very glad to have them. So thanks for everybody who's hosting them and taking time and stuff to do that.
We're lucky that virtual is actually a thing we can do. I don't think I'd see something like this, 2, maybe even 3 years ago. This definitely feels like some new grounds are being formed. I could
Yeah, it's exciting. It doesn't mean I don't miss, having beers and giving big hugs to everybody. That's for sure. So,
yeah.
New York Maker Faire and all those Maker Fairs and all the MRF and ERRF and all those events I certainly miss.
Yeah. So here we are.
But in the meantime, yeah, so MatterHacker's product portfolio, as Mara said, we are so happy and so excited to be able to sell and retail and promote and help to market almost everybody who's involved today with that you might see. So whether it's LDO Motors or Slice Engineering or E3D, those are all great partners for us. And we're excited to retail and promote those products. Even more so, provide them in a pre-configured, calibrated way already installed on the Pulse machine. So we're able to kind of offer a whole new value add for customers looking to customize their machine to suit their specific needs. So if you want an all metal hot end, if you want an abrasive resistant nozzle, if you want a 32-bit board for printing smoother and faster, we can provide those. One of my favorites is actually the Pulse HV. It's the high volume one, which is, fat layer lines and strong parts. We've really been embracing those around the office over the last year or two, honestly. I'm glad to see it getting some traction and momentum of how beautiful those parts can be in the community. But the HV is to provide exactly those things.
I think an important thing to note, I don't know if we've here today made this distinction. There's multiple ways that you can get a Pulse. You can either get one where you pick and choose each individual little part, or there's the Pulse bundles where it's pre-chosen, these are the baseline. It's going to come with this LCD and this Bondtech or this extruder or this hot end because it's fulfilling some specific purpose. So there's the Pulse XE, which is designed around abrasive resistance, being able to print Nylon X, that's the goal. Or you have the Pulse HV, which is about high volume output. So it's about making sure that the extruder is strong enough to push out that filament and that the nozzle is large enough so you can have those really thick layer lines. And we're always listening and watching and seeing what sort of items are people interested in. If they call in and say, hey, do you have a printer that can do this? And our answer is no, then maybe that's a point where we need to make a new bundle, and a new bundle with all the features already all put together into one machine so that you don't necessarily need to customize. The customization is always there. You're always able to come in and make a completely unique version of the Pulse. But if you just need something abrasive resistant, the Pulse XE is there, and you don't have to think very hard to choose it.
Alec brings up a really good point, because most people know MatterHackers as being an agnostic place to come and get advice on which 3D printer is going to be right for you. Because we sell 70 different kinds of printers. So why would we come up with our own printer? And I think it's important to understand that we saw a gap in the market for a printer that you can kind of like the Dell computer model. You literally check boxes and customize your own printer, but it comes to you assembled. And it's made in the US, which we've seen more and more of a demand for. So it's really just a good solution for someone that's looking for a printer that only has the bells and whistles that you're really interested in and is specifically designed to your needs. Back to you, boys.
It's like we listened to customers, heard what they wanted, and sort of came up with our own solution. And like everything we kind of do at MatterHackers, this started off by we had to solve our own problems. We were doing some printed parts for people, and none of the machines that we currently offered could, withstand specifically abrasive straight out of the box. Technically, you were voiding warranties and stuff like that. And those machines are great and robust on their own, but we realized that there was a gap in the market. So we're always interested in filling gaps in the market. And Pulse is able to do that, pre-configured, fully assembled, right out of the box, starting at $799. And then you can kind of upgrade your way from there and see the features that you value and really be able to sort of pinpoint the exact machine that you want without having to flash the firmware or do those upgrades yourself, which much of this community loves, and we appreciate. We're still your buddies in providing those specific components as well. And we saw Scott was on here 2 sessions ago, so we've upgraded to Marlin 2.0 in our newest, the 5th generation. We're calling it the E series. Marlin 2.0. So thanks, Scott, for all your hard work, bro. Certainly doesn't go unnoticed with all the, technology and usability that we're able to offer with these machines. It's really awesome. But beyond that, you can just configure it and customize it to meet your exact needs. And we make it here in Southern California, right at Matter Hackers. Send it off on your way. And we strive to get a 0-day lead time so that the day you order it, it goes out the same day. That's what we're hoping to get to. So in terms of like little features, the E-Series specifically has, we're just sort of keeping up with everything open source, obviously, and then adding a few bells and whistles. There's a lot more autonomy in the firmware. So you're able to do bed leveling on the fly, better for print farms. We've seen a lot of people adopting the Pulse platform specifically for larger print farms and wanting to do, just send different G codes to the printer and not have to worry about pre-configured leveling or anything like that. More autonomy on slicing engine. So really you can use whatever software you want, not a big deal. It's 24 volt, so faster heat up time, better printing and consistent heating in both the newly configured bed and the hot end, whichever configuration of hot end that you want. We recently launched the Slice Mosquito on Pulse, and it's interesting. About 50% of the pulses we've sold since we launched that have been the Mosquito hot end. So thanks to the guys over at Slice Engineering for helping and enabling Pulse to absorb those components. Also, E3D has always been a great partner. Bondtex, they all come with Bondtex if you upgrade to the Bondtech BMG or the QR. So really, we're just trying to be a bike shop that knows what components are being purchased out there in the field. And we're happy to sort of pre-configure those machines right there for you. So it's a thing we do. It's not the thing we do, like Mara was saying, but it's something that we're pretty proud of to be able to offer. Did I miss anything, Alec?
Where are we at in time?
I'm not exactly sure, but I think maybe let's move on to materials.
Yeah.
Because a lot of people do. Sometimes I talk to people and I say Matter Hackers, and they're like, "Yeah, you guys make filament, right?" And I'm like, "Kind of. It's one of the maybe sometimes." Let's talk about our Pro Series and Build Series filament for the FDM. Dave, you want to give us an update?
Cool. Yeah, I mean, Build Series and Pro Series, we've always really known that there's sort of many crowds out there in terms of what people are looking for materials. So Build Series, really the number one goal there is to provide really awesome, excellent material with Matter Hackers backing at a price that really can't be beat. So you can get a spool of PLA for 15, Mara knows the details, 15 bucks and something if you buy in bulk. And that's just really something that we're, this community especially looking for. We got silky colors, we got really vibrant colors there, and sourced from overseas, but something that we're still really proud of. We do a lot of QA on and all those things. So Pro Series is something that we can really, that we started offer many years ago, and it's been awesome. We've continued to get tighter tolerances and better offerings, and most recently, we've really started to focus on color. So on the line, we are now using a spectrometer to measure the colors so that from batch to batch, they're extremely consistent. In terms of offering, I think we are working on 87 different Pro Series PLA, specifically colors, and most of those colors will get transitioned into ABS and PETG. Obviously, our line of nylons has some great colors, and we're just excited to be really consistent with colors because we've spoken to so many architect firms and makers and hobbyists who really want this Pantone or this specific thing, and they want from batch to batch to be really, really consistent. So that's something that even if it's off by a small tone or hue, that becomes issues for people printing production parts, and use parts. So
I think Dave, you actually make a really good point as far as where 3D printing is going. Because I mean, we've been here, Matter Hackers started in 2013. I think we've been at 8 million maker fairs or 8.5 million, something like that. And we just, we love our community. We love the makers. And what we've seen is more of the makers with the Etsy shops, like people are really starting to get 3D printing dialed in and be selling like a ton of product that is 3D printed. And it's a beautiful thing to see, because a lot of these people, like we've seen them when they first started and they were buying, you know, maybe 2 or 3 spools a month, and now they're buying literally 100 spools a month. And so something like consistent color is really, really important. And then talking about, you know, Matter Hackers Pro Series, which is actually made in the US, I think what we all saw during COVID, besides, you know, the very unfortunate circumstances of the disease itself, was a shortage of 3D printing filament, because a lot of it was coming from overseas. And so I got a lot of feedback from people that were saying that they were so appreciative that Matter Hackers actually had filament to sell as people were making their PPE. And that's kind of why we're sort of doubling down. One of the reasons why we're doubling down on our Pro Series and our American made printers and our American made filament. Do you want to talk a little bit more about that, Dave?
Yeah, I mean, we were obviously, it seems like partially a lifetime ago, but yeah, we're just so excited to kind of spin up the lines and be able to provide whatever the community is looking for to solve whatever issues we have at that point. And at that point, there was so much PLA and then PETG. I think PETG over those few months grew more and dominated the market in a way that's really unique. I've always thought that PETG would overtake ABS, and that has taken longer than I thought it would. But while we were printing PPE, certainly PETG was moving the needle, and that was pretty cool. We were just so happy to be able to, you know, be partners with everybody that were looking to solve a problem at that point. We, Mara mostly started a whole thing where we started giving away and collecting PPE. Maybe you can talk about that a little bit more, but that was, we shut down sections of Matter Hackers to be able to really help the world at that point. And it's interesting, you know, 3D printing had its window of being a hero there, where I think I look back to my previous job where I was an engineer at a medical device company. And when I left there, I told my boss's boss, like the VP of engineering and R&D, and he goes, a 3D printers, I don't get it. What are you going to do with that? And after 3D printing had its little window in March, April, and May, I think no one will really be able to ask those questions again about like, what is 3D printing? I don't get it, you know, especially technical people. So we're able to kind of step in and really solve problems, something I'm really, really, really proud about. So we're happy to do that.
There was a question in the chat, if you don't mind. The new firmware, is it backwards compatible for the firmware for the Pulse? Is it backwards compatible for the D version of the Pulse?
It is not backwards compatible because the board has changed. So the 32-bit boards are backwards compatible, but the E to D series are actually fully different technical platforms. Hi, Charlotte. Come here.
Aww.
You know, this is welcome to my office, formerly known as my garage.
Hi, Charlotte.
Say hi. Say hi, chickadee.
If anybody remembers, 3 years ago, we had a photo of a little baby inside of an Ultimaker, which was not on and not printing and not heated, by the way. Yeah, this is flash forward.
She has grown.
Charlotte.
Yes. Yeah.
Okay, so we've got 10 more minutes for our time. So if there are any other questions in the chat, please do put them in. Someone had asked if we're going to, they said they love build and they're asking if we're going to be getting more stock. And I said, yes,
always.
We are ordering
Always.
ridiculous amounts of filament right now to meet demand. And thank you all very much for your patience. I've put a couple of things in the chat. We are doing a giveaway, and I've had that giveaway. I've been posting it around since about 8 a.m. And there's a little place for comments on our form. And oh my goodness, thank you guys so much for your beautiful comments. It's just been really nice to even just connect through a form, because you know that's what we're relegated to these days. But we're just so honored to be the place that you go to solve your problems when you're doing 3D printing and you need stuff. So we're really, really happy that you're happy with our customer support and the experience of buying from Matter Hackers and with the stuff that we sell. So, but we'll put that back in the chat again if anybody has not registered for the $100 gift card giveaway. And then I also mentioned if you've got stories and you've got like cool projects that you're doing, we would love to hear about it and potentially feature it in an upcoming newsletter and on our website. So I've just put the email address of community@matterhackers.com if you want to just use that and send us what you're working on, man. We want to see it.
I think before Dave talks about MH Build, I want to embellish Pro Series just a little bit. So I've been walking over to where our product team is reviewing the different colors that come in, and I worked with them just a little bit to kind of come up with some of the new colors, because prior to this sort of relaunch, it was really just, this sounds like a neat color, let's make this. But part of our protocol, we'll call it now, is thinking of like a theme to a different color series and come out with them. So like this in my hand is Regolith Gray. It's gray, it's got a little bit of sparkle to it, and we're coming up with other colors with sparkle in them. And it's all kind of getting science-based themed names to them. So we're really looking at it in the same way that like Silky came out and there was a whole bunch of colors that were specifically silky blue or silky gold. We're doing the same thing with Pro Series, where we're going, this is our sparkly section, this is our, red, orange, yellow, green. And I'm not going to say too much because we got 80 colors coming, but there's going to be good themes to work with that offer some really creative color options.
Yeah, and it's, anybody who knows anything about making filament, which is likely much of this crowd, it's all about the compounding, making sure you're choosing the right colors to be able to process them at a speed so that production can keep up with it and stuff. But we are working, constantly. Usually our compounding house has 12 to 15 colors at any one time, and we're getting chips back so that we can process them pretty quickly. So we're excited. It's a bit of a new endeavor to have that much control and really expand our portfolio in that way. But it's really cool. We're learning a lot, and we're excited to just sort of ride the lightning of Pro Series filaments, which have frankly at Matter Hackers like been this thing that has become a huge part of our business. Like some people, I think in the years past have thought like, oh, Matter Hackers, a materials company, and then started selling hardware. But at our roots, we began as a software company, but giving away free slicing software doesn't keep the lights on. So being able to sort of relaunch and rebrand Pro Series with this highest in the industry tolerance and consistency and in ovality, to be able to offer colors that are hugely consistent. Like really, we have a program written to know how much delta E it is off. If it's off more than 1.5, you can pick it up. If it's off more than 3, you can visually pick it up. If it's side by side, if it's off more than 5, they can be distance apart and you can tell the difference in color. So the hypersensitivity we have and some of the things we've done. We've also built out a whole lab to be able to test the mechanical properties. So the technical data sheets are a thing that are leading conversations in the industry, especially with huge customers, Fortune 500 customers that are asking like, hey, I need a tensile strength of this and a flexural modulus of this. We can now really, the big companies help the makers really succeed at cool things and new opportunities. Polypropylene's been something that has been, I guess, same story as nylon from 4 or 5 years ago, impossible to print. People think it's impossible to print. Well, you have the right build surface and you got the right polypropylene and you got, avoiding some of the colorants and you choose the right colorants, you can succeed with polypropylene quite nicely. So we're excited that the layer lock build surfaces, we've got Garolite, we've got polypropylene, textured PEI, all those surfaces really allow people to succeed at more applications all over the world.
We had a question about color matching, actually, which is something that I know that we will soon be. We can do Pantone filament right now through one of our partners. So if you have a specific Pantone for your business or for your school. We've had schools purchase like their school color. We are able to do that now. And then we will be able to do color matching with our Pro Series filament pretty soon. There was a question about if that's something that we would be looking at for the resins to do a color match.
Yeah, I mean, we have all the control in the world to be able to do that. So right now we have a list of sort of 80, I think 87 or something like that for PLA colors that were, you know, a good majority of the way through. And then we can totally open it to customers doing color matching for special projects. I think the really cool thing is we don't need huge orders for those, for Pro Series, even for resin color matching. Resin's a little bit more difficult because some of them get in that light spectrum and do funny things. So it's not as wide open as filament for sure. But yeah, we can make any color that anybody needs at the end of the day. So.
Once we come out with the product.
Yeah.
The build resin is still, we're still not supposed to even talk about it, but you know, it's VERRF. What are you gonna do?
Yeah, I don't even think we really did talk about it in this, but we're excited to launch a MH build has been filament for the entire history of Matter Hackers, and we're gonna launch an MH build. Again, we're looking to compete at the lowest price possible and get the highest value product. And we have reformulated everything. Anything that you think is, oh, this is resin, it's cool, even if it's cool colors. If you've bought anything that's a resin that says low odor, I would not have that on my desk next to me. Like it's still there's epoxy. They use epoxies. We have an epoxy-free solution. I would print it like under my nose, and I don't hesitate to like use it really closely in you know, obviously for safety, wear gloves, wear masks, be in a ventilated room. But like, oh my gosh, the formulation that we've come up with is really a unique offering in all of resin 3D printing. And it's tuned to work with MSLA and DLP printers. So it should be a lot of customers out there that we should be able to satisfy. We'll have really cool colors to start with, neons plus the standard old white, gray, and clear and black. But yeah, we're excited for that. It's coming. Production starts next week, probably. So,
and if anybody is still, sorry, go ahead, Alec.
Oh, have we teased packaging? Because I may or may not have a test pouch on Corey's desk.
Yeah, sure, go for it. Yeah, we will not offer it in bottles. I think one thing we learned is that bottles, you can never quite get that last little bit out. So we're going to go with resealable pouches. And that they're lined on the inside with a coating that lets you get the last little bit out. It's actually more shelf stable, so it'll last longer on shelves. And it's super easy to use. Once you use pouches, I never go back, frankly. So it's a pretty cool offering.
Shake it.
Ships more reliably. Like you know, we ship a lot of resin around the world, and so many of them break. The pouch is impenetrable essentially when it's shipped in a box. So we're excited for that.
Good stuff.
There was also a question on the chat of where Alec and I got our shirts. So I am going to post a link in the chat to the Phil shirt. And I believe we are officially out of time. So do you have any closing comments, or if Nick or Vicky want to kind of jump back on the
Yeah, I just want to talk to Nick.
Kick us out.
I am popping on right now, Dave.
I miss you.
I miss you too, buddy.
Hugs.
Oh, it's been too long. What, Murph 2019?
Goodness only knows. I was actually grounded like the end of 2019 because I had another baby. So I haven't gotten on a plane since like October last year. It's been a year almost.
Been a year.
I do. I absolutely, and this has kind of been the theme throughout the entire day. Like, I know we're doing it virtually, and I'm glad that we can bring it to the community.
Yes.
But I am missing just that interaction with people, and so hopefully, and I'm very much saying that VERRF2021 never exists. It is back to ERRF 2021. You know, and I'm hoping the same thing for Murph. I got no problem going out to Indiana and seeing everybody there as well. So
we're crossing our fingers. Well, thanks for pulling it off the way you did, for sure.
Thanks for being part of it. It really is. It's sponsors and exhibitors and you guys that make this all possible. And I'm not gonna lie, I saw the resin pouches and I heard you say impenetrable, and it brought me back to like Capri Sun when I was a kid. And if you didn't get the straw in just right, you were never getting into that thing. And I was like, yeah, that seems about right.
Yep.
Well, resin, it's actually like even the bottles, they're HDPE bottles. They're great. They work. But if like you drop it on the cap, which it gets actually most brittle, but yeah, like a Capri Sun, if you rifled it at a wall, like it doesn't actually burst. The pressure just like finds new corners to get into. So yeah, the pouches we're excited about. I think it's a little bit of a game changer.
That may have happened once or twice in college where Capri Suns ended up against walls and didn't splatter. But that's a whole different story for perhaps VERRF after dark, or definitely some beers after an event sometime.
Sure. Well, speaking of which, I need refills of the Pennsylvania lagers.
I see that. Yeah.
I'm excited for VERRF After Dark. I will be there. I think Jen Schachter and I are going to be talking at like 9-ish. Well, 9-ish your time.
Excellent.
Yeah.
Well, thank you guys so much. It was great to have you guys on. I do miss you. Virtual hugs.
Virtual hugs and spirit fingers.
And these are spirit fingers, and these are gold.
I'm more jazz hands, but I'll take it.
All right, guys.
Nice. Well, thanks, guys. We miss everybody.
Thanks for having us.
Bye.
Good being here.
All.
Thanks, Vicky.
See ya.
All right. And for our final speaker of the afternoon, ladies and gentlemen, I give you somebody who, I'm not going to lie, I'm super excited to hear because I love food way too much. And so I am bringing on Mr. Cocoa Press.
Hello.
Evan, take it away, my man.
Awesome. Let me see if I can share my screen here to get the presentation up. Okay. Can you see it full screen?
I can see it full screen, Evan.
Awesome. Oh no, I am streaming the YouTube in the background. Let's stop that. Okay, awesome. So, hi everyone, I'm Evan Weinstein and I am the founder and CEO of Cocoa Press. Cocoa Press is creating a 3D chocolate printer. So, why am I here talking about 3D printing food at a RepRap festival? 3D food printing is, by definition, not a RepRap. That is, it doesn't self-replicate. However, the first 3D food printers were being created at the same time as the early RepRap project. As an aside, if anyone does create a 3D printer out of food, I absolutely need to see it. Both the Fab at Home and the RepRap project were started in 2005. Whereas RepRap was looking to make a self-replicating machine, Fab at Home was more focused on getting 3D printing to the masses. They saw a future of 3D printing, which used a wide variety of materials, so they designed a syringe-based dual extruder. This let the Fab at Home print everything from silicone rubber caulk to epoxy, gypsum plaster, and then cheese, frosting, and even chocolate. I did a lot of digging and I found a gem in the RepRap forum where people were asking about the differences between the two projects. From the forum, people liked the sturdiness of the laser-cut Fab at Home frame and the precision of the gantry, but preferred the reliability of the plastic extruder on RepRap printers over the syringe-based extrusion of the Fab at Home. And you can even see their design influence in the early MakerBot printers that used the laser-cut wood frames. But still, the Fab at Home, it was the first food 3D printer, and I have to thank them for that, of course. Evan Malone, one of the founders of the Fab at Home, created NextFab, which is a makerspace about 5 minutes down the road from my office here in Philadelphia. In 2012, the goals of the Fab at Home project had been achieved, and so they shut down because sales of consumer printers were outgrowing the sales of industrial printers for the first time ever. So the benefits of printing food are actually very similar to the benefits of printing plastic. It all comes down to customization. With 3D printing, there are no mold costs, and for the most part, complexity is free. 3D printing is incredible for rapid prototyping, but it can also be used to create final production parts. One example is Adidas and Carbon, who are teaming up to 3D print shoes. Previously, Adidas had to run batches of a minimum of 10,000 shoes before it made economic sense. And if you combine that with the 4 to 6 weeks to make a mold and the dozen sizes they have to stock, no wonder they're looking into 3D printing. 3D printing, as we all know, is also just an incredible hobby. The quality of parts that we can make for just a relatively small investment in equipment is still mind-boggling to me. Among other things, 3D printing is a great educational tool. It's a wonderful introduction into engineering, and it allows teachers in any field to take a complicated topic and make it into a physical object for students to touch. 3D printing allows learners a new tactile dimension to their education. Many of us have also experienced a combination of these benefits when we sprang into action this March and printed hundreds of thousands of pieces of PPE and saved lives. Now, food 3D printing has many of the same advantages. Food printing, like plastic printing, comes down to customization. The main 3 ways I see food printing changing the culinary world are in personal health, environmental impact, and in personalization. But before we talk about these in depth, let's discuss what makes a food 3D printer different than a regular FDM printer. Here's some major considerations using a sneak peek of the CocoaPress printer that we are launching today in about a half hour on the other channel. First, just about every food printer uses a cartridge instead of filament. And these are usually either a reusable stainless steel cartridge or a single-use plastic syringe. Many food printers don't have a heated extruder at all because they're printing various purees. On the other hand, chocolate printers need to have extremely precise heating temperature, extremely precise heating control to maintain the chocolate's temper. Food printers also, of course, have to be designed with sanitation in mind. For us, that means that anything the chocolate touches has to be removable without any screws. Food printers have to be easily cleanable and not have any place where food can get caught. Although most food printers are not enclosed, one of the things I'm proudest about in our printer is the cooled build enclosure, which lets the chocolate very quickly solidify. Now that we know what makes food 3D printers different, let's talk about their use cases a little more in depth. 3D printing is in the early stages of being used to improve people's health. And one example of that is to help people with dysphagia who have difficulty in swallowing food. In some cases, they need to eat purees for extended periods of time. Pureed food often has an unattractive appearance or lacks variety and has a diluted taste. But 3D food printing allows the pureed food to look like the original ingredients while being safer to eat, like the photo on the left in this slide. It leads to a better sensory experience and more enjoyment of meals. For something that you do 3 times a day, it's important to enjoy the meals you eat. The US Army has also done years of research into 3D food printing for customizing nutrients in soldiers' foods. If combined with wearable sensors, meals could be custom made to include the necessary vitamins, minerals, or stimulants depending on what the person needs that day. Food 3D printing is the ultimate form of individualized manufacturing, which will increasingly be used to improve the health of people around the world. One of the uses for food 3D printing I'm most excited about is for the environment. The consumption of meat has a huge effect on climate change. According to Redefine Meat, more fresh water is being used to raise cattle than is being used by all humans combined. More pollution is emitted to produce beef than by all cars on the road. And it's created a huge race for fake or alternative meat products like the one you see in this photo. That's not a real steak. At least there's no real meat in it. Companies like Beyond Meat and Impossible Foods have been making huge strides towards these meat substitutes, but there's a reason they're both creating hamburgers. Mimicking a steak like this one is a much more challenging task because of the internal structure. Redefine Meat is 3D printing using fat, blood, and muscle to mimic the marbling and taste found in various cuts of steak, all without using animal products. They're aiming to print 44 pounds of meat per hour by 2021. And this quick video shows their process. And my absolute favorite use case for 3D food printing is for personalization. The US is in a transition period from mass manufacturing to mass personalization. From sellers on Etsy to Coke placing names on bottles, companies are looking for new ways to engage their audiences. 3D printing lowers the barrier of entry to customizing food. You don't have to be a chocolatier to make delicious cake toppers, as seen in the first photo here. 3D printing is not going to replace traditional artistry. It's just another tool It's just another tool in the tool belt of ways that companies can differentiate themselves. I expect both food printing and traditional artistry to continue to expand, much like the art of painting has continued to grow alongside photography. Personalization can refer to making people's names or printing a scan of their face, but it can also refer to textures and flavors. Have you ever wondered which infill pattern tastes the best? Think about it. I printed the designs in the photo on the top right of the screen, and I can tell you from experience, the gyroid infill wins. 3D printing food allows for new sensory experiences that have not even been thought of yet. Complexity is free in 3D printing. There's no mold costs, so you're only paying for the material. Food printing can be in a high-end restaurant or in your kitchen. The bottom left photo is the Pancake Bot. The Pancake Bot lets you make pancakes in any shape. And one of my favorite features about it is that it uses cooking times to have 4 different colors. Miguel, the creator of the Pancake Bot, has been super kind to me and actually inspired me to start working on food printing back in 2014. In the future, I expect 3D food printing will continue to expand into unique flavor combinations to create interesting and unique delicacies. And to start wrapping it up, customization in 3D food printing is just going to allow for a huge shift in the ways we interact with our food. We can live healthier lives. Those with swallowing disorders will be able to eat better, and bespoke meals can be made with varying levels of nutrients. 3D printing will be vital to enable the creation of realistic tasting meat and help avoid the further pollution of our environment. It's going to allow for personalization that is currently impossible with food. Even an individual with no knowledge of culinary arts will be able to experiment with unique flavors, textures, and shapes. And again, I'm Evan Weinstein, the founder and CEO of CocoPress. I've been working on 3D printed food 3D printing chocolate specifically, since 2014, and have presented at the Philadelphia, New York, and even the Rome Maker Faire. This photo is from ERRF2019, and I can't wait to be back in that building in 2021. We are launching our chocolate 3D printer right after this on the sponsor and exhibitor channel, and have a high energy, exciting 7 minutes plan. So I definitely recommend heading over there. And yeah, I hope you're able to learn something about food 3D printing, but I'm here to answer any questions you may have. So drop them in the YouTube chat. Let me see what you all have been saying.
So just watching the YouTube chat as you've been talking, Evan, and trying not to drool all over myself as I'm seeing different types of food. I mean, I think big takeaway has been just kind of the amazingness of what's happening with food 3D printing. I mean, you threw some facts and figures in there that I was completely unaware of, which was awesome. I saw a comment in the YouTube chat regarding gyroid infill for the win. I didn't think there was ever actually a doubt. I was pretty sure that gyroid would be the victor there. And then it's kind of a question, benchy burger?
I'm totally into it.
I'm thinking there's a way to make that happen, right? Like the hull, part of the hull is the burger and then, or the bun, and then you go up a little bit and you get burger in there, and then you kind of get that.
See, I think you print every part of the burger. And so you can have the bread in the shape of a benchy, like almost a candy type of thing. So that from top down, it just looks like a benchy through and through.
I got you. So you're thinking about it, I'm going to say kind of like in the 2D sense, where you print like a bun, that's a benchy, and then you print a burger, that's a benchy, and then you print another bun.
It would certainly make it a little bit easier to eat, at least.
That's a good point. I was just thinking like, we're going to print straight up and it's going to be bun and burger and then more. Okay. I like your thought process here. Just what else am I seeing in here?
I haven't printed a cake, but this Mr. and Mrs. Wonka cake in our launch video that we'll be showing in a few minutes, this is a cake topper that we made for it. But yeah, no, it's really cool. I think there's way more uses for food 3D printing than people generally realize. Even doing research for this talk, I learned so many things that I didn't previously know. Because, I mean, you know how the rabbit hole of Wikipedia gets.
Yeah. Absolutely. Well, Evan, I know that they are running a little bit behind on channel 1, but you've got some pretty big stuff to be talking about over there. And I'm not gonna lie, we kind of got a little bit of a spoiler here for us when you were talking about it. And I was like, that's right, spoilers coming from the build platform. But
always.
I'm going to let you run, Evan, so that you can run over there and make some form of announcement, I suppose.
Awesome. Yeah, we gotta get some balloons out, and we have a fun 7 minutes planned. So be sure to head over there and also start coming up with questions for us on that side, because we'll be doing some fun Q&A as well. But thank you so much.
Thanks, Evan. It was awesome.
Awesome. Great talking to you.
Bye.
Well, that was fantastic.
Yeah, right. Oh my, I had no idea that there was a company that was printing out, what is it? It's like 13 pounds of meat a minute now, but gonna be 44 pounds of meat. Or, you know, the way that they were 3D printing like the marbling and the blood and the
Yeah.
meat to really the fat. Like, I was like, are you kidding me?
With apparently Simplify 3D.
I saw that too. I was like, ooh, Simplify 3D. Okay. You know, things will change, I'm sure. maybe not. But with that brings us to our last speaker. That was our last speaker of the afternoon. So Build Platform Day 1 has wrapped up. Vicky, last words before we...
Thank you, everyone, for watching and your comments and your questions for our presenters and staying engaged. Thank you.
I think that is awesome, Vicky. I totally agree with you that, you know, the questions, the comments, everything that's come out of the chat has been awesome when we're talking about and talking with our presenters. It's been great to have that interaction, and it's been just phenomenal from my standpoint. I love it. And Vicky, I've got to spend the day with you. So,
Yeah.
you know.
It's probably well, yeah, because we're always in different parts of the arena. So this is probably the longest amount of time we've stayed together.
I would say that is
And
probably
then we have
correct. Yeah.
tomorrow too. We'll be back tomorrow at 11:30 a.m., right?
11:30 a.m. Eastern time for Slice. Yes. All right. I don't know about you, Vicky, but I'm going to go join in on channel 1 and see what's going on there. I heard there's going to be some kind of announcement about some kind of food printer that might be released.
All right. Goodbye, everybody.
Bye, all.